Welcome everyone to the St. Lawrence River Institute's 29th Annual River Symposium. And I'd like to start the day off by respectfully acknowledging that I am speaking to you on traditional territory of the Haudenosaunee, and all of you, I'm sure, are on the traditional territories as well of other Indigenous peoples. We offer our gratitude to the Mohawks of Akwesasne for the care and teachings about our earth and our relations. In honoring those teachings, we are committed to the process of dismantling the ongoing legacies of settler colonialism through good relations with each other and the lands we live and work on. The River Institute was founded in 1994 in a unique partnership with the Mohawk Council of Akwesasne, together with other members of the local community, including the City of Cornwall, United Counties of SDNG, and many local citizens. About the St. Lawrence River and other freshwater ecosystems. The River Symposium was the Institute's very first science and community outreach event. And for the last 29 years, the event has provided a platform for researchers, educators, policy makers, community leaders, and citizens to come together to discuss the health of freshwater ecosystems and to explore challenges facing our large rivers and their watersheds. This year's theme is Ways of Knowing. With guidance from our partners at Akwesasne, we wanted this year's symposium to focus on celebrating the many ways that people know and relate to the river and the natural world, including Indigenous knowledge holders, artists, scientists, and community members. We hope that bringing these different perspectives together will enrich our work and help foster collaborations to care for and protect our freshwater ecosystems, as well as the communities that they nourish and support. So this is day 2 of the symposium, and yesterday on day 1, we saw these themes coming together with talks by Henry Lickers, Jerome Marty, Jean-Louis Corteau, and sessions that brought together scientists, artists, and representatives from many different organizations that have some sort of aspect in their work to deal with our freshwater ecosystem. And today I'm excited to hear from another great group of speakers and from diverse opinions and insights, including, for example, Jessica Jock, who works with the St. Regis Mohawk Tribes Environmental Division and is well known to many in this area, as well as Kathleen Vaughan. She's professor of art education at Concordia University and a research chair in art and science for sustainable futures. And these sessions that they're involved in will also cover other many topics, including citizen science, environmental education, and invasive species research. So before I hand it over to Georgia, Georgia Bach, who's with me, I would like to thank all of our speakers for joining us and acknowledge the organizing committee for all of their hard work, and also building on this unique sort of event where we had in person and now moving into our online event today. I'd also like to thank our sponsors for making this hybrid event possible: Seaway Development Corporation, Minimax Express, Ingredion, the St. Lawrence Seaway Management Corporation, Ontario Power Generation, and the IJC, or International Joint Commission. So at this point, welcome. Hope you enjoy the day, and I'll pass it to Georgia for some housekeeping. Georgia?
Thank you, Jeff. Yeah, so I'll just cover a couple of quick points. So this will be, you are watching us live on YouTube right now. So if you'd like to ask questions throughout the day, you can just enter it in the YouTube chat, and we'll be monitoring that throughout the day. So we'll be sure to ask your questions at the end of each session. We will have 4 sessions throughout the day, and we will have lunch from 1:50 to 1 p.m. And yeah, we're just looking forward to a great day. And I'm going to introduce you, as we're about that time, to Laura, our first session chair from Water Rangers. So go ahead, Laura, take it away.
Ready to go on. Good morning, everyone. I'm Laura from Water Rangers, and I want to welcome you to the session today, all about citizen science and participatory science. And we have 4 amazing speakers today in the sessions. The first one is Gabby. She's the director of Water Rangers and my coworker, and she will present a business case for community-based water monitoring. So take it away, Gabby.
Thanks so much. Good morning, everyone. My name is Gabby Parent-Doliner. As Laura mentioned, I'm the director of Water Rangers. And I'm joining you today from Toronto, which is a traditional territory of many nations, including the Mississaugas of the Credit, the Chippewa, the Haudenosaunee, and the Wendat peoples. And it's now home to many diverse First Nations, Inuit, and Métis people. So I'm truly honored to be presenting the business case for investment in community-based monitoring to you at the River Symposium this morning. And I'm presenting on behalf of the National Community-Based Monitoring Collaborative. So I'm wearing a different hat today. So it's so incredibly valuable and useful research. And it was written actually by Jeff Ridal but from the International Institute of Sustainable Development. And it was written on behalf of that national collaborative that I'm going to introduce in a moment. But I am going to be short on time. And to do this case justice, the biggest thing that you could do is actually at the end access the link and really take a look at it, whether you're an investor, whether you are doing community-based monitoring. It is a treasure and it is a resource. So please reach out to us afterwards if you would like more info, just to make sure that we have time for this today. So first, just a little quick intro on the Community-Based Monitoring Collaborative itself. So it was formed in 2020. It is a national collaborative, and it was formed at the same time that the federal commitment to developing a Canadian water agency and the potentially national freshwater science strategy that had come to the forefront. So this national collaborative works together to raise the profile of CBWM. So that's, I'm going to say CBWM a lot. That's community-based water monitoring in Canada. And it advocates for its credibility at the federal scale with activities like federal advocacy, securing funds, and a national network. So the collaboratives knows that we need to make this case for investing in CBWM if we are to protect water at the scale that matters to each of us. So this report, as I mentioned, it's a treasure, and it offers a lot in terms of understanding the value and the return on investment of CBWM. So in this new report, just briefly, why is it cost-effective and scientifically rigorous way for Canadians to collect data on the quality of fresh water across their watersheds, how we need to coordinate and fund these efforts, when to take action, and what the role of the Canadian Water Agency should be. And it really couldn't come at a better time. There's an incredible urgency to make this case. So we need to ensure the value of community-based water monitoring is understood by investors, governments, and communities so that more of these programs can be renewed and expanded. Our water in Canada is in crisis. And while our society and economy depend on the services provided by water, many of Canada's darkest challenges can be framed in terms of water. So to find solutions and adapt, we need to understand what the human impacts are of our current, past, and future actions and how they're affecting water. But here's the kicker. Unfortunately, the very act of taking stock is nearly impossible to do for most Canadian basins. So this is probably familiar to you if you do work in the water monitoring world. This is a snapshot of WWF's 2020 Watersheds Report, and it's one of the cornerstone researchers used in the business case as well as in a lot of research. So the WWF investigated, or at least they tried to investigate the health of Canada's watersheds, and what they found was that 100 of Canada's 167 watersheds are data deficient. That's 60% of them. So what does that mean? Short on time, so I'm going to quote Jeff here. We can't even make a broad assessment about what the heck are even threats to these watersheds. So even for many of the watersheds that do have a health score, our understanding of the state and trends is limited, and with many of the data sets either out of date or in decline for their collection. So the responsibility of a considerable amount of water management in Canada has fallen on community members themselves outside of the provincial or federal structures. So you could see here, since the 1980s, there's been actually a dramatic increase in CBWM programs. And this survey of CBWM groups is from an amazing piece of research. Also suggest that you access it. And it's called a snapshot of community-based water monitoring in Canada from 2017. So it shows that since 1998, CBWM groups have dramatically increased and are continuing to grow exponentially. So this only goes till 2016. If we looked at this today, we don't have the numbers, but it continues to increase. The study found that community concerns about the health of local rivers and streams and lakes and a desire to be more involved in water stewardship accounted for a large portion of this increase. So the CBWM network across Canada, it's vibrant, it's expansive, and it's strong. Open source data hubs, monitoring tools, training, and regional networks, they're growing more accessible every year. So the diversity of partnership in the CBWM network is also starting to reflect the diversity of cultures within these watersheds as well. For CBWM to thrive, we need to understand the full value these community-based efforts provide to coordinate these efforts nationally and to fund them properly. So the purpose of the business case is really to do that. It's to communicate both the tangible and the intangible value that community-based water monitoring, And again, this is such a rich resource. I cannot do it justice. It's very, very thick. So please do take the time to access the link today. So CBWM reflects community needs and desires to channel their enthusiasm, their energy towards supporting better science and better policies. But for this mode of monitoring to thrive, we must understand the full value these organizations, these First Nations, these community groups that they're providing. So how do we make the case for sustaining and growing CBWM? Value for money. We need to demonstrate that any investment in CBWM is worthwhile and it contributes to protecting our environment. So we have the task of making sure that value is seen by investors and by our federal and provincial and local governments. So that's what this business case, it does really well. It translates the values so that they are tangible. Local level partnerships are delivering the raw materials for informed decisions. And these would not have existed otherwise if this hadn't been done. So the raw materials generated by CBWM programs are the data and the information products. These represent the most tangible outputs and are a way to demonstrate the value of CBWM. So fortunately, valuing digital assets has recently become a topic of considerable research in the business community. So, and this is the 2019 statistics. So Statistics Canada conducted an evaluation of the value of nonprofit data in Canada. Researchers estimated digital assets in the nonprofit sector ranging between Canadian dollars here, 2.5 billion and 3.4 billion based on investments made to obtain and store these assets. So CBWM data is being used by federal agencies, local decision makers, in courtrooms and classrooms to advance knowledge and understanding. Going to get into some business here. So this is how the values were calculated in the business case. So it's based on the PricewaterhouseCoopers list. These are the 3 approaches, and there's also 6 methods for evaluating the value of these data sets. So these approaches that Jeff used estimated the value of the data for CBWM products. So there's the income approach. So essentially that means how much does CBWM increase the organization's value? Then there's the market approach, and that is what value does the data fetch on the market? And then finally, the cost approach. How much would it cost somebody else to do what a given CBWM program organization did, and how much would it cost to acquire? There are three cases that are looked at to give examples here in the report. I'm going to rush through one and suggest that you look at them. So the one I'm going to look at today is all the way on the East Coast, and it's the long-running Clean Annapolis River project, which developed a long-term data set on the Annapolis River and its tributaries to protect and preserve one of Canada's most historic rivers. So this is just an example of looking at the value. So briefly, the return on investment for the Clean Annapolis River Project's efforts to answer their driving question. So their question was, how can the community of Annapolis, Nova Scotia, protect the Annapolis River estuary and their local economy? From the inception in 1991 until 2019, the Annapolis River Guardians program was composed of a group of volunteers, guardians who collected river samples at stations located sort of at convenient distances from their homes or their places of work. So as of 2020, this data set had grown to over 15,000 records for the 8 sentinel sites along the Annapolis River, and number of occasionally sampled tributary stations. So the annual cost to simulate the entire ACAP, which is the acronym program in Canadian, would have been $14,461,000, with a 5-year cost, again, Canadian dollars, of $71,049,000. But the actual funding to OCAP over the 5-year period was only $6,100,000. So this represents an 11.6 to 1 return on investment over conventional delivery. So I'm going to just be sort of wrapping things up here, and just a review of what the summary of the business case and a link there. And please do connect with us after to get the information and use this as a resource for yourself. So the business case found that the differences in jurisdictions, community capacity, and above all geography had created a fragmented landscape of the state of water monitoring in Canada. Monitoring based in each community, but connected to regional networks, can generate the data we need to prepare for a changing water future. And looking at these business cases and other community-based monitoring efforts, it found that it's cost-effective, at least 3 to 1, and scientifically rigorous method to collect medium and long-term water quality data at the watershed scale. And finally, community-based monitoring reflects local concerns to inform local action. So the big takeaway here is that monitoring is a program and not a project. Funding and the funding model should reflect this. It has to be long-term core funding to sustain this. And this is a symposium on ways of seeing. And I think it's really important to end here that CBWM groups, they should not be looked at as a less expensive consultant. Instead, they are partners in water stewardship. These are the eyes, they are the ears on the land and water in a way that governments and other programs cannot be. They're not able to do. So I want to thank Jeff for this amazing report. They are you can see the link down here. Please connect with me, or I can also connect you with other members of the community-based water monitoring collaborative. You can get involved, and this is a resource for you to use to incorporate to make the case for community-based monitoring. So thank you very, very much for your time this morning. This is my email here, and I'm going to pass it back to Laura.
That was so great. Thank you, Gabby, for that presentation. Up next, we have Bailey Bedard, a bat research technician at the Canadian Wildlife Federation, and she'll tell us all about the Canadian Bat Box study. Take it away, Bailey.
All right. Hi, everyone. I'm Bailey. Today, I'm going to be going over PhD candidate Karen Vanderwolf's Canadian Bat Box study and discussing different ways that you as a citizen scientist can be involved in the project. So bats are a very diverse and ecologically important species. Our bats in Canada feed exclusively on insects, and they save Canadian agriculture an estimated $30 million each year in their pest control. But they're faced with a lot of threats. So from habitat loss, wind turbines, diseases. One of the more well-known diseases is the deadly fungal disease known as white nose syndrome. Ever since this fungus was introduced into North America, it's spread and decimated bat populations, landing 3 of our Canadian species on the Species at Risk Act in 2014. And ever since their population started to decline drastically, efforts to decrease the effects that other threats that these bats are faced with have increased significantly. And one way to do this is to provide and protect bat roosting habitats. And a method that people often use is bat boxes put up on their property, which is thought to act as compensation habitat for the bats, boosting their survival and increasing their reproductive success. So in Canada, these 3 bat species here are known to use bat boxes as maternity roosts in the summer. But other than that, not much is known about what bats use bat boxes throughout Canada. There has been research done in other areas of the world, but the knowledge gap that exists in Canada is something that needs to be addressed. Bat boxes in Canada are often designed because of our colder climate to have high internal temperatures so that they're providing a warm quality roost for bats. But with climate change, there's now a growing concern that our bat boxes throughout Canada have a risk of actually overheating on our hot summer days. So there's this threshold of 40 degrees Celsius where bats then start to experience an increase in their internal body temperature and are at a higher risk of mortality. So understanding how factors like temperature affect the successfulness of bat boxes acting as compensation habitat is a very high conservation priority. So when it comes to bat box designs, there's a lot of variability. Oftentimes you'll see DIY boxes or commercial boxes that are built similar to this design. But you also have the rocket box design down here, larger bat condos, and there's even some bat boxes made out of cement. And bat boxes can also vary in how they're installed, so how high up they're installed, which way they're facing, whatever they're installed on. And all of these factors might have an effect on the microclimate of the box and its likelihood of becoming occupied. So the objective of our study was to fill that knowledge gap that exists in Canada to help inform the recovery of our endangered bats throughout Canada and address that increasing threat of habitat loss. So to do this, we're aiming to answer a set of key questions. One being, what types of bat boxes are being used throughout Canada? And is any one design more likely to become occupied by bats? Does microclimate vary across Canada within bat boxes based on geographic location, their placement, their style? And do any of these factors relate to overheating events of bat boxes? So by answering these questions, we'll be able to determine and promote the most optimal bat box design to use throughout Canada regionally, while also identifying new maternity roosts and promoting the importance of citizen scientists reporting their bat observations publicly. So over the past 2 years of this 3-year study, we've collected bat box data through unpublished data, citizen scientists, and regional collaborators. So participants would first register their bat boxes to our study by filling out this bat box detail survey. It just asks questions about the physical parameter of the bat boxes. And then they would be provided instructions on how to monitor their box and this bat count survey, which is a place where they can report their monitoring efforts throughout the field season. They were also given the option to receive temperature and humidity data loggers, which you can see in these photos here, that they would install in their box. And this photo here shows where the data logger would sit within the chamber of the box. And they were also given the option to receive guano kits to sample the guano in order to determine what species is occupying the box, and a swab kit to swab the occupied boxes to test for the presence of the fungus that causes white nose syndrome. Participants who received those supplies were chosen based on their geographic location, their willingness, and the occupancy of their box so that we were maximizing our geographic coverage of occupied and unoccupied boxes. And the data logger would record the overheating events. And to document the effect of overheating events, we asked participants to monitor their box on particularly hot days and document any signs of heat stress they noticed the bats to be exhibiting, if any. And this is a map to date of how many bat boxes we have registered in the study across Canada, the black squares being unoccupied boxes and the blue triangles being occupied. So with our initial data we received in 2021, we did a very preliminary analysis. At that point in time, we had 1,033 participants who were reporting for a total of 1,372 boxes. And only 19.7% of those boxes were occupied, suggesting inefficient design or just low bat population densities. So then we looked at the different factors that might explain the likelihood of a bat box being occupied. And the first one we found was that bat boxes installed in rural forested areas were more likely to be occupied by bats than those installed in urban areas. Bat boxes that were installed on buildings were more likely to be occupied than bat boxes installed on trees. And bat boxes that had bats inside of it tended to be larger in size compared to bat boxes that didn't have any bats living inside. Next, we looked at the temperature and humidity data. So what we found first was that the front chamber and the back chamber differed significantly in their temperature and humidity, where the front chamber, being more exposed to the sun, was more likely to reach warmer temperatures and was at a higher risk of reaching over 40 degrees. And then we looked at different factors of a bat box that might increase that likelihood of it reaching an overheating event over 40 degrees. So the first one we found was color of the box, where black boxes were more likely to reach over 40 degrees than the lighter colored gray boxes. Bat boxes that were installed on buildings or poles, which are plotted in the black, pink, and yellow points, were more likely to reach over 40 degrees than boxes that were installed on trees, which are pointed in this teal color. And finally, bat boxes without any vents plotted in black were more likely to reach over 40 degrees than boxes plotted here in yellow. So the yellow boxes would have vents on both the front and sides of the box, promoting airflow. So with that, we came up with this very preliminary, again, it's only based on data from one field season, an ideal bat box design. So we're suggesting that you install the bat box in a rural forested area by attaching a bat box that's larger than 200 square inches to a building. And although the other factors we tested for didn't prove to be significant factors in explaining occupancy, we did make a few more recommendations that we think might increase your chances of your bat box becoming occupied. So our data showed that bats preferred warmer boxes despite those boxes being more at risk of reaching an overheating event. Which is why we believe that they prefer the larger boxes, because those boxes have more room for temperature variation within the box. So the bats can kind of move around within the box depending on what temperature they're looking for. So with that being said, we don't think that having just one box is providing the bats enough variation that they need. So we suggest having a network of boxes that vary in height and aspect in order to increase the temperature variation for them so they can move around depending on what they're looking for on that specific day. Again, to increase that temperature variation, having boxes with more than a few chambers also allows bats to kind of move around within the boxes, looking for their perfect temperature. Having vents on both the front and sides of the box increases airflow within the box and prevents overheating events. And we suggest to avoid installing your bat box on a tree, as we think that boxes on trees didn't reach warm enough temperatures, and explains why those ones were often not occupied compared to boxes installed on buildings or poles. And so, like I said, we're moving into our third and final field season in 2023, and we're looking to increase our sample size of both occupied and unoccupied boxes across Canada. So if you or you know anyone who would like to get involved, you can go to helpthebats.ca, and there you'll find the link to the survey I was talking about to register your bat box, where you answer questions about the physical parameters of the box. You'll also find a link to instructions on how to monitor the box and the survey of where to report your monitoring efforts to our lead researcher, Karen. If you don't already have a box, but you'd still like to get involved, there's also links on helpthebats.ca of DIY plans to build a box. If you prefer to buy one, we have a checklist of what to look for while shopping. We also have a checklist of things to look out for when installing the bat box. And once you have it installed, you too can then register those bat boxes or bat box through that initial survey. We also have just general information about bats on that website. And if you want to participate in a more long-term monitoring effort of bats, you can go to batwatch.ca and additionally register your bat box or bat boxes there, and report any bat observations you make. And that goes towards the long-term monitoring of bat population trends. I also have my email there if you have any questions about the study. And with that, I'd like to acknowledge and thank our sponsors and partners, as well as all of you for listening. And I'll be happy to answer any questions you may have in the question period. So again, thank you all for listening, and enjoy the rest of the symposium.
Thank you so much for that, Bailey. I had heard a little bit about the program, but I'm so glad to hear how it's turning out and some of the conclusions that you shared with us. So thanks again for that. So as Bailey mentioned, there will be a question period at the end after all speakers have spoken. So make sure to write your questions on the YouTube live chat so we can ask our speakers at the end. So up next here, we have Larissa Holeman. She's the Ottawa River Keepers Director of Science and Policy, and she'll talk to us about including citizen science when assessing river health. It's all yours, Larissa.
Thanks, Laura. It's great to be here this morning. I'm just gonna share my screen with everybody. So, as Laura mentioned, I work at Ottawa Riverkeeper. I'm the Director of Science and Policy. Ottawa Riverkeeper is a charitable organization that works to protect, promote, and improve the ecological health and future of the Ottawa River. We work in a number of different ways, but we ground all of the decision-making that we are doing in a science-based decision-making process. We are an organization that's connected nationally and internationally as a Waterkeeper Alliance member. There's hundreds of Waterkeeper groups throughout the world, many of them in the US, but we learn from those organizations, but we also learn from many different freshwater organizations across Canada and have benefited from those relationships. Due to our diversity of funding, we have been able to keep an independent voice and are able to speak up at a variety of different issues. And we work across jurisdictions. We tend to be solutions oriented, and we try to be collaborative as an organization. So just to give a little bit of a picture about Ottawa River Keeper and the Ottawa River itself. The Ottawa River is over 12,000 kilometers long. The watershed is twice the size of New Brunswick. It is a large watershed, and it's hard to travel through it to get an understanding of what's happening in different areas. The watershed is also the unceded, unsurrendered territory of the Algonquin people. And this is just to give a sense of how the territory overlaps very nicely with the watershed itself. And so we try to work collaboratively with Algonquin communities in the watershed and continue to find ways to address different concerns that are brought about water issues. There are a number of threats to the Ottawa River industry. A number of industries are located along its shores. There are municipalities that have significant combined sewer overflows. We have the Chalk River laboratories within the Ottawa River watershed, but right on the shores of the Ottawa River. And so there's legacy waste issues and new developments happening at that site. So that's a continued threat to the river. There are a number of dams throughout the Ottawa River itself, but also within the tributaries. And with the shoreline development, as populations grow, we see threats to habitat and stormwater runoff. Another threat, which is maybe not as obvious, is just how complicated the jurisdiction of this watershed is. The Ottawa River forms the border between Quebec and Ontario for much of its path. There is also a federal jurisdiction for much of the Ottawa River, depending on the issue that you're trying to address. And there are a number of different ways that work is done on either side of the river that is not, they're not similar. And so there's different approaches to either sides. There's limited information sharing. There's no watershed management plan. And we have a lot of turnover for people who are in leadership positions, such as elected officials, which makes it very challenging to work within. Taking all of that information and experience of working within the Ottawa River and the Ottawa River watershed, Ottawa Riverkeeper completed an initial study to understand the health of the Ottawa River watershed. It was a scan of what was happening in the landscape in terms of data, and it was assisted through our Watershed Health Committee. It identified that there were numerous data gaps, that there are different metrics used to measure data. So depending on who is collecting the data, they're using different ways for that data collection, and that data is being reported and shared in different ways. And so even just gathering the data together became one of the key takeaways from that project. I'm just going to wave at Laura and say, I forgot to start my timer. So if I'm getting a little bit long, just wave at me. Sorry, everybody. So through that initial study, we did, Ottawa Riverkeeper put together this concept of starting a watershed health assessment and monitoring initiative. Through that initial study, which included the Watershed Health Committee, but a number of other partners, and including a work with an Indigenous liaison and talking with all of the Indigenous communities in the watershed, we came up with 14 indicators to help measure watershed health. We really wanted to strongly emphasize the importance of community science and community based monitoring. And some examples of indicators that work really well for that is the ice on, ice off observation, invasive species monitoring, algal bloom monitoring and sampling, phosphorus, and chlorophyll A monitoring. So there are 14 here. I'm not going to get into all of those. I'm going to focus on the community science ones. Why did we include community-based monitoring in this project? First of all, we have a history of working with community scientists. We have a River Watch network that had been collecting data on the river since 2013. We've seen how rich that data collection can be and how helpful it can be for getting to hard to reach areas. As I mentioned earlier, the watershed is large, so we need help monitoring throughout the watershed. But we also have seen the benefits to individuals when they are helping to provide data. They also provide additional information, so we learn more and more about what's happening in different parts of the watershed. We also found overwhelming support for community-based monitoring and people's interest in participating when we did targeted calls for people to monitor, so specifically doing ads and outreach to areas where we knew there were data gaps. We had the first year we did it in 2021, we had 150 respondents, and in 2022 we had over 200 people who signaled that they were interested in participating, not just by saying I'm interested, but filling out the form and providing lots of information about how they wanted to participate. And also another really important reason for including community-based monitoring is the fact that participants become awesome advocates for their river. They learn about what's happening in their local waterways, and they want to learn more, and they want to share that information with people. And I think that's a really critical part for community-based monitoring, is the advocacy that it can create within local neighborhoods. So here's just a quick scan of where our monitoring sites are for 2022. The red dots are temperature sites, which were installed by a student doing their master's project. The green dots are chlorophyll A sites, and the black dots are total phosphorus sites. So as you can see, we strategically tried to find places in the watershed that were away from Ottawa, and where there was not a lot of information currently available. So why is it? Why does this data help to improve our understanding of the watershed? First of all, there's different sources of data in many different places that you can get. They're hard to get. It's challenging to find them. On the top left, I have a slide here of the algal bloom monitoring that we collected in the green dots, and the blue is what's available in the province. I think the important thing here is how you can see clusters of it based on where the provincial governments have been successful in getting people to report things. We have not been able to secure the data from Ontario, despite trying for the last year and a half. And so there's that aspect of it. But then when we took a closer look at that data, there's a temporal scale there. And so this data is older, and the way that the data is collected does not necessarily lend itself to understanding what's happening from year to year. And so when we took the data we were collecting and put it on top of the total phosphorus data, which is the map right next to it, you can see, based on the color models for the total phosphorus levels, how algal blooms line up. So the red, yellow, and green is not very good, good, better. I did it in the wrong order, but you can see how the algal bloom points are lining up quite closely with where we're seeing a lot of total phosphorus. And so this is some of the ways that we've been taking data, looking at different sources of information, and sharing it back with community-based monitors so they can really help to understand why this data is helping to build an understanding of the watershed, but also why their actions take place. And then on the bottom left is a slide of one of the pieces of information that we were able to do through building an understanding of how to do data analysis, which is what we've learned from the Lake Winnipeg Foundation. And that's monitoring flow with total phosphorus collections. And so you can see there how after a rainfall event in September, the total phosphorus jumped quite a bit. And so again, this is stuff that we share back to people. We do the analysis ourselves. We're able to target different pieces of, target different areas where we're trying to better understand what's happening, and build a stronger understanding and really get that information back to people. I also want to share how we're learning from community-based citizen scientists and community scientists as well. The bottom photo is from a picture that we got from someone who is doing algal blooms, and it's a great illustration of how hard it is sometimes to identify information. There's the different kinds of algae that may be present in that section of river or lake, but also pollen and plants. And so we use this information, we share it back with people who are doing the data collection to really highlight how we're learning from people and not just the experts. We're trying to build a capacity across the whole watershed. Not only are we taking data that we're getting from folks, we are also using the data that is available through many different platforms and networks. And so we really benefit from the fact that there are multiple different platforms for data, such as DataStream, Water Rangers, iNaturalist, We've started using Survey 123. These different platforms allow us to get information that we're not necessarily working directly with our own volunteers, but benefiting from the fact that there are other organizations doing that. And I think that's just highlighting the fact that it's important to have a variety of different ways for data collection, being able to access that data easily, and that it gives people flexibility to do a number of different things. I wanted to just share as well the different ways that we share information with audiences and people who are curious about the river. We've created what we've called a discovery portal, which is a way for people to learn more about the watershed. There's also our open data portal, which is where we put all of our CBM data as CSVs, but also documents, so people can learn directly about the data we're collecting. And then we also made this really nice mini documentary about our first year of community-based monitoring work. And it highlights the work that we were doing with some of the volunteers, so they're featured in that documentary as well. And that's all I have for today. Thanks very much. Our contact information is down there. You can always find us online and follow us on social media.
Thank you so much, Larissa, for that. I really appreciated the presentation. I know we do a lot of work with Water Rangers, and it's great to see everything that you're up to. So thanks for that. So our last speaker of the session will be Cristina Cismasu, who is a data specialist working on Gordon Foundation's data stream that Larissa just mentioned before in her presentation. And she'll be talking specifically how it's an open access tool to support data sharing and community science. Welcome, Cristina.
Hi, everyone. Sorry about that. Thank you, Laura. So my name is Cristina Cismasu. I am a data specialist working for the Gordon Foundation. I am working on data stream. Sorry about that. I seem to have a bit of trouble with screen sharing. So I'm working on data stream, which is an open access platform for sharing water quality data across Canada. And today I'm going to tell you a little bit about data stream, and specifically I want to give you a few examples of how we support community science initiatives, particularly when it comes to data sharing. So data stream, as I mentioned, is an open access platform for sharing water quality data across Canada. It is free for anyone to use, and data can be accessed or visualized using user-friendly visualization tools. Searches can be done using a map-based search. Data can be easily downloaded from the site. And all data that we currently host is formatted or standardized using a robust data model, which is based on a standard developed by the US EPA. And what this means is that all data that we share on our site can be easily compared between regions or between different data sets. And all in all, what we do is we aim to minimize barriers to accessing and sharing and reusing data. We are almost a pan-Canadian platform, and as you can see on this map, we currently have data that can be accessed in 4 different hubs, going from the Atlantic region all the way to the Pacific. And I just want to mention that our Pacific Data Stream Hub is currently under development, and it will be released sometime in the future. But just to give you a brief overview of how data stream started, the first hub in the Mackenzie region was launched in 2016, and the Atlantic Data Stream Hub was launched a couple of years later, following a lot of interest in this sort of work that we do. Lake Winnipeg was the next hub that was launched in 2019, followed by the Great Lakes Data Stream Hub, which was launched just last year. The data that we host is shared by a large number of organizations. Currently, we host data from over 230 organizations across Canada for over 48,000 monitoring locations. And all in all, we have more than 28 million unique observations. the types of organizations that share data with us, as I mentioned, so today I'll be talking mostly about community-based monitoring initiatives, but there are also several other types of groups and organizations that share data with us, such as watershed organizations, academics and researchers, Indigenous organizations, and governments at all levels. So to give you a little bit of history in the context of community-based monitoring initiatives that we work with, I want to tell you how data streams started. As I mentioned, the Mackenzie Basin is our first data hub to be launched. And this is how DataStream was born, through an initiative, through a unique collaboration with the government of the Northwest Territories. Because there was a realization that data water quality data was not easily accessible. And this collaboration with the Northwest Territories government is actually a program, a community-based water monitoring program that was coordinated by the government of the Northwest Territories. So our first data set that came online in this region is actually a community-based water quality monitoring program, which was carried out in partnership with 21 communities that collect water quality data from over 40 monitoring sites across the territory. To give you an idea of what this data looks like, what I'm showing here is DataStream's visualization capabilities in terms of visualizing collected the data that is part of this data set. So what you're seeing here is a graph of turbidity data that was collected over a number of years as a part of this community-based monitoring program. On the left-hand side, you see different sites, also indicated in the graph by different colors of these data points. In addition to turbidity is not the only parameter that's a part of this data set. This data set actually contains nearly 80 different types of parameters collected by these different community groups, from field data such as pH or conductivity or temperature, but also going to different types of metals, nutrients, as well as hydrocarbons. And this is an interesting data set to talk about, because it not only shows, it actually shows the importance of having free access to data, to water quality data. So this data set was actually used because it was easily accessible on DataStream. It was possible to use it in a public hearing for the replacement of a pipeline beneath the Mackenzie River a few years ago. So by having this data freely available on DataStream, it was possible for regulators to use community-generated data to plan and carry out this project. Another example that I wanted to show you is the Lake Winnipeg Foundation, the work that they do with community-based monitoring programs. So the Lake Winnipeg Foundation is our regional partner for the Lake Winnipeg DataStream Hub. And they run a large-scale citizen science monitoring program for phosphorus monitoring. Eutrophication and phosphorus loading are a major problem in the Lake Winnipeg area, and this monitoring program measures phosphorus level throughout the region. And previously, there was no place where to store these data. And by uploading these results to DataStream, monitoring data can be used by researchers or regulators, and also across boundary for watershed studies across boundaries. Another example from the Atlantic region now, this is a group, the Passamaquoddy Recognition Group is an Indigenous organization in southern New Brunswick. And at some point, they were interested in restarting their long-term water quality monitoring program. And they used DataStream, so they came onto DataStream to gather information on what type of data and where data was collected. throughout their territory in order to design a better monitoring program. And with the information they obtained from data stream, they were able to design their program to avoid duplication of monitoring efforts and fill in data gaps. And also, it's a nice thing to mention that the data that they collected during this newly designed monitoring program was also shared on DataStream. Finally, I would also like to mention water rangers, which, as you all may know, work quite a lot with citizen scientists and encourage the use encourage the water quality monitoring using test kits. The data that is collected by citizen scientists is provided on the Water Rangers platform. And what I would like to say about this is, in our case, we collaborate with Water Rangers in order to integrate our two platforms so that we increase data flows and we increase the visibility of the data collected through the Water Rangers program. I would like to leave you with this final, a slide that hopefully brings all of this together. So I would like to show you where DataStream is situated in the data to action cycle. So DataStream provides a place where data can be stored, compared across different regions and sectors. And this is how we help broaden the reach of and impact of community-based monitoring initiatives as well. By storing data that's collected by community-based monitoring initiatives, whether big or small, we intend to keep this data, to ensure that this data is there for communities, but also for researchers and for anyone that has an interest in using this data for purposes, whether understanding a particular environment or developing better environmental regulations. Looking ahead, we are continually working on expanding our networks throughout our data hubs. We continue to advocate for free access to data and use in order to enhance transparency and make better decisions about our waters. We also continue to support the user community, including community-based monitoring initiatives. And something that I haven't mentioned is that we have been involved in convening around community-based monitoring, around ways to support community-based monitoring initiatives, or the development of community CBM initiatives at a national level. And more recently, we've become involved also at a provincial level. So in Quebec, we are involved in in convening around CBM work that's done at the provincial level. I would like to acknowledge our partners and collaborators, which without whom this work wouldn't be possible. And if you have any questions, I would be happy to address them. Thank you.
Thank you so much, Cristina, for that presentation. I know quite a bit about DataStream from our work, but I learned some new things here, and I'm sure everyone else did as well. So thanks again for that. So we're now entering the question period of the session. So if you haven't already written your question in the chat box on YouTube, I invite you to do so right now. I believe we'll be bringing in all of the presenters right here to start asking questions. So I will say that there's quite a bit of interest in the BAT program, so you might see some new registrants happening here. So while some of the questions start trickling in, I have some questions that I can get ahead and ask some of you. So Gabby, since you were first, I'll start off with you. So in your conclusion, you said that community-based water monitoring was about 1 to 3 times it was a ratio of 1 to 3 in terms of how cost effective it was. And in the case study you showed us, it was about 11 to 3. So clearly that was much higher than the average. What kind of factors play into that ratio that makes some programs more or less cost effective? So what should people look out for when they design these programs, essentially?
It's really, I think, localized, and I don't think they're actually set up like, but that's the first thing in mind, is it more cost effective? So this one was really, if you go back, I can show that slide again about how it's calculated. So it's those different whether it's based on if someone had to reproduce this, what is the value of the data, and so forth. So that was, again, the average, greater than 3 to 1 is sort of the average, and the Annapolis, the ACAP program, was 11.6 to 1 return on investment, and it had to do with just how much cheaper it was when they did this over time. So when people are setting this up, again, that's usually not the first thing that they're thinking about. They're really trying to answer a core question that their community has. And a lot of what happens is that this is a question on the ground. So the way when the programs are set up, it's sort of like the one that we have in Saskatchewan. They're maybe collecting data that's close to their home. They could access that and get down quite quickly. So that's reducing costs of transportation. So it's obviously great for the environment too. The types of materials that they're using. A lot of times community-based monitoring, they are collecting high quality data, but they might have access to sort of they can't afford the $40,000 piece of equipment. So they have something that is just as reliable, but it is cheaper that they've found. And it's also the network. So a lot of times it's sharing of resources. We're setting that up. But it's always, if we look at all those case studies, the first thing that they did is they asked a question, and that came from the community. Yeah. So I'll pause there. Thanks.
Yeah, thanks. Larissa, I have a little question for you. So working with water rangers, one thing we always talk about is keeping people engaged. So you said you had some participants that were really great, answered everything, and you started in 2020. So how do you make sure that you keep those participants engaged year to year?
Yeah, I think engagement is one of those things that can be a really challenging part of community-based monitoring, and often is one of the pieces that's overlooked when setting up these programs. You're like, clearly people will want to do this, and then there's lots of enthusiasm, and then they start and they don't continue. We really work to develop relationships with the community scientists that we're working with. We send them reminders, but we also share data back. We make sure that once we've collected the data, once we've looked at it, we put it in a way that can be shared with them, and they can share with their communities to help improve their knowledge. And we do that at different levels. Sometimes we'll share scientific articles, and sometimes we'll share simple diagrams. We really try to cover a range of materials to do that, and that has really helped with our engagement. And also people share stories with us, and we then share that with our social media network. So we give them a lot of space and try to do that to really highlight what we're learning from community members.
That's great. That's always great to hear. I always love hearing those stories. We just have a couple of minutes left, so I'll just make sure to get to everyone. Bailey, I really enjoyed your presentation. I have to say, bats is not my area of expertise. I loved hearing about it, and there's clearly lots of interest. I'm just wondering about like the program, like kind of long-term goals. I know I was talking a lot about these bat boxes, but is there a hope to really see that population increase or stabilize? And like, what's kind of like those targets if there is that hope for the program?
Yeah, so there has been some research going on throughout North America looking at the recovery of different bat populations from white nose syndrome. It's thought that some populations might have begun developing a resistance to the fungus. And that's why we want to investigate whether the bat boxes are acting as a vector, if now they are surviving their exposure to white nose syndrome in the caves and carrying it to bat boxes in the summer. So that's why we're investigating that. But to me, it seems like there is a light at the end of the tunnel. I think that it's looking good for these populations that did see such a drastic decline. Our study is, like I said, just the 3-year project. But like I mentioned at the end, BatWatch is looking to monitor bat population trends very long term. So if you wanted to contribute to that as well, then you can register your bat box there. But yeah, I think bats have a good future.
That's great to hear. That's really good. One last quick question for you, Cristina. So I know how we recruit folks to join DataStream from Water Rangers, and it's pretty easy. Usually people love to share data with DataStream, but I'm wondering on your end if there's some sort of strategy or how DataStream goes about building those connections with groups so that they feel comfortable sharing the data and also they get the proper training to understand how the platform works.
Yeah, that's a very good question. Well, we reach out to several groups that we are aware do water quality monitoring, and in terms of convincing them or getting them to understand what DataStream is about, it's a dialogue, and we're open to anyone who is interested in sharing data with us. We're at a point where we're meeting people halfway where they're at in terms of how they manage their own data, and if there's a need for anyone for any type of help or guidance in terms of data management or getting the data up on DataStream, we also provide those services as well.
Perfect. Thank you so much. Well, I just want to thank again all of the speakers, and thank you for everyone that was listening online. And I hope you enjoy the rest of the virtual day of presentations. Thanks again.
Hi, and welcome back. I'm Georgia, as you know. I'm going to introduce our next session chair, who is Yanik Rozon, who some of you might know. She has worked at the River Institute in the past, and she's out at UBC right now. And she is going to be chairing It's All Connected Part 2. So I'll pass it over to Yanik.
Hi, everyone. Thanks for joining us for this session. As Georgia said, this is It's All Connected Part 2, and I'm Yanik Rozon. I will be chairing the session. So we're joined today by 4 speakers, each of which will have 10 minutes to present, and after which we will have a group question and answer period where you can ask questions to any one of the speakers. We would ask you to please submit your questions to the YouTube live chat box and make sure that you are identifying which speaker the question is for. So we'll start today's session with Dr. Jessica Nolan's talk on In the Forest, the Field, and By the Waters, creating a Haudenosaunee and Anishinaabe ethnobotanical map and field guide to Southern Ontario. So Dr. Dolan, whenever you're ready.
Let's see here. Uh-oh, I thought I had this down. Okay. There we go. How's that? Can you see that?
Yeah. Yes.
And can you hear me okay?
Perfect.
Okay, good morning, everybody in Sego. My presentation is called Garhagu Gahundawanu Danu Aksata, In the Forest, in the Fields, and By the Waters, an Indigenous Biocultural Atlas and Ethnobotanical Field Guide project. Let's see. Uh-oh. Why doesn't it do that? Okay, sorry. I should have practiced this a bit more. There we go. In this talk, I'm going to share my current research, which combines archival research with ethnographic and environmental fieldwork to create an Indigenous digital atlas and field guide to Southern Ontario. The project is a collective formed by the Indigenous organization Plenty Canada, which many of you may have heard about, and researchers from the University of Guelph. And I'm a MITEX postdoctoral fellow with both organizations. This project isn't specifically about the St. Lawrence River itself, but it's relevant to Akwesasne knowledge of ethnobotany and Haudenosaunee knowledge along the river, as well as many of the plants are the same as in the ecosystems found along the St. Lawrence River watershed. My involvement in building the project stems from relationships I've developed with Haudenosaunee and Anishinaabe knowledge holders, teachers, and environmental professionals over the last 12 years, since carrying out my doctoral research at Six Nations of the Grand River in 2011. Six Nations is the most populous, well, as many people know, Six Nations is the most populous Indigenous community in Canada, and combined with the adjacent Mississaugas of the New Credit and all of the communities of Toronto, Hamilton, Niagara Peninsula, Brantford, and west to Oneida and Chippewa of the Thames, is rich with Indigenous pluralism. Here you can see some treaty maps of Ontario, of Southern Ontario, of the Niagara Escarpment, and of the Greenbelt region around the Greater Toronto area. My doctoral research that I am drawing extensively from and provided a very strong foundation for this research, explored environmental knowledge and philosophies of the Haudenosaunee. I interviewed 45 people about their relationships with and cultural philosophies toward Mother Earth. Most of these interviews took place at Six Nations, but I also traveled on a peacemaker's journey with mostly moms and kids, and as well with my mentor, Rick Hill. And throughout this journeying, I visited communities throughout Haudenosaunee homeland and interviewed people from all of the nations in these places. Later, I worked for Onondaga Nation and Center for Native Peoples and the Environment. And throughout these experiences, I joined a network of Indigenous environmental practitioners who are integrating Native science and biocultural traditional knowledge with Western sciences to restore the elements of their cultures and of their homelands that have been destroyed over the last centuries of capitalist settler colonialism. The processes of my doctoral work and many contracts after served as a foundation through which people began to know me as an ethnobotanist and an allied scholar and talk to me about plants and restoring plant knowledge.
Sorry, my computer is very sensitive. Okay. This is a map that represents our current project, which my mentors are calling Wisdom from Knowledge. And it joins into several ongoing restorative movements in Native communities across Turtle Island. One is that of digital mapping or Indigenous mapping to make Indigenous relationships with landscape visible and accessible to insiders and outsiders of Native communities. Biocultural mapping has been a movement around the world, and Plenty Canada has created a series of projects that they call Landscape of Nations 360, which are what they call legacy projects in the Southern Ontario region, whereby they build monuments, create place-based learning spaces and trails that are indoor and outdoor exhibits to repopulate the landscape with Indigenous storytelling. My mentor, who's in the upper right photograph, Tim Johnson, used to work, who's from Six Nations. He's Ganyankahaga. He used to direct the direct education at the Smithsonian National Museum of the American Indian. And he heads up these beautiful projects that intertwine history, treaty education, arts, music, theater, and biocultural conservation, all of which are featured in an annual festival in St. Catharines called the Celebration of Nations. And then on the lower photograph, you see Larry McDermott, who may be there today, who many people there know, who's the founder of Plenty Canada, and who's been working extensively in the areas of food sovereignty, forestry, Indigenous protected and conserved areas, and more. Larry and Tim asked me to join in their work to map the Niagara Escarpment and to build relationships and legacy spaces throughout the Niagara Biosphere Network in Ontario. This kind of work contributes to establishing the viability, visibility, and depth of Indigenous stewardship, advocacy for Indigenous treaty rights in their homelands, regeneration of community-based education, and the development of Indigenous co-management and protected areas. Their combined projects extend geographically from Eastern Ontario to the Niagara Peninsula and up to the Bruce Peninsula. And as the GTA is one of the fastest growing, diverse, and populous places in North America, it's a beautiful challenge to make these multicultural geographies and ecologies legible. Since I finished my doctorate 6 years ago now, I have been working with and learning from different community members to build the concept and framing of an ethnobotanical field guide project. This project is in response to another movement that is across Native communities, that of regenerating environmental knowledge in support of Indigenous food systems and connection, and to reconnect younger generations with their ancestral knowledge of food and medicine plants, to restore cultural continuance that's been under siege for over a century of residential schooling and assimilative termination policies. Mentors and colleagues have advised me on how to collaboratively research and write a user-friendly book that people can take into the field with them as a tool for learning plants. We also decided that we'll feature common food and medicine plants to avoid exposing ceremonial information or promoting botanical knowledge as witchcraft. So how are we doing this? Well, we have several streams of work. Part of my role has been to organize a collective of Ganyankahaga and Anishinaabe knowledge holders who are knowledgeable about plants and their language and interested in working on this project. In 2019, I carried out research at the Canada Museum of History in the F.W. Waugh collection. I researched his field notebooks, which you can see here, which span the years of 1911 to 1924. In conversation with Haudenosaunee scholars, I learned that this information he collected from these communities is ancestral knowledge of descendants today. And some of the people who Waugh interviewed in the early 20th century were elderly, and so the knowledge he documented then could go back at least to 1850 or earlier. Even though these documents were in a public museum, due to the segregation policies in place, they were not easily accessible to the descendants of Waugh's native cultural teachers. So over the course of several days, when I did my research there, I selected 800 pages for digitization that contain information about traditional foods, medicine, craft, and utility. And then I rematriated those digital copies to about 40 different people across Haudenosaunee communities who are scholars, plant people, environmental professionals, and et cetera. Interestingly, I learned recently that the path that I took to do fieldwork this summer is is the same as what Waugh did in his earlier career. In other words, he went from Ottawa. He didn't start in Cornwall like I did, but he went from Ottawa out to Six Nations and back. And then he went all the way up to the Bruce Peninsula to Manitoulin Island and back. So this year I've been working to synthesize this knowledge from his notebooks, as well as other published information, my own field notebooks, and contributions from mentors and peers into Excel charts, which you can see here on the right, of ethnobotanical metadata. I organized the data by plant name in English on the y-axis, and then on the x-axis, I've inputted Latin, Ganyangeha, French, and then habitat conservation status and plant uses by the source. Organizing the sources helps to ensure that we track credit where credit is due. I'm using my own knowledge and experience, as well as running everything through my plant and language knowledge advisory committee to select which species that we are going to highlight that are relevant and appropriate for publication. I've documented over 200 species thus far, and I'm doing the same thing for Anishinaabe ethnobotany in a separate chart. The goal is to incorporate sources that are 100 years old or older with contemporary knowledge to create a thoughtful inquiry into continuity and change. For some youth who are learning their ancestral knowledge of the environment, it can be a source of pride, identity, and healing to be reconnected with ancestral and place-based knowledge of plants. So I'm working with the team of community knowledge holders to select the species we'll feature and edit every plant profile I write. They're also providing linguistic orthography, their knowledge, and each will write a culturally grounded introductory chapter in Ganyangeha and Anishinaabe. Since the area that we're studying is a place where Haudenosaunee and Anishinaabe homelands overlap, and many families are related, it's appropriate that our Atlas and Field Guide will feature both of these knowledge systems integrated with Western science. Here's some pictures of some of the knowledge holders who I'm working with, and the students from University of Guelph who did the plant biology part of the research. So the other stream of the project has been carried out by my graduate student, Mia Yuzaoni. She's in the bottom right photograph at the supper table there that was up in Tobermory. She and two research assistants led the plant biology component of the project. Throughout this spring and summer, they studied species diversity, richness, and health in 23 sites on public trails along the Niagara Peninsula up the Bruce Peninsula and out to the Oak Ridges Moraine, those parts that overlap with the Greenbelt. Within each site, they also documented 3 subplots, so it amounts to 69 sites. They visited these sites first in the spring to capture photography and spring inventories, and then I joined them during their second round, when many summer plants were blooming and trees were beginning to fruit. This data serves as botanical ground truthing, which demonstrates through finding the plants and the trees in public places on historical trails, native trails and portages, where Native people have treaty rights to gather for personal use, that the species described in historical documentation by the ancestors of today's communities are also still here. Some are returning due to climate change too, such as the pawpaw in the upper right photograph, which we were very excited to find, as you can see from the happy looks on the students' faces. Here are some of the plants we documented along the trails in Southern Ontario. So we have witch hazel, black cherry, pawpaw, motherwort. We have St. John's wort and boneset. And here we have some beautiful cedar and wild ginger. And down here we have an Sagittaria and white birch. And you can see here's the landscape up the Bruce Peninsula. So in conclusion, well, maybe, oh, I don't know how to go back. Oh, well, let's see here. Sorry about this, guys. I'll start right here. Okay. In keeping with Indigenous methodologies, the processes of this project are as important as and are part of the outcomes. The relationships we carry forward through working with each other to generate educational materials are part of the regeneration of intergenerational ethnobotanical knowledge. Cross-cultural elements of our project are in line with renewing peace building and knowledge sharing between peoples and ethical spaces. As well, an important part of renewing relationships with plants is knowing where to find them and being able to name them and speak with them in Indigenous languages. The linguistic components of this project are intended to help restore that ability in Native communities. Many people believe that it's essential to the medicine working as well as to the conservation and regeneration of species to be able to speak with them in Indigenous languages. At this point, we are still working on processing and synthesizing all of the botanical, ethnographic, photographic, and linguistic data from the first 9 months of this year. But we are also now beginning to write plant profiles for the digital atlas and field guide, species by species. And we are working with doctoral student Marina Johnson-Zafiris on mapping and Indigenous data sovereignty, and Cree graphic designer David Beyer to design our interactive website and field guide for publication. Thank you so much for the opportunity to share with you, and I'd be happy to answer any questions and also receive suggestions.
Thank you so much, Dr. Dolan. That was fantastic. So we will move on to our next speaker. And if anybody has any questions for Dr. Dolan, I would invite you to put them in the YouTube live chat box, and we will get to them during the question and answer period. So next up, we have Dr. Laura Murray, who will be presenting on swimming upstream using augmented reality to reveal fish in the Cataraqui River.
I'm sorry, I don't know whether I'm online or not. I can't see myself.
That's all right.
I don't see the main screen where I'm supposed to do what I'm supposed to do.
Okay.
I can
hear you. I can see you on the.
Hello, I'm sorry about the technical difficulties. It's wonderful to join you remotely, but of course we always have these challenges. And I was so inspired by the first talk, and I know that the folks, wait, that isn't supposed to happen. My screen, my show is moving itself along when I didn't ask it to. Sorry. I'm showing you a screen of the Cataraqui River. and I'll introduce the place first and then myself. So if you look at the sunny trees in the distance there, that's Bell Island. And so I was really thinking about Bell Island and the caretakers when I was listening to the last presentation, because we're embarking here Indigenous-led project for thinking about the botanical and sacred spaces of that island. And then to the left, the other trees you see there are Bell Park. And Bell Park was a wetland, became a landfill, and is now a park of sorts, a very complex space. And you're looking north here, up the Gadaraqui River. So those of you who are in Cornwall, you know you'd have to go west, and then you go up the Gadaraqui River when you get to Fort Henry. And this is the infrastructure of a very small project we did compared to the last presentation, an augmented reality project. And I'll show you the project itself, but this is where you have to go to see it happen. I just want you to note that there's somebody fishing in the river, and is a lot of discussion, scientific and political, about what state the river's in, and this piece engages with that. Myself, I'm a settler scholar at Queen's. I'm work in cultural studies, which is a graduate program, and I'm always interested in interdisciplinary collaborations, working with artists, working with scientists, working with community members. I've done a lot of local work here, oral history about the 20th century working class history of the west shore of the Gadaraqui River, and also work on the treaty history of this area, including further east. I have an article coming out about the Crawford Purchase in ethnohistory. So this kind of collaboration with artists and community members is part of what I do with other people. The smaller project of swimming upstream is part of a SSHRC-funded project called the Bell Park Project. So this is a lot of layers of projects. And this is about that space I described already, where we're looking at ecological histories, political histories, cultural histories in this space, and looking at it both really, really specifically and knowing that it resonates with a lot of other wetlands that have been destroyed with garbage and that have future lives as well. This is an old map to orient you again. Bell Island, I spoke about, is on the right at the top, and you see the wetland that connected it to the west shore of the Gadaraqui River, and you see the train tracks, and that's just important because the place that we've situated this augmented reality piece was not actually land, like a lot of the west shore of the river. It was not land originally, it was a pier for the K&P Railroad, and now it's grass, but you wouldn't have known that history without seeing these maps. The art piece was done by 4 people, and we were really lucky to have Jennifer Norton, who is an expert in augmented reality and animation, who did the actual technical work to make it happen, using fish models that are provided by Harvard University, 3D fish models. And so we were able to borrow that into our work. Matt Rogalski is a sound artist, and he did the sound part of this piece, which you'll hear is really crucial to it. I guess it was sort of my idea, and Dorit Nauman works in film and augmented reality, and has also been really interested in the in thinking about different perspectives on rivers and how we can imagine them. So this is our artist statement. It may be hard to imagine it now, but in the past, fish were abundant in the Gadaraqui River. In the 1750s, Pierre Pouchot reported that in the spring and early summer, the creeks and rivers running into Lake Ontario teemed with spawning fish. The quantities that go up on some days, he wrote, is inconceivable. The Mishsagi people, and their name means people of the large river mouths, as many of you will know, they depended on fish relations for a large part of their livelihood. The construction of mills and dams and destruction of wetlands by settlers, not to mention overfishing and pollution, have drastically reduced the number of fish. They're still here though. The herons and ospreys know that, and some of you do too. We hope this audio and video piece will immerse you in the fish world of this river. So I was inspired in an immediate sense by a couple of very different people. Leanne Simpson, a leading philosopher and thinker and poet, Anishinaabe. And in a piece in 2008, she writes about Anishinaabe relations with fish nations and how important it is to retain relationships in a systemic way and in a deep way with fish as collective species with their own perspectives and their own ways of being. And as she says, to do otherwise would be to ignore their responsibilities to the fish nations and to jeopardize the health and wellness of the people. And I think a lot of people in Kingston don't think very much about fish. That would have included me. And I started thinking about them more, partly also because of the work of the River Institute and meeting people like all of you who are doing this kind of scientific work, and partly because of people like Simpson. And then I'm a historian. And so when I came across Pierre Pouchot's writing, I was really engaged by him. He's an engineer who came to work shoring up forts in the 1750s. He's also French, so he's interested in how fish taste, and he's interested in the data, but he really does have a sense of wonder about what he saw here. And so just to read a little tad of this, about the months of May and June, they find pike, mullet, and salmon trout from 15 to 18 pounds, and achigan, gilded and green. I'll return to that word later. The mastilongi, which grows from 10 to 25 pounds, is a kind of pike trout, and very good, as also the gilded fish, which is shaped like a cleaving axe. And he just goes on and on and on. He's so amazed by the quantities of fish that go up the river. So swimming upstream, the name of our AR piece, is a bit of a, I guess, a double meaning. I think in English and settler thinking, swimming upstream, we use that as a figure of speech to mean like, this is just hard and I probably should just be going with the flow. That is like going downstream, which is easier. But then for me, when I start thinking about fish, I realize swimming upstream is an essential part of creating life. And I like to think about that. So I'll play you a bit of a video. It shows on the left what you would see when you stand at the sign of the fish with your app installed. And then on the right, this is our collaboration with scientists, which has been so important for us. You'll start to see some footage from an underwater drone. And I hope you'll hear the soundtrack as well. Chose the fish. We were consulting with some folks at the River Institute and other experts we knew in the wrong field fish, whatever we could find. And we couldn't pick too many just because of the technical demands. But we wanted to have an eel. And we chose these little pumpkin seeds. And we didn't actually, in fact, know that they still lived there until we had the drone footage. So for us, it's been a little bit of an experiment and a discovery, and we were so delighted to see them there, as we had kind of imagined that they would inhabit this space. So that sound was recorded in the river, actually, by Matt Rogalski and then mixed into that environment. So we have really been animating the piece in a lot of ways, so it doesn't just stand there by itself. And here, for example, in his event we held with Alderville First Nation, that's Dave Mowat, the chief there. And, you know, they were displaced in the late 18th century to Bay of Quinte and then up to Rice Lake. And so to welcome them back to the territory from which many of their ancestors came was a really lovely, lovely day. And we have held many other events there with school groups. We have a grad student running sessions with kindergarten and high school students there. We've had artists. We've had the Gadaraqui, the Kingston Indigenous Languages Nest there as well. So just to wrap up, there's some challenges with this kind of work. One is that not everyone has an AR expert around. And also, you know, our signage has been vandalized. It's in a public space, but not a public space that's entirely on the main track. So we have to sort of keep it up in that way. A big thing is that people don't download the app. The instructions are, and they're on our website and everything. Download the app and then go down there. But of course, I understand that people don't get around to doing it. So sometimes they get there and they have no idea what the thing is, or they don't have headphones and they don't hear the sound. But there's a lot of opportunities that I think we didn't necessarily anticipate when we first did this piece. One is that it does turn out to be attractive to people of various ages and backgrounds, and it reminds people or informs them that there is life in the river, and they can think about that. Some people it makes them think about the past and things that have been lost. Some people think about the present, and some people think of the future. It's not didactic, so you can let it wash over you in different ways. We have hosted all these visits, as I suggested before, and built relationships through those. And we really do imagine, for example, that the Kingston Indigenous Language Nest could use this piece in different ways. It's a nice place to gather, and because it has no language in it, of course, it can be presented in different languages. We've also found that the political resonances have accrued over time. So after we did the piece, we found out that Transport Canada was planning to dredge the Cataraqui River, and also much more discussion came about around a proposal to build condos on the former tannery lands and thereby destroy a wetland north of the park. And so there's been a huge amount of discussion about the Cataraqui River that we sort of accidentally have been able to participate in. And it proves to be really enriching in both directions, I think. And to conclude, I'll just note that even the sign itself, even if people haven't downloaded the app, has become a kind of invitation for dialogue, it seems. So this is what it looks like now. I should say that the sign is a stencil from a manhole cover, which is intended to warn people about not dumping toxins down the drains. So people have written on it, water, oh water, I's the buy that builds the boat, my Bonnie lies over the ocean, whatever. And I don't know whether those people had downloaded the app or anything, but they're interested in the sign. They're not vandalizing it, they're engaging with it. So it's a small experiment, as I say, but to us, it seems to have a lot of opportunities that keep appearing, even though we didn't intend them. And I'm so inspired by all the different kinds of art and scientific work that I've heard here, and hope that we'll have more chances to talk. Thank you. Bye.
Thank you so much, Dr. Marie. That was fantastic. So we will ask now for our third presenter to share their screen whenever they're ready. So next up, we have Dr. Valerie Goodness, who will be presenting on the restoration of clan species and conservation of freshwater river ecosystems. That includes Haudenosaunee traditional ecological knowledge. So Dr. Goodness, whenever you're ready.
OCO, thank you River Institute for allowing me to present here today. Most of my work is in applying traditional ecological knowledge in watershed restoration and conservation. Today, I'd like to talk about how conservation and restoration of the 9 Haudenosaunee clan species using TEK will improve freshwater river ecosystems. Oops. We're also going to play an ecosystems game called 6 Degrees to the Tree of Peace. How many of you have heard about the game called 6 Degrees to Kevin Bacon? In that game, the goal is to connect famous people to Kevin Bacon in 6 steps or less. Oops, sorry about that. Clan species and their 6 degrees to the Tree of Peace. Easy example. Deer has 1 degree to the Tree of Peace because they browse white pine during winter when they're not eating our rose bushes. Harder example, eel have 4 degrees because they create aquatic decomposer ecosystems, which improve soil fertility in floodplains and watersheds, which is good for grasses and forbs that share sacred space with eastern white pine, which likes moist, well-drained soils. Here's the ecosystem challenge, and this is what I teach to students when they're learning about culturally significant species and how important they are to ecosystems. Write down as many degrees to white pine that all clan species can connect. How many of those overlap? There's one more native species that co-evolved with the clan species. Can you guess what that species is? I propose that river and watershed restoration and conservation must include protecting and restoring all 9 clan species using traditional ecological knowledge. This includes applications of the Great Law of Peace, Haudenosaunee origin stories, and the Thanksgiving Address, which are influenced by nature, according to Oren Lyons at a conference in 2015. Clanology, Clan System of the Iroquois by Tom Porter reveals that the clan system was modeled after nature. Clan species are culturally important keystone species. This and clan ecosystems knowledge was learned from nature and constitutes traditional ecological knowledge, or TEK. This lived knowledge comes from co-evolutionary relationships between Indigenous people and their clan species within those ecosystems. The voices of Haudenosaunee scientists provide a better understanding of how to tackle the watershed ecosystems conservation issues we face today. For the Haudenosaunee territories, that means better inclusion of applications of TEK in conservation and restoration. TEK inclusion must include clanology of clan species, taught, practiced, and applied by Haudenosaunee experts. One mind, one heart, community, and responsibility. Here's my Venn design describing the TEK connections between the Thanksgiving Address, origin stories, the Great Law of Peace, and clanology. This includes their connections to ecosystems kinship and relationships, coevolution, and step succession. Our clan more than human relatives are bear, beaver, deer, eel, hawk, heron, snipe, turtle, and wolf. Some of these species are on lists within the Endangered Species Act. Bears are the medicine people of our ecosystems. Therefore, it's not a surprise that they're also the medicine clan for the Haudenosaunee and many other tribes. Bears can sniff out moth grubs in soil to eat. These moth larvae help fatten bears up for hibernation. They eat berries, fish, ungulates, and white pine sap are foods and medicines for bears. Old growth white pines are often hollow and often the only trees large enough to serve as dens. Beaver are a keystone species in aquatic ecosystems. They also share their sacred space with other aquatic clan species such as heron, snipe, eel, and more. While white pine is not the preferred woody foliage beaver eat, during lean times they will. White pine does share sacred space with other trees that beaver do prefer as food and building materials. Henry Lickers reported, "You find the nature of women is to cooperate." Then we also have a little creature, beaver, where our women would go out and catch a beaver and they would transport him across the land into the valleys around where we live. Deer. According to Tom Porter, the Deer Clan people are timid and shy. Porter then suggests that Deer Clan people are athletic, but are usually intimidated. When we see the clan species deer, their co-evolutionary ecosystem needs and contributions intersect with all our native clan species. Indigenous people protected habitats and promoted biodiversity in plant and animal communities by keeping the ungulate numbers low. In my interviews with Neil Patterson, he tells us that keeping deer populations down improves biodiversity and other habitats such as beaver habitat. Like the beaver, deer browse white pine during lean seasons. Eel. Tom Porter writes that though the principal clans of the Mohawk are bear, turtle, and wolf, there are few eel clan members, especially in Akwesasne. Nature's ecosystems need eels just as much as the Haudenosaunee needs eel clans and members. Eels bring balance to both In my archival studies, lamprey were considered eels until the late 1800s. Both species are older than dinosaurs, and their co-evolutionary kinship is very important to river ecosystems' health. Habitat protection is important for the northern brook lamprey. The fish is sensitive to environmental degradation and seems to prefer undisturbed habitat and clear water. Watershed management practices that reduce erosion and pollution and thus maintain high water quality are beneficial to eel and lamprey. Lampricides, which are intended to control parasitic sea lamprey populations, are toxic to all lampreys and other aquatic species. Management of lamprey and its invasive cousin needs to be controlled by Indigenous experts. Hawk, sharp-skinned hawk, common nighthawk, Cooper's hawk, and the northern goshawk are all in the ESA. They're either threatened or listed as special concern. They nest in the herb stratum of trees, which serves the birds of the shaded or lower branches of riparian regions and forests of watersheds. These birds make their nests from 5 to 35 feet above the ground. The birds who nest in the herb stratum would include the green heron, mourning dove, sharp-skinned hawk, ruby-throated hummingbird, kingbird, robins, and more. The fact that 2 of the many species listed are clan species and share space peacefully in white pine is proof that these are watersheds of peace. Heron. What the literature shows is that many of the clan species, like the heron, have at least one in their families that is threatened, endangered, or extinct. While the great blue heron may have stable populations in Haudenosaunee territories, the green heron and yellow-crowned night heron may not. Their population continues to decline. Therefore, understanding TEK clanology has value. Snipe. Tom Porter wrote, "The following is observed of the people belonging to the snipe clan. They're always busy or involved in something. They're usually not lazy. They're sometimes moody. Most of the times, the mood is of a joyous nature. It is said that the snipe clan people are a noisy bunch, and they're very alert and full of energy." The blending turtle is threatened. There are many native species turtles that are. Turtles are the canaries in the coal mine for river ecosystems. Tom Porter describes the turtle clan as one of the principal clans of the Mohawk. The turtle is a symbol of the whole earth. We walk upon the turtle's back. The people of the Turtle Clan are the foundation of our nation. Because of this, Turtle Clan people are very consistent, determined, and humbly stubborn. Doug George tells us that the turtle shell reminds us of the 13 moons of gratitude as they walk along the path of stars back to the Creator's land. For there they will be embraced by their ancestors. Wolves. Wolves have been teachers to Indigenous people for millennia. Wolves feed their neighbors, which prove they're not just killing machines. They withhold estrus during lean years to keep their population lower, so not to outcompete their food. They're keystone species in ecosystems. There's much research done on how extirpating wolves have caused great harm to river and watershed ecosystems. There's also research that shows that restoring wolves have improved river ecosystems. The tree of peace in ecosystems. When settlers and colonizers were arriving to the Haudenosaunee territories, ecosystem degradation became more and more prominent. None more evident than the clear cutting of white pine for European warship masts and turpentine. Ignoring or removing one ecosystem service can have critical effects on other threads of that web. The threads that connect to the white pine provide services to ecosystems include the valuable soil geology of rivers and watersheds, which is necessary for these clan native species. Coevolution, watersheds of peace. 6 degrees to the tree of peace, eastern white pine, Parnus strobus, plus one other species. Any clan species in the Haudenosaunee territory can be linked back to the tree of peace in 6 degrees or less. Clinology includes clinology of ecosystems, coevolution, which includes one other native species, Indigenous people, the Haudenosaunee. While there are enormous problems to overcome, there are also successful examples of TEK and Western science collaboration. The future of watersheds of peace requires tribal TEK clinology inclusion. For example, who better to protect and monitor eels than vested eel clan scientists? Native people should be managing sea lamprey problems, not chemical companies. There's big money in harvesting sea lamprey. United Nations Declaration on the Rights of Indigenous Peoples, Rights to Genetic Resources and Indigenous Knowledge, Article 31.1. Indigenous peoples have the right to maintain, control, protect, and develop their cultural heritage, traditional knowledge, and traditional cultural expressions, as well as the manifestations of their sciences, technologies, and cultures, including human and genetic resources, seeds, medicines, knowledge of the properties of fauna and flora. Restoration conservation opportunities, clinology as a study of clan species and ecosystems, as well as in the clan systems of the Haudenosaunee, provide more research opportunities for optimal restoration and conservation results, especially for monitoring. Nyaweh.
Thank you so much, Dr. Goodness. That was an incredible presentation.
Thank you.
So we will now move on to our last speaker of this session, which is actually myself. So I'm just going to share my screen and begin. Just confirming that everyone's able to see this. Perfect. All right, so I'm Yanik Rozon, and I will be presenting today on connecting with the community, the quest for transformative change through social engagement. So a little bit about myself. I am a graduate student at the University of Northern British Columbia, located in Prince George, British Columbia, and located on the traditional territory of the Lheidli T'enneh First Nation. I am pursuing my research in the Masters of Natural Resources and Environmental Studies program, and I'm focusing my research on looking at climate change adaptation strategies. And I previously worked for the St. Lawrence River Institute in a number of different positions. A long time ago as an educator at the day camps, the summer day camps, and more recently as the project coordinator for the river strategy, as well as coordinating outreach initiatives as part of the Great River Rapport. So a quick outline of today's presentation. I will begin with an overview of current global and environmental challenges, followed by looking at what we can do and the role of transformative change and transformative learning and informal learning in adapting to these threats. And then briefly describing the Great River Rapport project and the workshops that were held, and finally the results of these workshops. Now, this presentation is not meant to focus on sort of, big global threats and what's gone wrong, but really to highlight what is going right and what we're able to do. But it is important to provide some quick context of the global situation. And so this year, the Intergovernmental Panel on Climate Change released the 2022 IPCC report assessing the current state of knowledge of climate change. And this quote briefly outlines some of the biggest take-home messages from the report in saying that the health of ecosystems on which we and all other species depend is deteriorating more rapidly than ever. We are eroding the very foundations of our economies, our livelihoods, food security, health, and quality of life worldwide. The report also highlights the 5 biggest drivers of change, which are causing the most harm from the global to local scales as being climate change, pollution and contaminants, changes in land use and sea use, invasive species, and overexploitation of organisms. And we can actually see how these 5 global threats are having impacts at the local level. And so, for example, if we look at the St. Lawrence River itself and just any species, looking at the American eel, we can see all 5 of these different global threats having impacts on this one species. And so, of course, this raises the question, what can we do? And more importantly, what can we do at the local level in our own communities and environments? So the IPCC report does highlight that it's not too late to make a difference, but this requires action on all levels. So from the global scale all the way down to the local scale. And Sir Robert Watson is the former chair of the IPBES and is quoted here on the screen in expressing the importance of transformative change as a solution for our current global issues. And I'd like to just draw your attention to the second part of this quote, saying that by transformative change, we mean a fundamental system-wide reorganization across technological, economic, and social factors, including paradigms, goals, and values. And this essentially means that global change would make sustainability the norm and not the exception. So when we speak of transformative change, what exactly are we speaking about? And we say that transformative change must occur on all scales. And research has shown us that there is actually no correlation between awareness of climate change and corresponding behavioral change, meaning that we can learn as much as we would like about a problem and tell people about it, but it is not often enough to actually increase engagement with an issue. And so what is effective at the local level if learning about a problem itself just isn't enough? And there are 8 identified biggest drivers of social engagement. So things that actually drive people to implement these changes that are necessary. The first of these is in promoting educational opportunities. And another is in generating knowledge that is inclusive of different ways of knowing. So including Western sciences, as well as Indigenous knowledge and local knowledge. So this stems from this, from this stems the idea of transformative learning, which are these informal learning opportunities. So learning outside of a formal classroom that can alter your paradigm. So the very way in which you see the world and see your place in it. And there are some incredible studies showing the benefits of informal learning opportunities and how successful they are at altering worldviews about climate change and about environmental issues. And that's because these informal learning experiences can change not only people's knowledge base, so not only contribute to what they already know, which as we know is not always effective, but also their fundamental beliefs, their perceptions, and their behaviors. And learning in these settings tends to be self-directed and often involves personal choice. So participants are able to choose to participate in things that actually interest them. And by doing so, engage in these topics, and they can see their relevance, its relevance to their own lives. So I'm now going to quickly shift over to provide a brief overview of the Great River Rapport project, and then we'll be connecting these 2 concepts of transformative change and the Great River Rapport by talking about the Great River Rapport workshops and how these were an opportunity for transformative change to occur. So the Great River Rapport project is run by Dr. Lee McGaughey and her incredible team at the River Institute, and is an ecosystem health report of the Upper St. Lawrence River. The project came about as a result of the commonly asked question by community members asking, how healthy is the St. Lawrence River? And the project is framed in the words that come before all else, the Thanksgiving address. And as part of the project, a set of 35 ecological indicators were identified through consultations with scientists and with the public. And it brings together Indigenous knowledge and Western science, and it aims to really engage the public through storytelling and art. As part of the project, we ran a series of 17 workshops, some of which were part of this Ever Wonder How To series. And the aim of the workshops were to cover a variety of topics relating to the Great River Rapport project, and to really engage the public in the work that was being done, and by providing these opportunities for informal learning opportunities to occur. So some of the workshops held were by some of our amazing Indigenous partners and collaborators, all of which related directly or indirectly to the health of the river. So we had workshops with Abraham Francis, with Sathiokwa Buktu from Snipe Clan Botanicals on medicinal tea tasting, a workshop by Deo Skitters from Mohawk Council on beaver skinning and trapping. We also had workshops on community action, so looking at some of the existing efforts by community members and looking at what they're doing. So community members like Cristina Cismasu, who is helping monarch butterflies, or Nancy Hildebrand, who spoke to us about how to forage safely, ethical foraging practices, and how to make dandelion tea using ingredients from your own backyard. We also held some citizen science aimed workshops. And so we had lots of these with our wonderful partners. So for example, we had a workshop with Watersheds Canada on how to naturalize your shoreline property, and with water rangers who make these really incredible water testing kits on how to collect and share water quality data. We also had a panel discussion with Lawrence Gunther from Bluefish Radio, and we had 5 different panelists who were researchers or anglers discussing the use of the MyCatch and Anglers Atlas apps. And I'd love to speak to you more about all of these workshops in detail, and I could go on all day, but I'm wary of time, so I'll just give a brief overview. We also held quite a few scientific workshops highlighting the work being done locally on the St. Lawrence River, and with all of this work being done also at the River Institute itself. So looking at eels, how the FINS team studies fish, catching and tracking bats with Dr. Brian Hickey. So all of the amazing work occurring on the river and highlighting some of the ways that the public can actually get involved with this research. We held an art workshop with Christine Fitzgerald, who is a local artist specializing in cyanotypes, a photograph which develops through sun exposure, which you can see in the bottom 2 photographs here as it's getting exposed. And the workshop was on the Great River Report project itself and the indicators, and really aimed to provide an opportunity for the public to get engaged with the project in a different way. And the intention is that hopefully the art piece might be actually showcased at a number of exhibits throughout the years. And if anyone is interested in knowing more about these workshops, the link for the River Report project is on the bottom left of the screen here. And they can most of them were recorded and can be watched. So we had lots of different goals for these workshops, and the aim of them were quite multifaceted and had different, scalar intent. So we've got long-term goals, medium-term goals, and short-term goals. So ultimately, in the long term, the goal is to engage the public and to achieve a sustainable, thriving, and resilient river as well as community. In the medium term, the aim is for these workshops to connect the community to the river and to really help create and facilitate these environmental networks of people who care about the health of the river. And in the short term, it's a matter of providing these opportunities for engagement to occur. So for people from all different interests, professions, hobbies, and backgrounds to come together at these informal learning opportunities to learn about something that really connects us all, and that is the health of the water and our ecosystems. So in total, we held a total of 17 workshops, which reached over 2,500 participants, both virtually and in person. We had 97 volunteers who volunteered 360 hours, so quite a bit of their time to these workshops. And we were able to run them with 20 different organizations, so a really great opportunity for collaboration and partnerships to occur. But of course, the success of these workshops really lies, I think, beyond the numerical figures and looking at how these workshops are a tool for transformative change to occur. They allowed people to meet, to network, to meet other like-minded individuals and really enrich this network of people who care about the environment and who care about the health of the St. Lawrence River, no matter what background that they're coming from. And by engaging the public in different elements of the project, it aimed to provide opportunities for people to see their place in the research itself and how it influences their own lives and how also they can get involved. And it's more so in these real life experiences. So taking part in the science rather than just always hearing about it, or, recognizing that art is a very powerful medium through which to communicate environmental efforts, that we can, make more of an impact on the ways in which people view the natural world as well as their place in it. And of course, these workshops were, there's lots of people to thank for these workshops. Most importantly, I think all of our partners and collaborators who helped us deliver them and run them and host them are lots of them. Some of them are here at the symposium, so I would encourage you to watch some of their presentations, as well as our wonderful River Report team, especially Stephanie Hildebrand and Zachary Zwanenberg and Lee Magahi, who have always been super helpful in delivering the workshops, and our River Institute administration and funders, particularly the Great Lakes Local Action Fund, who made this all possible. So that's it for me. I'm going to stop sharing my screen now, and we will enter into the open question and answer period. All right, everyone is joining us, wonderful. So we'll spend 10 minutes in the question and answer period. And if anybody does have questions, again, I would invite you to drop your questions into the YouTube live chat box, and just to specify who the speaker your question is for. And I'll keep an eye out on the chat box to see if there's any questions coming in. And if there aren't, I have a few of my own that I'd be happy to ask. And if any of the speakers also have any for each other, then I would invite you to of course, ask them. So I don't see any so far that have come in. So I guess, Jessica, I had a question. I went to the University of Guelph. And so when you said that you partnered with Guelph, I thought it was really interesting and quite exciting. I was curious if you actually sampled at the Guelph Arboretum.
No. So yeah, a little bit more about how we did the plant samples. My master's student, Mia, looked at historic Indigenous trails that fall within the geographic boundaries of the Greenbelt that's been established by Ontario. And she found a bunch of trails and portages that overlap with current public trails, like historic Indigenous trails that overlap with current public trails. And that's how she selected the sites where we would do ground truthing of plant biology. She and the two other research assistant students collected over 2,000 herbarium voucher specimens as part of this project. So, and those are deposited at the Guelph Herbarium. But University of Guelph is, supporting my postdoc on this. And as part of that, I'm part of the Conservation Through Reconciliation Partnership research team, as well as the People, Plants and Policy Lab. And then also working with Plenty Canada. And as you know, I've also been working with Mohawk Council of Akwesasne and St. Regis Mohawk Tribe. So working with a lot of people. Yeah.
Perfect, thank you. We have a question here in the chat box. So question for Dr. Dolan, what is your favorite plant and why?
Did Kayla ask that question? I can't see, but that sounds like a Kayla question.
It was actually Marianne Pearl.
Okay, so our most exciting find on this research was when we found pawpaw that had, Royal Botanical Gardens of Hamilton was one of our sites, Cootes Paradise. And in the second subplot in Cootes Paradise, we were in the forest and it was not an area that had been planted by humans. It was just a forested area that's protected as part of Hamilton Royal Botanical Gardens. And we found pawpaw there and we were so excited to see that pawpaw had been seeding itself or being seeded by its supporting species, because pawpaw, there's kind of a resurgence of pawpaw in Indigenous communities as a historic food. And a lot of people are trying to grow pawpaw on their own, and it's very finicky and hard to grow. So we were really excited to see the pawpaws there. That doesn't, I don't have an all-time favorite plant outside of this project, but I have to say that I do love I love the common plants that I grew up with, like the basic, I love milkweed for how beautiful it is, and its globular flowers and its beautiful seeds. And there's a lot of plants like that, orange daylily. Yeah, but yeah, pawpaw was the most exciting find.
Perfect.
Can I ask a question of Jessica? I'm just wondering, so the caretakers of Bell Island are involved in a kind of project where there's a lot of buckthorn there. I don't think any of them are here. They should be asking the question, but it comes to my mind. So there's a lot of buckthorn. There's an oak forest that is quite aged. And so there's a question of how to kind of thin out the undergrowth so that saplings can come up and be the next forest there. And so they've been planting various small trees, and it's a complicated process that we would always welcome more input on. But I guess my question is about whether planting native trees that would have lived further south, looking towards the future, is a philosophy that, and this maybe is a question to both of the other panelists or all the other panelists, in terms of, so there are traditional plants that Anishinaabe and Haudenosaunee people would know as part of their tradition in this area, but then there are other plants that may be more suitable going forward. And do any of you have ideas about how people think it's right to handle that if there's replanting happening?
I have an idea. I don't know if it's doable. But what about working with environment departments of local First Nations, like Akwesasne, Tyendinaga, and other local First Nations, to do a controlled burn of Bell Island? And so using historic forest management, Indigenous forest management practices to see what comes. Because it's true, like I always cite Henry this way. Henry is, he developed this beautiful way of describing that the trees are walking north with climate change, like the species, plant and tree species are walking north. But I don't feel like we don't necessarily have to help them by planting them, but by creating the conditions in which they will plant themselves. So for sure, getting that buckthorn out of there, like probably has to be manually, but then why not try, since it's an island too, a controlled burn of the understory with Indigenous experts on controlled burning. What do you think, Valerie?
Yeah, on the West Coast, we call it cultural burns, but you know, the nutrient cycling and the seasonality of burns that involved Indigenous people and nature really supports nature doing their thing with tree and savanna and plant natural succession. I mean, that nature, that's where we learn this, is through nature. So, but really good point. Thank you, Jessica.
Even in the, oh, sorry, I was just going to say, Clint Carroll has in his book, The Roots of Our Renewal, he has a really wonderful description of Cherokee burning practices in forest understory. And he talks about how that also helped to keep tick and chigger species down, which had been, you know, which helped to keep the deer species healthy, the ungulates healthy. And that's a really good book to read about that. I mean, there's others. There's many wonderful books like Kat Anderson and wonderful books on Indigenous burning, but that one just came to mind.
Well, I'm not sure if that's being pursued, but it is. So the Mohawk Nation Council of Chiefs co-governs the island along with the city of Kingston. It's quite complicated sort of diplomatic structure, but you know, that could be something to. And then the folks here who are members of the Indigenous community in Kingston have, you know, been doing, I guess, in a way, a little experiments with the buckthorn and so on. And of course, it's sort of attached to the park, which is, again, this sort of used to be a golf course, used to be a wetland space. So it's all unclear, but that's a strategy I will mention to them and see if they have considered.
Yeah, MCA, contact Kayla. Kayla Sunday is the interim environmental program manager at MCA Environment, but Kayla and Ibrahim and the others there would have some great ideas about maybe how to go about that. Yeah, and invasive species are really interesting in terms of what are they here to teach us. And some of them, it is important to try to remove them because they're successional species that came from disturbing the landscape anyway. Golf course, wetland. So I think it could be really interesting, and I look forward to hearing what happens. I'm aware of the partnership with Bell Island because I was working as an environmental science officer for a little while. So I think that could be a really wonderful project to undertake together. Yeah.
Thank you.
Thank you so much, everyone. That was great discussion there at the end to wrap it up. So thank you, all three of you, for your great presentations. I'm just wary of time, so I think we'll pass it on over for the next session. But again, big thank you for your time and those great presentations.
Main speakers, who is Jessica Jock, and she is the Remediation and Restoration Program Manager at the St. Regis Mohawk Tribe in the Environment Division. So Jessica, she has worked for the Environment Division for over 20 years and oversees 6 full-time staff. Her program includes activities related to the federal and state-listed Superfund sites in Messina, New York, brownfield, and abandoned home sites in Akwesasne, and all things related to the St. Lawrence River area of concern at Messina and Akwesasne. In 2019, she led the first of its kind state-tribe coordination agreement for the management of U.S. domestic portion of the AOC in the Great Lakes. She is a contributing author to the New York State Lake Sturgeon Recovery Plan in 2018 to 2024. The guidance document on traditional ecological knowledge pursuant to the Great Lakes Water Quality Agreement in February 2021. Created, designing, and applying ethnobotany in the Indian Meadows grass river for the Mohawk of Akwesasne in 2017, and led her team to the first successful freshwater mussel propagation operation. So I have worked across from Jessica for a little bit. We both know the areas of concern, and I'm very excited to introduce her and to hear her talk. So without further ado, Jessica, I will hand it over to you.
Nyawa, Georgia. Okay, so let me just go ahead and share my screen. And I was listening to the introduction. Perhaps I should have shortened it, condensed it a little bit for you. Let's see here.
Yeah, sorry. Right. Sorry, I might have butchered a little bit of it. So if you wanted to introduce yourself, that would be great.
Can you see my screen okay?
Not yet.
Okay, hang on.
Yep, now I can see it.
Okay, all right, great. All right, so I noticed you did skip over a few words in the introduction, like I would have as well, because they were in Ganyageha. And so I'm just going to go ahead and get started. You said you can see my screen, correct? So thank you for the introduction. I have worked for the St. Regis Mohawk Tribe for 20 years. And today I'm coming to you from Niganjage. Actually, I live on the shorelines of the Grass River. And so today I'm just going to focus on the beautiful teachings of Niganjage. And to me, this background was kind of inspirational because I've heard yesterday in some of the presentations, you know, water is life, the river has energy, we know the river has energy and power. And when I see this design, I think of electricity and electrons and just energy messages being sent through the river. And that's kind of how I view the river from a more personal approach. But when it comes to my professional and scientific approach, you know, we have to use data and we have to use the the other observational methods and documentation. But I wanted to give some acknowledgements first rather than at the end of my presentation. I wanted to acknowledge the organizers for creating this platform of ways of knowing. I've worked professionally, like I said, for the tribe for 20 years. And I think we're coming upon a time of where it's really important to share the different knowledges and systems. And this wasn't the way it was 10 years ago or more when I first started working at the Environment Division. So the different panels and the other panel presenters and plenary speakers, they really helped lay the foundation of a lot of the things that our work is based on, and consistent messages. And a special thank you to Henry Lickers for the Ahoda and Gully Wadekwa and the opening and the reminders and responsibilities of our relationships to the environment. And, you know, that's one of the things when I get into more of my discussion. In the background that Georgia provided, I basically have built my professional career on contaminated sediments and the Superfund sites as they're managed by the U.S. Environmental Protection Agency. And having those kind of relationships and responsibilities to the waters, it's one of those things where it's so important to take a step back from the engineering science and the decision making and remind ourselves of those responsibilities and relationships. And a few other acknowledgements, my tribal leadership, the Sirinjas tribe leadership over the last 20 years of my career, my Environment Division directors, for allowing me to continue to, allowing and trusting in me to be an advocate and to speak on the sovereign issues, the traditional issues, as well as the Akwesasne Mohawk community, the teachers and the knowledge holders for sharing with me and trusting in me. And I say that because I'm not Unwin-Hunwe. I'm not from Akwesasne. I'm not Mohawk. I've received that question many times because my last name is Jock, and there's many Jocks in Akwesasne, but I'm from the Bombay Jocks. And so just a little bit more background from myself. I grew up just southeast or south of Akwesasne in a little town called Bombay, New York. We're on the state side here. And but, I'm thinking of ways of knowing and some of our early on introductions to the different cultural components and language. I reflect on when I was young, my early years, my early years of elementary school. I actually went to the St. Regis Mohawk School in pre-K, kindergarten, and first grade. And so I was introduced to the language, not that I speak it now, but I was introduced to the language and counting numbers and some simple words when I was young, as well as immersed into the different student body interrelationships. Same with my education at Salmon River Central School District. And so I mention this because to me, my ways of knowing is that I've always experienced that Mohawk cultural integration in some sense, not in the sense that I know it now from working for the tribe and learning about the environment and the environmental issues, but that it wasn't unusual to me. And so I say that because in my professional career, I've learned that it is unusual to some, and it's unusual to some neighboring community members. And that's something that I try to achieve in terms of science and other ways of communication that to bridge that gap. And I say that in the sense that I said that I'm sitting here on the shoreline of Niganjage, the Grass River, which also, as I get to in a few minutes, is the village of Messina. So I do live here in the village of Messina now. And then just a little bit of the background to my professional career. The federal Superfund sites, a lot of my talk today and lessons learned stem from the Grass River Superfund site. And almost every action that I've done since then has to do with how do I help resolve this problem? How do I better communicate to the federal agency decision makers or the support agency from the state, or communicate effectively that we as in representing the St. Regis Mohawk tribe is a sovereign government with the same authorities. And I started working for the tribe when I was 23 years old. So I feel like I've developed quite a bit in the last 20 years in terms of my ways to communicate with the federal agencies and the state agencies on these matters versus coming in at 23 years of age with very little information and understanding myself. And so it's because I was in those positions to talk about the importance and the significance and the sovereignty of the issues related to this particular stretch of the Grass River, to be able to effectively express the significance and the cultural significance. And so I did just put this slide in here. This was the description of my talk, but I wanted to make sure that, when I talk about recounting the teachings of the river Niganjage, just in terms of place, so Niganjage as a place name is a Mohawk word that refers to full of big fishes. And so when I started my job working on the Grass River, I was told that was one of the very early on pieces of information that I was provided from the Mohawk language and how it relates to the environment on this river stretch that I was working on in the Grass Rivers. That means full of big fishes. I'm like, okay. And then it also refers to the Grass River itself, but it also refers to the village of Messina. So this image here, I wanted to also include because that Niganjage is the word referring to the water and a place, but then there's also another Mohawk word that refers to the Indian meadows and the shoreline and the landscape. So I just want to make sure that that's clear, because as I talk about, the different things that I've learned over the years and the teachings, that there's some different words that are used, Mohawk words that are used for different places on the river. So how do I weave a river story? Or how have I, for me, this is my own personal experience of ways of knowing, and my 20 years of experience of the pieces of information were weaved together through history and archaeology, observation and science, and then the Mohawk biocultural context, which is a term that I've adopted from my friend Abe Francis, who uses. And the Mohawk biocultural context, from my understanding, refers to the traditional teachings, the Hodengaliwadekwa, and the Great Law. And so some of the beautiful teachings that I'm going to refer to, I also want to acknowledge that there are individuals that have provided their own shared experience and knowledge, whether it's historical, archaeological, scientific, or a cultural context with me, that has helped put the pieces together. And so as I'm trying to represent the tribe and looking at this very complex sediment Superfund sites and the contamination issues and what that means in terms of biotransfer to the people and the perception of the people of the contamination, it's also how do you communicate to EPA the significance of that, especially if they're engineers. And so that's one of the things that I would find quite often, is that trying to have this conversation of cultural significance, but I'm communicating with engineers and they just weren't seeing things the same way. So anyway, this slide was mostly just to help remind me to stay on track with acknowledgements of certain individuals. And I wanted to recognize that over my 20 years of working for the tribe, I've had the privilege of working with 4 different Tribal Historic Preservation Office directors, including Francis Boots, Cherie Bonaparte, Arnold Printup, and Darren Bonaparte. And they have contributed to some of my knowledge on the 1796 treaty, the history of the area, as well as the landscape that we talk about when talking about rivers and land and what that means to the community. And then Francis Scudera, he has been a significant help in understanding the science of the historical findings as well. And then historical records. I was led to many different historical records to review to help support, because when you're talking with funding agencies, or I shouldn't say funding agencies, federal agencies, they're always looking for, lines of evidence. You have to have some smoking gun of line of evidence or reason to why you're expressing something that you're expressing if it's non-scientific, that hasn't been proven. And so one of the great resources to me early on in my career was Darren Bonaparte and the Wampum Chronicles and his research that he had done with local history of Akwesasne and in the Mohawks of Akwesasne. And the science and observation, component of it. So if we think again of that image of where we're weaving the history, archaeology, science observations, and Mohawk biocultural context, a lot of the science work that we do, it's driven by, what trends are we seeing? Are we seeing any new phenomenons? Is there presence, absence? And it's driven by data quality objectives and study design. So a lot of the work that has come out of the Grass River that has been led by the St. Regis Mohawk tribe is in part due to, the support team that I have from my staff. And in particular, Jay Wilkins, Santiago Bucktooth, Colby Bowman, to help bring in those observations and the study and awareness over the years. And then last but not least, I just wanted to acknowledge a lot of the cultural teachings. I was in a very unique place of where the St. Regis Mohawk tribe, while pursuing some of the damage lawsuit with the natural resource damage assessment for the Superfund sites, there was the development of the cultural component of that, and then the Akwesasne Cultural Restoration Program to restore the people to the environment from the contaminant damages. And through that program that was developed, led by Goodness, Barbara Tarbell, and others, that piece during my environment division working relationship really helped fill the gaps of the science. So I was able to draw from other professionals on the historic, the archaeological, the science and observations, and then that program really complemented and filled in the rest of it. And so just briefly, some of the other knowledge holders that were, contributing to some of my teachings, like that taught me and the lessons that I've learned, included Vaughn Adams, Amber Dawn LaFrance, Norman Peters, Ernie David, Alicia Cook, Mary Arquette, and Dorothy Lazor. Galoahewe, she helped with many of the accents in the Mohawk words that I have in my presentation here. So to get to the Grass River, sorry, that was a very long intro to talk about my ways of knowing. So the Grass River is, the headwaters are in the Adirondack Mountains in New York State. And it's, if you're just to look at as the crow flies, approximately 70 miles long. But when you add in the different branches and tributaries and connecting waterways, it's hundreds of river miles. But in terms of, I don't know if my cursor is viewed on the screen or not, but those who are familiar with where Akwesasne is and those who attended the conference yesterday in person, you were sitting in Cornwall, Ontario. The river stretch that I'm referring to is in the United States on this northern portion of what's considered New York State, but it's just east. I'm sorry, it's just west of Akwesasne. And you could tell by the river that from Akwesasne and Cornwall Island, you could traverse upstream, navigation by boat, up to the lower Grass River, the Messina, the village of Messina, And then the river continues up through Louisville, Chase Mills, Madrid, etc. And I mention that because we will be talking a little bit more later about some of that navigational pathways and significance of what that means in terms of landscape and connectivity of the Grass River to Akwesasne. We're in this, day and age where people segment it from, you're in this village or you're in this Mohawk territory or the boundary area based on some survey done in the 1800s. But if you view it from the perspective of the Mohawks pre-New York State boundaries or St. Lawrence County boundaries, it's more of a landscape perspective. So oftentimes what was at the heart of many of our discussions for the Grass River was the Seven Nation Treaty of 1796. And I put this language in here because it is in historical documents. And I wanted to just try to outline some of the complexities of it, I guess, the complexities of the language, where it's not very long, it's not very lengthy, but it's called the Seven Nation Treaty. And this is where a lot of my conversations with Darren Bonaparte early on in my career were very helpful, because I had to have conversations with him of trying to understand. I said, I don't get it. I've heard of the 5 nations, the 6 nations, but what's the deal with the 7 nations? And he was very eloquent in his response. And if you ever have a chance to review some of his Wampum Chronicle presentations or written records, a lot of it was in terms of that time period of alliances and how, during different warring periods, you got to keep in mind, this was after the Revolutionary War, the American Revolutionary War. And there was a lot of different changes that were occurring and alliances prior to that, the hundreds of years, multiple hundreds of years prior to. So changes of communities and villages. So anyway, with that being said, the Seven Nation Treaty of 1796 is representative of the Mohawks of Akwesasne, regardless of whether it's New York State or reference of 7 nations versus 5 nations or 6 nations. And so what it says here is that said deputies having suggested that the Indians of St. Regis have built a mill on Salmon River and another on Grass River, and that the meadow on Grass River are necessary to them for hay. And I had emphasized that part intentionally, so that way you can see that the written language talks about the meadows on the Grass River in reference to significance of hay, and that this area should be reserved to the said village of St. Regis. In like manner, said tract is to reserve tract of 1 mile square at each of the said mills and the meadows on both sides of the Grass River, from the said mills thereon to its confluence with the River St. Lawrence. So I bring this up because when I first started working for the tribe, again, I was interacting with the United States Environmental Protection Agency, EPA, on the contaminated Superfund site on the Grass River. And the Grass River, from the perspective of New York State, it's in New York State territory, not Mohawk. And EPA was, taking the position that we're not in a place to, determine any kind of land claims, things like that. But I brought this to the project manager's attention, and I'm like, I'm under the impression, because this was a piece of information that was given to me saying, this is our land, this is our waterway, this is our territory. We have a sovereign, authority over what happens in this river. But when you communicate with other agencies, they're like, well, that's not what this says. That's not how I'm reading this. And so then you have to kind of take a step back and read it from their perspective in order to understand the miscommunication. I took it, as it's a treaty, so it means it's valid. Whereas when they start reviewing the language and the interpretation of it, it's like, well, and again, at this time with Superfund site, we were talking a lot about fish, about, the significance of different fish species in the river that are important to Mohawks. Why aren't some of these areas being sampled for Mohawk consumption risk assessment? Why aren't certain fish species being considered that have cultural significance to the Mohawks? And the response is, well, this doesn't say anything about the fish. And this refers to the meadows, not to the water. And so it was this moment of realization that there was more work that was needed to convey the significance of it, and from the perspective of what what may have been interpreted by the Mohawks. And so this is just a quick visual of, for those who aren't familiar with the Grass River Superfund site and the study area, the Grass River Superfund site study area is the same exact river location as the Indian Meadows that was reserved in the 1796 treaty. And then in this image as well, I included a little green box up in the village of Messina. And this is approximate. This isn't to say that I'm outlining any kind of treaty boundaries here, but this is just to give you the area of study for the Superfund site, as well as the same part of the treaty rights. So while I was attending meetings, including public availability sessions as the representative for St. Regis Mohawk Tribe, but availability sessions that were being held by EPA and the responsible party for the contaminated sediments, I would attend these community meetings, and there'd always be questions that were asked relating to cultural use of, can we eat the beaver? Can we eat the muskrat? Are you testing the medicines? Are you, what about this? In terms of how we view the natural world and our exposure assessment. And the answers would normally be very similar of, that's not, it's not required under the regulatory authority, or there's no reason to indicate that what studies are being done under any kind of New York State eco risk assessment or other risk assessment was not inclusive of those concerns. But we knew that it was not included because nobody was testing the plants. Nobody was testing the muskrat and beaver or other aquatic fur-bearing mammals or other species of concern that were mentioned in some of these community meetings that were held in Akwesasne. So I've broken this down into what I'm referring to as beautiful teachings of Niganjage. And again, with the premise that when I started working on the Grass River Superfund site for the St. Regis Mohawk Tribe, I was basically given a couple pieces of information of the, it's the Mohawk word for the Grass River is Niganjage, and there's a treaty that reserves our rights, and the river is significant to the Mohawks for fish and medicines, and that it's obviously a very important process for the tribe to be involved in, because the federal agency was the lead agency making these decisions. And so as we were building our capacity to be involved in these very complex scientific discussions about bioavailability of PCBs and other contaminants, that we were also involved in the policy and the cultural components of it too. So the beautiful teaching number one that I took from working the last 20 years on the Grass River is the canons of treaty construction. And if you haven't heard of this before, it's in reference to how treaties should be interpreted, with the understanding that this treaty of 1796 took place hundreds of years ago, and that you're making some assumptions that there was a language barrier with the entities that were involved in the negotiations, and that the history that was written was likely written in a way that benefited the ones that were in power. And so the canons of treaty construction for Indian treaties says that there are 3 principles that you should that assume that there's ambiguous expressions must be resolved in favor of the Indian parties concerned, and Indian treaties must be interpreted as the Indians themselves would have understood them, and Indian treaties must be liberally construed in favor of the Indians. And when going through this, we'll talk more as we proceed through the different slides, but one of the first things that we grappled with in going through this is, well, okay, well, how is it construed by the Mohawks versus what do the surveys say? Because then the surveys came in afterwards and were done later in the time period. And the surveys, both for the Indian Meadows as well as the mile square, was it representative of what the intent of those parcels were? And as we look at, and keep in mind, when I'm going through this with my interpretation and ways of knowing, I'm basing it on where I was professionally with how we use the information for environmental decisions. It wasn't necessarily for any land claims effort or other use. It was for specifically for federal decisions being made on the water. And that included, I didn't mention it in a couple slides ago, but it also included, there's another action that was related to ice management, but it was a FERC process, so Federal Energy Regulatory Commission, for constructing a dam. And so when looking at the canons of treaty construction for Indian Meadows for environmental decisions, early on, there's a lot of questions that I didn't have the answers to. I didn't know, what did the Indian Meadows mean? The treaty said used for hay, and if you take that literally, that's a whole different use than what makes traditional sense. And then what is that area? How are the Indian Meadows defined? Trying to think back in the 1700s, what would the Mohawks think the meadows were? Was it just the shoreline? Was it the riparian? Did it go back a distance? And then, the mile square, what was the significance of that area? They mentioned in some of the historical literature the mills, that there is a mill there, and but from other uses, that aren't mentioned, waterways, navigation, that area of Village of Messina we call the rapids section, if you're looking at it from a habitat perspective. So there's riffle rapids during high water, spring flow, high rain events, and fall. And to me, when looking at it from a scientific perspective, that's fish movement, that's fish passage, that's migratory patterns for our lake sturgeon, salmon, and walleye. And so kind of going back to those thoughts of, what could have been important about the mile square, and those discussions evolved in part around, what if there was no longer fish passage because there was a dam built or a dam placed there. So the last, well, not the last part, but one of the other parts, so I brought up this figure. So I mentioned earlier that, you got to think of the landscape. And so the Grass River, and Niganjage refers to the Grass River, as best as I know and have been informed, even as far upstream as Canton, New York. And so it was in reference to some of the travel pathways. So it wasn't just to go from the St. Lawrence River upstream to the Village of Messina. It intended on continuing further upstream, navigating the different waters. And so what I failed to mention before when I had a different image up, for those who are familiar, the Moses Saunders Hydro Dam is located just upstream on the St. Lawrence River, but just upstream of the confluence of the Grass River. And so why I'm mentioning navigation and bypassing the Long-Sioux Rapids is in the 1700s, there were Long-Sioux Rapids. And while some very skilled navigation could probably portage around them or, find other ways, it is suspected that the Grass River was a navigation route to get upstream of get upstream of the Longsu Rapids. And what this image here shows is that if you could get upstream far enough to this Chase Mills up to Louisville, it's less than a mile to Portage, to the Wilson Hill, what's now called the Wilson Hill Wildlife Management Area, to the St. Lawrence here. Or if you were to continue to navigate upstream to Chase Mills, there's some water that during high water levels or other events would likely dictate an option to be able to get to the St. Lawrence River upstream of the Longsu Rapids by navigating through the Grass River. So that was one of the things that through discussions with one of the previous Tribal Historic Preservation Office directors and archaeologists, and trying to think of, this from a landscape perspective and a historian perspective of how was the Grass River used by the Mohawks in that time period that that didn't just result in use of a mill or other. And then the other discussion that came up often was, this area, how was the rapid section used in terms of fishing? And one of the conversations from an archaeologist was, these photos here are not from the Grass River. They're not from Niganjage. They're just examples provided of what a historical Iroquoian fishing pier might look like. And here you might be able to see, it might be difficult to see, but in the photo to the left, this V shape, and what they were is fishing piers of trying to make it so that the fish, as the fish are moving upstream, are kind of corralled into where you would then spear them or catch them without much effort, because it's easier to catch fish in shallower waters than in deeper waters unless you had the boat and other means. But here you could do it by foot and by shoreline. And so that was one of the conversations, that was discussed, is just, what would the significance of this riffle section be? And then what fish would use this water? And it was, over time discussed a lot of lake sturgeon. We're always working with our partners from New York State Department of Environmental Conservation and others in that time period of like 2005 to 2015 of what is the significance of the Grass River for lake sturgeon, because they knew from a biological perspective that lake sturgeon had a residual population in the Grass River, and that the Grass River wasn't one of the rivers that were being stocked in their stocking program. And so why was that? Why were there lake sturgeon in the Grass River that had a healthy population, adult population, a spawning population, but not in other tributaries? And so there's a lot of dialogue and discussion in my career between 2005 and 2010 about the lake sturgeon in this stretch of the river. And so I just brought some of these pictures up, in terms of, the historical dam that was there, the breached weir. There's many different conversations that came about this, but the reason that this became part of my working dialogue was because those who are familiar with the Grass River Superfund site may be aware that ice jamming became an issue for resuspension of contaminated sediments. And so the ice jamming and the erosional forces below that jam were redistributing PCBs downstream. And so as one of the management options to try to figure out how best to engineer a remedy for those contaminated sediments, one of the options that was presented by the responsible party was ice control. And through the discussions of ice control, whether they be ice control structure piers or some other mechanism, a conversation about rebuilding a dam in the village of Messina to be able to capture any of the ice flows that are coming downstream, to be able to manage the ice above the Superfund site. And so at one point in time, there was a dam proposal that was going through FERC review to be a multifunctional hydro facility. And this multifunctional purpose was for ice control. And it garnered a lot of support from the community of Messina because this dam was here previously. And it was this very simple conversation of, there used to be a dam, it held back water. We like that water behind the dam to be impounded, and we want to have, that impoundment again. But what they didn't realize is that this would be a completely different dam. And we're now in the 2000s of time period, and you can't just build a dam in New York State without looking at the adverse effects and impacts to the ecosystem. And one of the important pieces of the ecosystem was the fish and fish migration coming from the St. Lawrence River. And the reason I mention this is because you can see these images here. The dam that was constructed in 1912 over time just degraded on its own. And I'm going to draw your attention to this picture in the center of where this gap is to the left, and keep that in mind because that was assumed to be historical fish passage, because there are some assumptions that were made during the conversations around FERC is that, well, the lake sturgeon weren't able to progress upstream anyway because this dam was in place. But there is this gap here where some assume that there could have been fish passage if you had the right flow conditions. And if you look in the photo to the right, when you have high spring freshet flows, that there is quite a bit of water there, and that depending on the fish species would likely be able to pass upstream under the low head weir conditions. So beautiful teachings number 2 was that the Mohawk word niganjage, meaning full of big fishes, is accurate. Through the work, there were studies that were conducted with not just fish passage, but multiple studies in 2007 to 2009 about fish community assessment above the village of Messina in the Grass River. And there were telemetry studies done for lake sturgeon. There were egg trap studies done for lake sturgeon in that riffle area. And what was found was that, yes, lake sturgeon are in this river. Yes, lake sturgeon are spawning in this river. And there's also other fish, walleye, that are here. Well, I shouldn't say everybody, but the fishermen knew that the walleye were there and that they pass upstream as well. But one of the other findings from those fish community studies in the year 2007 and 2009 was that there were salmon in the river as well, and that they were observed, and as well as American eel and muskellunge. And so this basically, between some of the piecing of the history as well as the field studies that were done and the conversations, was that niganjage is an accurate word for the Grass River. And this was further demonstrated by anybody who is familiar with New York State Department of State Coastal Fish and Wildlife habitat significance, that in 1994, it was documented that there was observed lake sturgeon spawning in the Grass River, and that it's believed that the Grass River is important refugia for muskellunge as well as lake sturgeon. And what we know now from different studies and communicating with those who do the fish collection for the different entities, that there have been observed young of year muskellunge, and as well as we ourselves at SMT Environment Division have confirmed and observed lake sturgeon spawning in the Messina Village rapids just downstream of that breached weir. And so it became very important to us that we understood, the past, the present, and the intended future of this downtown Village of Messina Riffle section in the Grass River because it is an important area for fisheries. There was another interesting piece of history that was found and shared with me. This is over 10 years ago, but it was during the discussions of, what if we were to build a dam? Of that, in 1824 in St. Lawrence County, there was an act passed that made it, declared the Grass River a public highway and for other purposes. And the other purposes were related to requiring that every dam have slides, aprons, sluices, or other passage to admit all fish upstream from the confluence to, I believe it was up to Canton, New York, from spring until June 1st. And again, reiterating the importance of that it was known then that this body of water had large fish that needed that migratory passageway from the St. Lawrence upstream in the Grass River. So this is just an image to show some of the, to the left is a picture of Jay Wilkins when we were doing our own radio telemetry work, and we were able to observe in 2017, I think the year was, lake sturgeon greater than 1 meter that were congregating there in the area, as well as we observed the spawning behavior. And through the tagged fish, you were able to tell if it was an adult female or male. And so just with the scientific data behind it, and we were able to confirm, yes, with certainty, we know sturgeon are spawning in this reach of the river, and it's an important reach of the river for our restoration of sturgeon populations. The middle picture is with Vaughan Adams giving a demonstration of night lining for sturgeon, and we have been working with Vaughan with some of our own lake sturgeon studies, as well as tagging and releasing. And so these sturgeon here were tagged and released, and we're tracking them to see if they move up into any of the tributaries for spawning next year. And then I just like to always include a picture of a young of year sturgeon through the propagation efforts of New York State and in the spring of each year, and then each fall they bring them back to release into the waters by the St. Lawrence River. I'm probably running out of time, so I'm gonna move on to beautiful teaching number 3. And this is another important one, and another one that's near and dear to my heart. The Indian Meadows hay, if you remember the language of the treaty, Indian Meadows hay is not for horses. And I say that because there was some, I think, discussion early on, and I'm trying to, trying to remember all the conversations over 20 years. But there were some people from agency or responsible party, because they obviously had a vested interest in knowing how the St. Regis-Mohawk tribe was progressing in the conversations with EPA on this matter, who may have interpreted and point blank said that the hay was not significant for any cultural use. It was more so for, other grazing animals. And so I put in here, just to keep it very clear and succinct, some of the findings that the St. Regis-Mohawk tribe had when we went out and we did our own floral surveys, and we pieced together in our own report, it's cited on the bottom of the slide here, of some of the plant species that would be culturally significant to the Mohawks of Akwesasne. And in some of that discussion, and as it relates to the treaty and the Grass River, in Indian Meadows is, that first bullet says, when hay is used in the colloquial sense, one may envision fodder for grazing animals. Hay, though, can often refer to dry grasses, legumes, and other herbaceous plants. Many traditional foods and medicines were harvested and prepared this way from grasses, legumes, and herbaceous plants. Some were dried and were ground into flour. Groundnut and cattails are just some of the plants that can be ground into flour and were found growing in abundance along the Grass River in the summer of 2017. It is easy to surmise that these species were in even greater abundance during the era of the mills. And that was one of that sentence was crafted from a botanist and a traditional knowledge holder with plants and medicines, Satego Bucktooth, and then also pulling in the pieces of the history of what we found in different historical documents of that, you know, when looking at the meadows, you know, what was important about those meadows. And the Ganyageha name for Indian meadows translates to where you pick the grass or where the grass is picked. And so we kept coming back to this word grass, like what does that mean in terms of grass? And so the word for medicines is also encompasses various plants that all grow, including grasses, medicines, and foods. And one of the conversations that I had with another knowledge holder from Akwesasne is the reminder that corn is in the grass family. And so we've got potential of the different, you know, medicines, the foods, that there's more to this conversation than just hay. And some of that was also supported by a historical map pre-1850s. And this translation was done by Satyago Bucktooth, was that the Mohawk word that's used translates to go there and collect again. And so this gave the imagery of that the meadows were important, not just as a one-time use or a, you know, part of discussion, but that this was an area that was easily accessible by navigation by boat, that was used as transportation in that period of time, and that it was something that could harvest food and medicine on a regular basis. And so to help, our 2017 survey had helped to demonstrate that. And then in terms of some of the questions that have been raised by the community over decades of, you know, well, okay, well, we know this area is contaminated, so even if we had access to it, we wouldn't want to use it because those medicines would be contaminated or the plants and the food would be contaminated. So in bringing in the science to this, last year, we worked on developing a work plan to go out and collect target species, target parts of the plants, to then send for chemical analysis to determine if we could maybe create some safe harvest zones or what, and it was just a preliminary screening project. So it wasn't to say with definity that this is a safe area for harvest, but we knew that this was a contaminated sediment site. The remedial actions to clean it up took place in 2019 to 2021. And so assuming that there will be some cleaner or recovery of the area from the contaminants, where can we start to revitalize that cultural use of the Indian meadows and go back again and have the Mohawk people be able to access those areas again for the medicines and the plants. And the food and the medicines, this is, the pictures here are just demonstrating, you know, to the left is a picture of groundnut that was collected in abundance along the shoreline and discussed multiple times with different community members on, you know, some of the knowledge of that was something that was used for food in the past, as well as lilies and cattails and arrowhead, and that these are some of those examples of plants that might be ground up into flour as well. And my beautiful teaching number 4 is that aquatic fur-bearing mammals are medicine. And in the words of Mary Arquette, you know, in different conversations with food, is that food is the first medicine. And so this slide here is just to depict, you know, trying to integrate a little bit the creation story. And there were some presentations earlier that talked about the different, the significance of muskrat and beaver, or the beaver as a clan. But with the creation story, I'm just going to read from the excerpt that I got from the Traditional Teachings, the book. The otter, muskrat, and beaver all play an important role in the creation story. Beaver offers to hold up the earth to support the woman and tries, but finds that it's too heavy for him. Muskrat attempts to get dirt from below the water and dies in the process. After 3 attempts, it is Otter who is successful in bringing up dirt for the Sky Woman. In our Thanksgiving address, a special acknowledgement is given to Otter as the leader of the water animals. Now, I've heard that story told a couple different ways, but I like this version, well, when it was printed as well, and I could reference it, so I'm not mincing anybody's words, but you know, it does emphasize the cultural significance of the muskrat and beaver, as well as the otter. And so when I would be in those community meetings where for the Superfund site and members of Akwesasne were asking, when can we eat the muskrat and the beaver? And there was legitimate concern from that, and EPA or the responsible party couldn't respond because they didn't think that it was an aquatic animal species, you know, for any kind of bioaccumulation significance. The St. Regis Mock Tribe Environment Division, we developed our own study. So we developed our own study to go out and sample the muskrat and beaver for contaminant analysis. So that way we could responsibly respond to the community of, yes, muskrat and beaver are safe to eat, in part because they eat the roots of plants, and that those roots of plants are also considered medicine. But there was that fear still and that concern that if the muskrat and beaver are eating contaminated plants, and they themselves are also contaminated, and that is also a concern. So we're just trying to pull all the different pieces of science together, not just in terms of the traditional knowledge, but in the scientific study, to be able to say with certainty that, yes, you can eat the muskrat. Yes, you can eat the beaver. And this was identified in the tribe's updated game consumption advisor, I think in 2014. And the photos here, I hope you don't think are too graphic, but it is depictive of what is considered a traditional meal in Akwesasne. And I've heard a number of accounts of people saying, you know, we used to eat the muskrat. My family would bring home muskrat and the beaver. And I'm going to start quickly going through slides because I realize I'm running out of time. And I'm sure some people might have some questions to ask me. But this is just, again, not just the muskrat and beaver, but skunk. Skunk oil is a significant medicine. And beautiful teaching number 5, freshwater mussels are the liver of the river. And if anybody is familiar with the work that the St. Regis Mock Tribe's been doing with freshwater mussels over the years, we have invested a lot of energy in expressing concern that the remedial actions in the Grass River, Niganjage, would either bury or remove these mussels from the system, and that mussels have a very important role and responsibility to the natural environment. And I think that was best stated by Chief Beverly Cook in a joint state and tribe press release on freshwater mussels just last year in 2021, of stating, as human beings, we are dependent on creation for our survival. As sophisticated as we think we are, the smallest creature can accomplish feats such as providing clean water simply by following their original instructions. We are always grateful for them and those that take action in acknowledging their important purpose. And for those who aren't familiar, freshwater mussels, they filter and clean the water, and they're native. They're considered uninotids. They're not the invasive mussel species that some people might be more familiar with from the St. Lawrence River due to the boats. This is not Jack of mine, but they're not zebra mussels, they're not quagga mussels, they're not dreissenids, they are native uninotids, and they are surviving and well in the tributaries to the St. Lawrence, but they have been greatly affected, the native mussels have been greatly affected by dreissenids in the St. Lawrence River. So we spent a lot of time emphasizing the importance of the freshwater mussels in the Grass River from some of these actions. And in 2001, the press release had estimated that, you know, through the efforts primarily by New York State Department of Environmental Conservation, but with support from St. Regis Mock Tribe, that estimated 500,000 mussels were saved by salvaging and relocating them, and those 500,000 mussels represent up to 18 different mussel species. But what's not stated in that is that from different population surveys and estimates, that prior to remedial action, it was estimated that there were 1.7 million mussels in the system prior to remedy. So from just a simple subtraction, you could assume that even though 500,000 mussels were saved, there were still over 1 million mussels that were impacted despite those salvage successes. So with that, you'll often hear work that SRMT has been doing with mussel propagation and biosubstrate placement. We're trying to restore the habitat in that stretch of the river of Niganjage that's been impacted by remedy. And this slide briefly, I just wanted to show native mussels are in the picture to the left. And when you find that when they're freshly opened, and muskrats will eat mussels in the spring before there's any roots or vegetation growing. And so you'll find these muskrat middens, and they like to use their little the little claws, and they pop them open and they'll eat them and consume them. And when they're fresh, when the mussels are freshly killed, you can see the very bright purple, pink, shiny nacre inside of them. And so when people think of mussels with the purple and related to wampum, the point of this slide briefly was just to let you know that in conversations with a Mohawk woman from Akwesasne who used to study mussels, actually I think she still does study mussels, was just to acknowledge that the purple that is often referred to as wampum from the quahog shell from the ocean, that the reference to the peacemaker story in Hiawatha of when the condolence of looking at when the beads were taken, when the mussel shells, I'm sorry, I'm mincing words right now, when the mussel shells, they were clam shells from the bottom of a lake. And so I just want to reference the lake, and that with lakes, you have freshwater mussels, not the quahog mussels. And over time with trade and other, obviously the more prized and powerful wampum was from the quahog shell. But there is some reference that freshwater mussels likely played a part in the Haudenosaunee territory because they are the freshwater mussels of Lake Ontario in the St. Lawrence River watershed. So I'm going to probably skip over this part because I just want to move on because I know I'm running out of time. But when we're talking about the biosubstrate and the mussels, it is just important to understand the different scientific components of how they filter feed and siphon water, and that when we go out and we've sampled and surveyed mussels, we have found the photo to the left is the species Petamelus elatus that I believe was estimated to be over 20 years of age. And so you're looking at these mussels, and then the photo on the right shows 5 different mussel species in one search effort in the field. And so it's showing that we know that there's a great abundance and diversity of mussel species. In one of the previous slides, I said there's at least 18 different mussel species that have been identified in the Lower Grass River that is part of the same 1796 treaty rights area. And that if we know that they're at least 20 years of age or more, to restore our population that's been impacted so greatly is going to take time. And then my last teaching was beautiful teachings number 6, ice jamming is not a new phenomenon. And I say that because this is an image of the ice jam that occurred this year in 2022 on the Lower Grass River. But if you have taken any time to review Franklin B. Huff, The History of St. Lawrence County from 1853 documentation, or there's The History of Messina by Dumas and Dumas in 1977, and that references spring freshets taking out the old dam in the early 1800s multiple times and bridges, and that prior to the hydro dam, the Moses Saunders hydro dam downstream in the St. Lawrence, that there were regular backwater flooding events in the village of Messina from ice jamming in the St. Lawrence. And so while we've spent a lot of time in terms of ice management decisions for the Grass River, it's not a new phenomenon. The Grass River is a north-flowing river. As I mentioned early on in the presentation, the headwaters come from the Adirondacks, and so the Adirondacks are south and everything flows north. When you have north-flowing rivers, ice jamming, especially in the Northeast, ice jamming is just common. And so, you know, there's been many efforts to design engineering controls for ice, and part of the Grass River Superfund site remedy over the sediment designed an armored stone cap. And while that appeared to be effective, you know, once you get past the armoring, you know, you're still going to have native sediment or sand and other materials that eventually may be subject to scour under ice jams as well. And so I just included this picture real quick that design does not necessarily mean it's going to function as you expect, the user experience. Water will find its way and its path with erosional forces. And one of the last images here in my presentation is just showing a sheet of ice on the Lower Grass River or Niganjage or along the Indian Meadows. The Indian Meadows are to the left and the right in this image of just, we oftentimes think of when there's an ice cover, there's nothing going on underneath, but there was one presentation yesterday that talked about the significance of ice and the different complexities of what needs to occur. And one of the conversations that we've had in the past with Under the Ice of, you know, the significance of turtles that are overwintering, mussels that are overwintering and burrowing, and fish are still moving, and people will ice fish through this. And it doesn't mean just because there's ice, there's not a very lively and productive ecosystem that is occurring underneath. And so with that, I'll just leave with this last image. I did have some things that I was going to say about this image, but basically moving forward, this is just an image looking upstream on the Grass River, and how moving forward in my project management and collaborations, I've taken on the approach of making sure that whenever we address a specific environmental topic, that we're including not just the scientists, but the archaeologists, the historians, and the traditional knowledge holders from Akwesasne to make sure that we're integrating the different components into the work that we're doing. So thank you very much. And I will, I think I need to stop sharing my screen. Is that correct, Georgia? Okay, let me stop sharing my screen here and open it up for questions.
Thank you so much, Jessica. It's just great to hear about all of your experience. 20 years is a vast, long time to work at the same job, and it's amazing all of the different teachings that you've learned over the years. And I
was just gonna say, I'm drinking from my one of my favorite work coffee mugs. It says, "The only way to do great work is to love what you do." Steve Jobs quoted that, and whenever I feel like I really want to like get into the emotion of the day, I try to drink out of that coffee cup.
You can tell you love what you do just from that talk. It's yeah, it's amazing.
I've been very fortunate.
Yeah. So I'm gonna just go to we are a little over time, so it might be a bit of a shorter question period. I'll just go and see if there's anything in the chat. There's a lot of really great comments. No questions so far, but there's Jessica Dolan was saying some great things. She loves how you organized this into beautiful teachings, which is, yeah, amazing how you did that. Yeah, and then I might have a question for you if we don't have anything yet. So for me, I had a question. You said how to, like, you have to communicate this to engineers and to the different types of people that you work with, and they kind of work in, you know, just kind of their own like Western science way, and you're trying to communicate this other, you know, vast knowledge, like the history and the biocultural part. Like, has that gotten easier over the years to communicate that? Like, do you find that process and then I also, I guess there's two parts to my question. So has that gotten easier over the years? And then also I noticed that you like, it seems like, yes, you know, we know there's fish in this river, but it seemed like you had to kind of go in and do the Western science, like do the sampling to actually prove, you know, that there are fish in the river. Is that still the case? Like, you're, you know, like, you might have been saying it all along. Do you still have to go and do that Western science to kind of prove that would you say, if that makes sense?
Okay, so remind me of your second part question in the event that I forget. So I'm going to address the first one first, is that has it gotten easier? I don't think it's gotten easier. I think policies changed, right? So the part that's gotten easier is that we can now look at different policy that's come out from the federal agencies, whether it's Fish and Wildlife Service. They were one of the first US federal agencies to talk about TEK, but there's now policy out there that from the White House, from different federal agencies that mention traditional ecological knowledge on Indigenous matters. In 2017, there was a memo that came out of headquarters for EPA. I'm going to forget the office name, but it's the office that manages the Superfund sites, that not only said, you know, you need to include tribal treaty rights if there's treaty rights into these sites, but the TEK component. And so I feel silly saying this, but it's like, as soon as these things get published, I feel like I'm like, look, like, you have to abide by your own policies. And I think anybody that's worked in Akwesasne, that's worked with the federal agencies, has probably experienced that on a number of occasions. And that's unfortunately even, I think, the case with the treaty. It's like we kept going back and saying, look, there's a treaty. But one of the successes this year also, you know, again, referencing we're in a different time, in 2022, is that there was a recent court win for the Mohawks of supporting that treaty and the boundaries of that treaty. And so I don't want to say it's easier, it's just all the work that my predecessors did as well, because we've been talking about these issues. I shouldn't say the Mohawks have been talking about these issues for 30 years plus in terms of environmental contamination. It's just, we're at a place, I think, now where policies changed on a federal level, and then the acceptance of the knowledge. And, you know, when I opened my talk, I wanted to acknowledge the River Institute for putting this Ways of Knowing conference together, because, you know, it really just demonstrates how far we've come, you know, in talking about science and integrating all those complex conversations for better environmental decision making or management decisions. So that was the first one. And then the second one with the fish, yeah, that's just been like my frustration, where we had to put the pieces together, and some of the work we didn't initiate ourselves, but as a support agency, or as having a seat at the table on that government to government basis for these federal processes, that we were requesting the studies. And so the studies were shaped based on our requests. Whereas you would have whoever the applicant was, or the responsible party, or, you know, whoever was paying for the studies, is saying, no, we know what's in the system, because we've got, you know, this anecdotal report from somebody who lives over here in New York State, and that's good enough. And so it was pulling a lot of pieces together. And then in terms of the flora survey on the Indian Meadows, with the that was something we had to do on our own because we were not getting traction on that at all. And so once we had that report ourselves in the study, then we could take the conversation to the next level of how do we restore, plants of cultural significance in this Superfund site that's managed by EPA. And so once we had that data and information, and then they had their policy change in 2017, it kind of just, worked well together. But I don't know if I answered your first question though about the fish. I kind of transitioned it into plants, but
no, that's you definitely answered. I'll just check the YouTube chat quickly. Oh, so there is one quick question. So, from Talking Wings, how can communities along, it's the Grass River, and I don't know how to pronounce it, in Mohawk, I'll have to work on that, work together from Akwesasne to the Adirondacks, uniting to protect the Grass River and their bioconnectivity?
So that's interesting. So this is a little bit off topic, but how I'm interpreting that is from the St. Lawrence to the Adirondacks. But if you look at traditional Mohawk territory or Haudenosaunee territory, I think they would say from the Algonquin Mountains in Canada to the Adirondacks in New York State, New York. And I just had a recent conversation with a retired fisheries biologist from DEC who works on rare fish. And he was talking about doing some of the work in the tributaries on the Canadian side. And I said, well, do you know what that looks like in terms of certain fish species and composition from the Algonquin watershed to the Adirondack watershed and all the tributaries in between? Because I was thinking of it from that same perspective of, if we're to look at real traditional territory and protecting fisheries, and I'm just going to mention fisheries, what is that landscape and what does that look like from a science perspective? And he responded he didn't think of that. and in terms of a solution to make something like that happen, that takes a lot of dialogue and collaborations, and I unfortunately don't have the answer. I presented a lot of information today on one very narrow focus of one, maybe 9 river miles of the Grass River. And there's some days when I'm like, thank God I don't have more river miles to deal with because it's so complex. It's really hard to, effectively, I think, manage those broader systems. Yeah. And I defer to other people like my boss or those who have more authority than me to figure out those kind of solutions.
Yeah, it's so complex, and I find communication is just key in those types of things. It's so hard. So I think that's I might have to just stop it now just because we are out of time and we have to go for a lunch break. But once again, thank you so much for your talk, and thank you for coming to present today. It was really great to have you and hear you speak.
Thank you, Georgia. Thank you so much. Have a great day.
You too. Bye.
Hello, everybody. I believe we are back from our break. So welcome back to the River Symposium, our 29th River Symposium. Yet we're just in the middle of the event. We started yesterday in person in Cornwall, Ontario, and now we're on our second day, all virtual. So you are likely watching on YouTube. If you have any questions for our speakers, you can put it in the comment box. So next, I'd like to introduce Dr. Kathleen Vaughan, our second plenary speaker for the day. She is an artist, researcher who integrates visual art and storytelling in studio and community-based projects on social and environmental themes related to the dynamic ecosystems of rivers, forests, and skies. Kathleen leads the interdisciplinary four-year arts science research project, Learning with the St. Lawrence, which explores the river as environmental entity and imaginary via artists' work and community outreach. Initially trained as an artist in painting, drawing, and photography, she is increasingly promoting sustainable art making and earth-friendly material choices. Her own practice now emphasizes textiles both to explore diverse cultural and industrial histories and to create that can eventually rot, subside into the earth with limited environmental footprint. A lifelong knitter, Kathleen is also exploring wool as a sustainable, beautiful material that can improve our lives and our world. She holds the Concordia University Research Chair in Art and Education for Sustainable and Just Futures, is a professor of art education, and feels happiest with her hands in materials. Walking wildish pathways with her standard poodle and collaborating with others for the love of our beautiful planet. I had the opportunity to sit with Kathleen by the river just in the month of September. We had a wonderful conversation, and I'm looking forward to everyone hearing more about Kathleen's projects and her work. So welcome, Kathleen. Thank you for taking the time to present today. And without further ado, it's all yours.
Thank you so much, Stephanie. I am so very delighted to be joining you here today and honored to be with you as a speaker for this symposium on modes of knowing. So let me just share my screen and I'll get going with some visuals as I speak. Being a visual artist, the visuals are important to me, of course. So as Stephanie mentioned, I'm an artist and professor of art education at Concordia University, where I hold the Concordia University Research Chair in Art and Education for Sustainable and Just Futures. I create studio-based artwork and facilitate art in community settings, since I am profoundly interested in people's stories and the way they wish to tell them through language and images. My work has, for the past 20 years, been place-based. That is, I use place as a lens through which to see the world and engage a wide range of issues: environmental, cultural, historical, social justice-oriented, natural history-oriented, and more. For about 6 of those years, a focus of mine has been the St. Lawrence River, emphasizing the realities of the river around Montreal, but also orienting to its full 1,200-kilometer flow from Lake Ontario to Dublin. I'm interested in humans' relationships with the river, how they have changed over the years and are still changing. But I am also compelled by the St. Lawrence as a dynamic, extraordinary ecosystem, a living entity that we have the capacity and the responsibility to care for, to love, in fact. I'll say more about love in a moment. After all, the title of my talk is, as you can see on screen, I hope, Becoming an Amateur, Love as a Route to Knowledge as we learn with the St. Lawrence. I'll outline the background to my ideas, share some images of my own and others' work, and close by considering what artists might offer at this time of climate catastrophe, plastic pollution, ocean acidification, and accelerating species extinctions, and of course, the ecological grief that comes with these realities. But first, a little personal background. I was born and grew up in a community in the center of Montreal, and as a young person had little or no orientation to the river, which was a spectacle in the distance. As an adult, I lived for 20 years in Toronto, but have been back in Montreal teaching at Concordia for 14. I'm of third-generation settler heritage, with my ancestors coming here in 1870, so a little more than 150 years ago, and not long after the geopolitical event we know as the Confederation of Canada. They were farmers and working poor from Ireland, Scotland, and England, leaving their homelands to avoid colonial conflict, famine, and land seizures, many of the same reasons that people worldwide now seek to move to North America. My family members would have traveled for multiple weeks by boat across the Atlantic and up the St. Lawrence before disembarking in Montreal. Of course, they were, as I am, uninvited guests on First Nations territories. In the spirit of the land acknowledgements that preface and ground place-based work such as mine, I would like to affirm that, like so many of us, I am increasingly attentive to my relationship with the land, skies, and waters around us, including Ganya Darwanane, the Mohawk or Ganyangaha name for the big waterway, also known as the St. Lawrence. I am mindful that here on Montreal's unceded territories, we acknowledge the Ganyangaha Nation as the custodians of these lands and waters. Not long after my great-grandfather, Robert Crawford Vaughan, arrived in Montreal from Western Ireland, Scottish emigre Alexander Henderson took this picture of Montreal, seen from the south side of the St. Lawrence River. As a white man with family money, Henderson had the privilege and the means to take up photography after moving to Canada. He loved our seasons and the great outdoors, and is known for his landscape photography of places throughout Quebec, Ontario, and Western Canada. Currently, there's an exhibition of his work on at Montreal's McCord Museum called Alexander Henderson, Art and Nature. The show features more than 250 period prints and reproductions of photographs, in addition to documents and albums from the photographer's personal archives. The exhibition aims to consider the colonialism embedded in Henderson's photos, as well as what the curators describe as the image's romanticism. Let's unpack that notion of romanticism as a way to begin our discussion of love. You'll probably know that originally, back in the 18th century, Romanticism in art and writing emerged in Europe and eventually came to North America as a reaction both to the Enlightenment's overemphasis on cognition and rationality, and the horrors of the French Revolution, Reign of Terror, and other devastating wars. Artists and thinkers increasingly felt the need for alternative modes of knowing, ones that acknowledge more ways of being in the world, that recognize the importance of beauty as well as respect, even love, for nature. Some writers and artists were interested in romantic love between people, but most were oriented to a connection to the natural world. Like these artists and others since, I maintain that such love can in fact be a method of generating knowledge, that romanticism can help us. Three extraordinary women of the 20th and 21st centuries support my thinking in this direction. All are teachers and writers who explore connections between love and knowledge. Scottish poet Nan Shepherd is the author of The Living Mountain, about the Cairngorm Mountains near her home. Written during the Second World War and published 3 decades later, Shepherd's book integrates personal stories, natural history, field notes, oral history, and musings about the essential nature of the mountains she loved. Most important to me, in this text, she wrote, as you can see on screen, that love pursued with fervor is one of the roads to knowledge. Her own love for the Cairngorms prompted years of devotion, research, and writing. But what exactly do we mean by love? Here's a suggestion from my second muse, American cultural theorist Bell Hooks. You'll probably be familiar with her extensive work supporting racial and social justice. In her thoughtful book from the year 2000, All About Love, she proposes that we see love as the will to nurture one's own or another's spiritual growth, revealed through acts of care, respect, knowing, and assuming responsibility. She writes of love in families, in romantic relationships, in community connections, and in spiritual engagement. To her, the foundation of all love in our life is the same. Seen in this light, Nan Shepherd's love for the Cairngorms, and perhaps our own love for the St. Lawrence River, can be seen as a starting point for engagement, for doing research, building relationships, and deepening connections. Love, then, can be seen as a precondition for knowledge. Elsewhere in the same book, Bell Hooks remarks, embracing a love ethic means that we utilize all the dimensions of love: care, commitment, trust, responsibility, respect, and knowledge in our everyday lives. We can successfully do this only by cultivating awareness. Being aware enables us to critically examine our actions, to see what is needed so that we can give care, be responsible, show respect, and indicate a willingness to learn. Understanding knowledge as an essential element of love is vital. In other words, knowledge can be a precondition for love, just as love is a precondition for knowledge. They're entwined, a kind of Mobius. My third muse is the remarkable botanist and Potawatomi writer, Robin Wall Kimmerer, who you will know as the author of Braiding Sweetgrass. In this book, she describes how the imaginations of her environmentally minded creative writing students were defeated by her question to them. She asked, "You know you love the earth, but how do you know that the earth loves you back?" They had a hard time recognizing or perhaps admitting to the feeling that the earth loved them back. Robin Wall Kimmerer writes, "Knowing that you love the earth changes you, activates you to defend and protect and celebrate. But when you feel that the earth loves you in return, that feeling transforms the relationship from a one-way street into a sacred bond." Drawing on the ideas of all three of my muses, I'd suggest that love and knowledge are linked components of a sacred and reciprocal bond that connects us to the earth, air, and waters, and inspires us to do the work that we do. My own work is, as I mentioned, as a visual artist, researcher, and community arts facilitator. While I was trained in visual art, English literature, and education, I have very little science knowledge and work to educate myself as I go. I'll show you three projects of mine about the St. Lawrence River. They all require that I bump up against my limits of knowledge, try to compensate for those limits, and keep moving forward, fueled by love. First up is Gardens of Water, an ongoing series of photos I take along the river shoreline from Lake Ontario to the Gaspésie. As you can see from the selection of images here, each photo features a mason jar of water that I scoop up from the near shore and photograph against the landscape from which I borrow it. The image includes GPS coordinates to be very specific about the location of the sampling. I have 22 images so far, taken on various trips through multiple seasons and kinds of terrain. I love the work, specifically that time when my phone's camera and the mason jar working close to the water line, considering the light and the air movement, the transparency of the glass, the colors and reflections in the water, and aiming to create a photographic image that somehow represents an aspect of that place at that time, while still foregrounding the jar of water. I continue to develop this series, now implementing a kind of catch and release approach. I scoop the water into the mason jar for the duration of the photograph and immediately afterwards return it to the river. But in 2017, as I first worked this series, I had a different plan. I wanted to know what was in the river. Was it contaminated or clean? A good environment for the creatures living within it, and for those of us drawing on the river as drinking water? So I kept labeled samples in a cooler in my car and then in my refrigerator, wondering about the colors and components of the water along its flow from sweet to salt. I soon realized, after talking to water sampling labs, what so many of you will already know. The work of testing can be complicated and expensive. Even if I were to get a scientific analysis of some components of the water, I wouldn't have the knowledge to understand what it meant. And as one collection in one spot at one random moment, my sample would not be meaningful, even if it might be mildly interesting. As a non-scientist, I felt disciplinarily limited. I was definitely an environmental amateur. I realized, however, that while my photos and their accompanying samples might not in themselves generate new knowledge about the quality of water in the St. Lawrence, they were good for generating conversation with people. Here I am, pre-pandemic, at a Toronto Arts Festival called Big on Bloor, whose theme that year was water. The kids loved the small yet visible creatures that swam in the jars. Most adults were surprised to make the connection that somewhere beneath our feet at Bloor and Dufferin Streets was the undergrounded waterway, Garrison Creek, which flowed into Lake Ontario and from there down the St. Lawrence to all the sites I'd photographed. This continuity, this connection, was a new thought for some, and I'd like to think that perhaps it was also the beginning of a new sense of responsibility for our waters more generally. As the Swiss-born artist Paul Klee suggested, art does not reproduce the visible, rather it makes visible. Of course, Klee was suggesting that art can make apparent in a conceptual way, not just visible in a purely perceptual way. But artists' tools are indeed the senses, especially sight, hearing, and touch. It's not often that people are invited to touch visual art, which is usually thought of as too precious to be handled. But touch is indeed one of the many senses I wanted to activate in Walk in the Water, an artwork about the many times changed shoreline of Point St. Charles. Point St. Charles, or the Point, is the post-industrial neighborhood of Montreal where I live. Historically a community of economic need, the Point is now gentrifying. Our small triangular community is delimited by the Lachine Canal on one side and technically by the St. Lawrence River around other perimeters. In actuality, though, residents have no direct access to water, nor is it even visible to us. We're separated from the St. Lawrence by fences, the fast-moving traffic of multi-lane highways, train tracks, and maintenance yards. Many locals advocate for river access and call out the past 200 years of shoreline infilling with contaminated soil. Every time Montreal went through a major urban development that required a big dig, be it the enlargement of the Lachine Canal, the building of the Victoria Bridge, the creation of the subway and the Vicari Expressway, or covering over of one of the city's old garbage dumps, the contaminated soil was unloaded along the river's shoreline. Not only does the contaminated soil make the ground unfit for human habitation, it also contains dangerous chemicals such as PCBs that through groundwater runoff seep into the river, something the city is now working hard to remediate. We have not treated our shoreline with love, and I do sometimes wonder whether we deserve the love of these territories. In any case, my own work was prompted by finding this map of 6 shoreline changes over a period of 200 years. It made very clear to me how much our earlier generations had changed the edge of the St. Lawrence and its ecosystems. I wanted to bring the river back to my neighborhood, give people an opportunity to experience in my artwork how the shoreline might have been, and to hear stories about the St. Lawrence from a variety of locals and experts. I felt that if, as an artist with little scientific knowledge, I had a limited story to tell, then the best thing I could do would be to include the stories of other, more river knowledgeable people in my work. This is the finished piece, Walk in the Water, installed at Montreal's McClure Gallery in 2020. To see how the work can be interactive and call on visitors to touch it, I'm going to show you a short 6-minute film of the work in action. Great. We're here in the McClure Gallery, where I have a show of 11 of my artworks called You Are Here, Vous êtes ici. One of the ways that I create art is through textile maps, and I'm here today to tell you in particular about one of the pieces in the show, to spend a little time unpacking some of the meanings, ideas, and hopes that are embedded in this work. This is Walk in the Water, Marcher sur les eaux, which is a 9-foot by 12-foot textile map that explores the histories of the shoreline of the St. Lawrence River at Point St. Charles. This is one part of 2 components that create this project. There is the map, the interactive talking map that I'll demonstrate in a moment, and there's also an hour-long audio walk that I will tell you about that's all part of this same exploration of place, of meaning, of histories, of justice issues, and of the future. A lot of the work that I create is what I think of as place-based, which means that I'm very interested in all different aspects of locales, the natural world, the human histories, the ways that justice is enacted or isn't, the built environment, the artworks that have been created there over time, the different kinds of creatures that have lived there over time and may not live there now, but might have been present once. The way that change, it leaves its traces on our environment, whether through stories of industrialization, deindustrialization, post-industrialization, gentrification, or through the wonderful bearing of witness that a beloved 200-year-old tree can offer as it has grown to venerable maturity in a particular location. So each of the 5 triggers plays back a different sound or interview. 4 are with people who have strong connections to the river and to the St. Lawrence in general, and 1 is the voice of the river itself, recorded with a hydrophone. Let me show you how this works. So this is conductive thread, meaning that it's thread that will conduct an electrical current. And when I use this little bit of conductive thread to close the circuit, that's the voice of the St. Lawrence River. So this particular map works with Google Maps as the visual form to show what exists now in this neighborhood. So I wanted this to be identified and identifiable, and the way that I did that was through digital embroidery. Digital embroidery allowed me to add names to different locations and to run a flow of script around the edge. So part of my goal with this particular piece was to bring the river back to the neighborhood and create a visual suggestion of what it might have been like back in the day I wanted to acknowledge that here in the gallery, the McClure Gallery, part of the Visual Arts Centre in Montreal, in general, we are on unceded Indigenous lands. So the Ganyan-Gahaka Nation is recognized as the custodians of these territories, and we acknowledge their history and guardianship of these lands.
Alors, je suis Natacha Alexandrov. J'habite Pointe-Saint-Charles depuis une trentaine d'années et je fais partie de la Société d'Histoire depuis le début.
Philippe Gachon, I'm a professor here of hydroclimatology here in
Et moi, je viens du bord de la mer.
My name is Jean Desjardins. I'm the owner of Fishing Old Montreal. I've been running this business for 6 years now.
My labor of love, trying to come to understand some of the many complexities of the We're going out on the St. Lawrence for more information about the degree of pollution at the Point St. Charles shoreline. I came across a video interview by environmentalist Danielle Delhaes that was published in the Montreal Gazette on June 9, 2016, just as the federal government
Qu'on n'entend pas trop parler, mais qui existe entre nous et la ville et l'arrondissement.
Like 5 minutes away from the downtown over here, and I'm catching average 10, 16 fish.
My real thanks to Marco Flores for behind this work. Of course, when I was creating Walk in the Water, I was still very conscious of the limitations of my environmental knowledge, my desire to know, and my longing to have my visual work contribute to a greater interdisciplinary understanding of the St. Lawrence River. That's the impetus behind the final initiative I'll share with you today, called Learning the St. Lawrence. This is a project that I developed after the joy of spending 10 days in 2018 as an embedded artist aboard the Lamsillis research vessels, while scientists set fish and water along the St. Lawrence. I will always be grateful to environmental scientists François Guinette, Gilbert Cabanin, and Lizzie Grader for welcoming me on this trip and so very kindly explaining their research to me in terms I could understand. Watching them work, I again felt the limits of my knowledge, that I was an amateur among experts. You'll likely know that the word amateur means someone who takes on an activity from pleasure, from love. The word derives from the French and Latin amateur, or lover. These days, the amateur is sometimes dismissively contrasted with the professional who holds expert knowledge. Of course, the amateur can contribute other knowledges than does the expert, so that they complement and magnify each other. As an amateur aboard the Lamsillis, I had the pleasure and privilege of extended time on the river through the long sampling days from 7 a.m. to 7 p.m. I could spend time observing, time aiming to become aware, to return its word, both of the riverscape around me and of the human activity that was taking place in service of St. Lawrence. I was and am so thankful to have had the experience of those long, open, panoramic vistas, taking in the kind of extended horizon that those of us living in the middle of cities almost never see. I was animated by the light over the water, the changeable weather, the segmented colors of the river, greenish in the deeper dredged areas of inflow from Lake Ontario, brownish where the boreal tees of the Outaouais and St. Maurice rivers joined the flow. These were fascinated to my eye and lifted my heart, connecting me at last directly to the St. Lawrence that through my youth had been only that distant vista. It was building from my experience aboard the Lamsillis that I brought together a team of artists, scientists, including my 3 shipmates, and a curator on a project called Learning the St. Lawrence, funded by the Social Sciences and Humanities Research Council of Canada and Concordia University. We just this week launched the first web version of the project website, learningwiththeSt.Lawrence.ca, which highlights our public outreach projects and the field guides we've commissioned from artists. I'm particularly proud of these latter, a series of creative interpretations of the river, geolocated by artists working in dance and archival research, drawing, text and video, bookworks and photography. I hope you'll enjoy these on our site when you have the chance. The website also includes documentation of our public outreach events. In the last year, my team of graduate students and I have conducted 2 art activities that are informed by the knowledge of the river we glean through our collaborations with our science team members, as well as our own research. These activities include October River, a series of outdoor Saturday midday art workshops in Point St. Charles that invited people to use media from land art on the left to drawing on the right. In our drawing workshop, for instance, participants learned some technical basics and were given prompts by the workshop leader, as well as a variety of source photos of the river, some taken by François Guimet using a drone. At the workshops, the data collected included photographs of the artworks people created, as well as their stories and comments about their engagement with the river and their hopes for the St. Lawrence's healthy future. Their own art making and artwork became the sparks for conversation and connection between us, in the same way as having gardens of water photos at Big on Bloor. Our outreach events attracted many individuals who love and are concerned with the river. And in addition to the event in Montreal, in July 2022, we also hosted a day of drop-in activities at the Old Port in Trois-Rivières. On the art side, participants drew, wrote poetry, and created cyanotypes or sunprints using sustainably foraged local plants as inspiration. They also took in science demos, as you can see here on the right, and visited the labs of the Lancillus. Our participants' work and words are all part of the gathering collective. Photographs, artwork, and audio recordings. Starting this winter, I'll be bringing these together in an artwork of my own, integrating statements, images, and ideas from all kinds of sources. Unlike the talking textile walk in the water, this work won't use digital technology. As I've continued to learn about and work on river issues, I have grown increasingly concerned about the environmental footprint of the artworks I create. More and more, I am orienting to sustainable and natural processes that reuse and upcycle materials into a work that can eventually, someday, decompose without leaving harmful residues in our earth or waters. We already have too much e-waste and plastic pollution everywhere on the planet, including in the St. Lawrence River. During a field trip along the river in Conn, our team found these plastic liquids, which scientists informed us are often mistaken for food by fish who can die from starvation. We live in complex and challenging times, just as many of us take pleasure and comfort from nature. All was also beset by ecological grief over all the losses our planet is experiencing now. But our grief is also a measure of our love for the river. And art, thank goodness, has the emotional range to encompass all the feels, as the saying goes. Philosopher Maxine Reid has suggested that art allows us to hold the chaos of the world at bay while not denying it. I'd like to think that art can help us to build our tolerance for living with paradox, for engaging with the double-sided coin of love and grief, and also building the knowledge that will enable us to make good choices for the St. Lawrence River. By becoming an amateur, that is, one who loves, who looks to multiple experts for input and ideas, but is guided first and foremost by love for the St. Lawrence River, we may perhaps come to know, really know, in our own internal waters that the St. Lawrence River loves us back. We may come to live that sacred bond that Robin Wall Kimmerer describes and learn with the St. Lawrence how to be in our beautiful world. Thank you. Thanks to all those who have contributed to my project along the way, named here.
Thank you so much, Kathleen. I can hear a clapping in the background, and that's how I could imagine it would be if we were all together in person. Thank you for that beautiful and very inspiring presentation that I think I'll listen to again so I can really digest everything that you've shared with us. I'll open up the floor to questions for anybody watching. And I guess for me, while I wait to see questions coming in, I wrote down a few of my own. So I was wondering for the field guide of learning with the St. Lawrence River, is it for the whole river or is it specifically for the Montreal region?
It's for the whole river, but it's at the artist's discretion. So the artists themselves chose the locations they wanted to identify. One of them works specifically along the Verdun shore. One has chosen 4 different spots, none of which are at Montreal, one near Gananoque at Wolfe Island and the other Matane and sort of down towards the Gaspésie. And the third so far is sort of a Trois-Rivières-ish between Montreal and Quebec. So I wanted to leave that to the artist's discretion and see where that person was moved to work or be working with reference to. I'm hoping we'll have some more field guides as we go, that this is the first sample with more to come.
Excellent, thank you. I'm hoping that we do have artists watching and that work on the St. Lawrence to get acquainted with this project. So I'm just checking the questions here. Well, I got a comment from Jordan. She leads the environmental tech program at St. Lawrence College. And she says, thank you, Kathleen, for sharing your work, vision, and passion through this presentation. Thank you, Jordan, for your comments. I have a thank you from Paul Gilbert. He's asking, he's saying, thank you, Kathleen. Is learning with the St. Lawrence an ongoing project?
You froze on me for a moment there.
Oh, am I back?
You're back. I understand my internet connection is unstable from what my computer is telling me.
Okay, I'll say that one again.
Thank you.
So Paul Gilbert is saying, thank you, Kathleen. Learning with the St. Lawrence, is it an ongoing project?
Yes, I mean, it's an ongoing project for as long as I'm around. I have a certain quotient of funding from the SSHRC, the Social Sciences and Humanities Research Council, that ends this March, but I have additional funding that comes from my research chair and will be applying for ongoing grants to continue the work. I believe in it very strongly.
Excellent. Thank you for that question, Paul. So I'm just going to go to my notes because I did write down some comments and a few questions. And actually, I was curious personally for you, what was the spark that made you fall in love with the river? Where did that begin?
Yeah, I mean, in a certain kind of a way. There's a kind of a weird backhanded spark that came from when I was a child and grew up in places I didn't see the river at all. We would occasionally, go to something like La Ronde as a family, and we'd see the river from the Ferris wheel or whatever. But I do remember sitting around the breakfast table with my family, my father, my mother, my brother, and me. And for some reason, the discussion of the St. Lawrence and where everything goes when you flush the toilet came up. You know how it is at breakfast. And so I remember asking my father, I would have been probably about 9 or 10 at the time, well, where does it all go? And he goes, well, it goes in the river, of course. And I was like, what? Like, that was just so outrageous to me. Like, couldn't we as a human species think of a better thing to do than to put our waste in the river? That just struck me as so wrong. And I suppose I could have been a sanitary engineer instead and tackled that directly, but I was not gifted in that academic direction. But I guess in some ways, just thinking about the too many things that humans have done to our beautiful planet that do not show the respect and love that we would want to receive from another and that we would want to give to a beloved. I think that moment really in some way went right into my heart and motivated me onwards. And so, it took me a while, I'm no longer a 10-year-old, to get to the point where I was in a position to really think conceptually and artistically and with funding that allows me to hire people and fund people about these questions, but now I can. And so this is my kind of kept promise to that 10-year-old's outrage of, how could we do better?
It almost sounds to me as if it was actually that knowledge that sparked the love for the river.
Maybe that's a great way of thinking of it. Yeah. I mean, and also that my father was so like, yeah, well, duh. And it's like, what? I mean, it just was so normalized at that time that it just, anyway, yeah.
It's amazing. Yeah, I mean, it's amazing that you're thinking of that at 10 years old. I think there's something to be said about it.
Yeah, I suppose so.
I have a question from Francine. She says the pieces are so powerful. Does the textile piece travel? Could it be installed and activated again?
Yes, absolutely. It takes a day to put it up. It's a large piece and it takes a couple.
Oh, I think the internet cut there. I'll give Kathleen a minute. Hopefully she'll come back quickly. I was excited to hear this answer too. I'm gonna send her. Sorry, everybody. Here's our technical glitch for the day. Let's see. I'm gonna send a text to Kathleen, see if. We do have a few more minutes. Kathleen, we'll be right back on in a second.
I somehow got disconnected. There must have been a glitch in something somewhere. It told me I had, yeah.
It's okay. I think we're off live right now. Oh, I think we're back. We're back on air. Okay. So would you like me to repeat the question for you, or?
I guess it's the question about whether the walk in the water piece will travel. Yes, it can certainly travel. It takes some arrangements to do, but it's totally possible. It does need an electric outlet. It runs, or I suppose I could run it off a 12-volt battery and some setup time. But yes, it's designed to be portable and adjustable data-wise to the content stream of the location it's shown. So it has 5 places of activation triggers, and those 5 can all change depending on what needs to happen.
Excellent. Thank you, Francine, for your question. Philip is asking, how do you feel the river loves you back?
I guess one of the ways that I think about this a lot, one of the ways that I think the river and the earth generally loves us back is by being beautiful. You know, this is one of Robin Wall Kimmerer's other questions is, why is the earth so beautiful? And I think the answer is because that's a way it can show us how it loves us.
Thank you. Thank you for that answer. And thank you, Phil, for your question. I'm going to leave that at that. Our schedule says we're on our 10-minute break now. Thank you so much for presenting. It was so great to hear you speak, and I look forward to seeing you again.
Me too, Stephanie. Thank you so much. My privilege, and thanks, everybody.
All right, everybody. We'll be back at 2 p.m. for the session Responding to Change. See you then.
And welcome back to our third session of the day. So we're going into the session called Responding to Change, and I'm going to introduce Mackenzie, who actually works with me at the River Institute, and she will be leading this session. So over to you, Mackenzie.
Thank you. Yeah, so welcome back, everyone. My name is Mackenzie. I work on the River Reform project at the River Institute, like Georgia said. So just like all the other sessions, we will be going through, we'll actually be doing 3 presentations for this one. We'll have a question and answer period after the last one. So if you have any questions, put the name of the speaker you'd like to ask into the YouTube live chat, and we'll get to that at the end of the session. So to start off, I will actually be presenting with my other coworker, Cristina Charette, who is on the education team at the River Institute, and she's also a PhD student at Université de Québec. So we will be presenting on spatial and temporal trends of the Round Gobi invasion in the Upper St. Lawrence River. Perfect. So I'll start on the second slide here. All right, so like I said, we both work on the Great River Report project, and this project involves 3 different components. So we have an Indigenous, community, and scientific component, and our report today that we'll be presenting on is a part of the scientific component. So within this project, we have identified 35 ecosystem health indicators that have been identified with the help of community members, our Indigenous partners, and people at the River Institute. And these all represent concerns along the Upper St. Lawrence River for the health of the waters. And for each of these technical reports, we write, or for each of the indicators, we write technical reports, and we'll be presenting the one on the Round Gobi today because it is a dominant invader in the system. So some of you may or may not have heard of this small benthic fish before. If you live along the river or do a lot of boating, you've probably seen these little guys, but they're not supposed to be here. They're actually native to the Ponto-Caspian region in Eurasia, and they were brought here through human activities, most likely shipping ballast water. So whenever cargo ships are bringing goods over from other areas around the world, they release, or they did release water in earlier decades, and this sometimes released species from other areas. Yeah, so because this little fish does have evolutionary history in brackish water, it has tolerance to environmental heterogeneity. So it can survive in a lot of different habitat conditions, including varying salinities. So this has allowed for very good invasion success in our region. Yeah, so it's been here since 2000, and it is now probably the most abundant fish in the waters here. So like I said, it has been very successful, and this is because of its very broad environmental preferences. And with this comes a lot of impacts because their populations have exploded over time. So particularly competition with native species for resources and habitat has put pressure on our native benthic fish species because they are living in the same habitats, and the Round Gobi is a competitive predator. It has also resulted in the reintroduction of contaminants into the food web, and this is because of an interaction between two other invasive species, the dry-snid mussels that actually come from the same region and have established in the waters. And because these mussels are filter feeders, they take up contaminants from the sediment, and as the Round Gobis feed on these mussels, they then take up these contaminants. And then as our predatory bird and fish species in the St. Lawrence have started to shift their diet to the Round Gobis, they then bioaccumulate these contaminants as well, which brings concerns for their body condition as well as for human health as we consume these fish. So yeah, the Round Gobi has brought in a lot of novel interactions within the St. Lawrence, and this diagram shows just a few of them. So we have the direct predation on both native and non-native invertebrate species, direct competition with native benthic fish species, such as the log perch demonstrated there. There's also the tessellated darter that has been highly impacted in Lake St. Francis. And then we have predatory species such as smallmouth bass, as well as other sport fish, and the double-crested cormorant there. Here we just have a diagram to show an example of a shift of the diet for the double-crested cormorant. And as you can see from left to right, it's showing before and during and then after the invasion of the round goby. And the white demonstrates yellow perch, the grays demonstrate other native fish, and then the red demonstrates the round goby. And this is the dietary composition of 3 different cormorant colonies. So over time, you can see a large proportion of the diet does transition to round goby. So they have kind of taken away predation pressure on native fish in this way, in this example. So with all this background information, a lot of it has been based in the Great Lakes or other freshwater systems alike to ours. But we do have data gaps in the Upper St. Lawrence River, and that's kind of why the Great River Report has come together. We want to know more as to what's happening. So our aim of the report was to determine the trends in round goby invasion through space and time, and review the impacts that we just went over in regards to the Upper St. Lawrence River specifically. And we were able to do so by doing a systematic literary search, as we do with all of our other technical reports, in order to identify databases and relevant primary literature and describe these trends, both historical and current trends for the round goby invasion. And through our search, we identified 3 databases. We have the Ministère des Forêts, de la Faune et des Parcs, the Thousand Islands National Park, and the Fish Identification Nearshore Survey, or FINS, which is actually based at the River Institute. Here we just have a map to demonstrate the 5 river sections of the Upper St. Lawrence River. So they're highlighted in the different blues at the bottom. And then we have 3 different colored symbols to demonstrate the survey sites for the databases we found. So now I'll hand it over to Cristina to go over the results of our report.
Thank you, Mackenzie. So we'll start with the results for the Thousand Islands National Park data set. So as you can see, this is the river section, and all the green dots are the data observation. So this is a graph for the Thousand Islands. So as you can see, this is the round gobies per sites in function of years. So each point is the median for each site, the mean, sorry, for each site with a standard error, with a trend over the years. So overall, there's an increase in round goby abundance throughout the years. However, you see that this trend is actually non-linear, and you see an oscillating patterns with increase of round gobies followed by decrease. And you see that in the recent years, well, there's a tendency towards a decrease in the round goby abundance. So only the future surveys will tell us if this is actually a true decrease or not. Now, in terms of the data set for the Ministère des Forêts, de la Faune et des Parcs, so they do an extensive survey in the Quebec portion of Lake St. Francis. So you see here, all the red points are data observation. So the data is the round goby capture per unit effort according to 4 different years where they did the survey. So starting in 1996, 2004, 2009, and 2014. This is a box plot with the median here with the black line. So you see that there was no gobies captured in 1996 and 2004, and the first time they captured the goby was in 2009. So overall, there's an increase in round goby density from 1996 to 2009. However, there's no significant differences between 2009 and 2014. So that might indicate that the population is stable. And again, only the future years will tell us if this is actually stable or not, and if it's going to be increasing or decreasing in the future years. Finally, this is the results for the FINS data set. So the FINS data set actually includes the 5 river sections. So you can see the yellow triangles. These are the data observation. And since the FINS accrue samples from like April through October, we needed to include seasonality into our model, spatial effect as well, and look at each river section. So we did a general additive model in order to assess the trends over time. So this is the results for Thousand Islands. So this is a GAM graph with the partial effect of the year on the round goby density on the y-axis. So any positive numbers will be a positive effect, so an increase in the round goby density. Any negative number is a negative effect, so lower density, and you have the null effect here at 0. So for Thousand Islands, there was no significant trends detected. Same thing goes for Brockville, no significant trends for the FINS data. Next, it's Lake St. Lawrence, and you see there is actually for this section a significant trend, and this one is non-linear. So you see that from about 2015 all the way to 2018, it's a positive effect, so an increase in the density of the Rango B, followed by a decrease in the Rango B density. So this is like similar to an oscillating patterns that we saw in Thousand Islands. Next one is Cornwall. So we see again a similar pattern as in the Lake St. Lawrence, where we have an increase in the Rango B density starting in 2015 and a decrease in more recent years. Finally, for Lake St. Francis, using the FINS data, we see that there's no significant trends for the Rango B density over time. So the reason we think that maybe we see no significant trends in some of the river section is because the sampling efforts weren't not the same between the river sections. So maybe that's why in those sections with a little bit less sampling, we see no significant trends. This is the result for the spatial effect on the Rango B density. So this is really interesting. So the spatial effect is displayed by colors. So yellow colors means a positive effect, so higher density of gobies. Blue colors mean negative effect, so lower density of gobies. So when you look at the river downstream from upstream from downstream, there's a gradient in the Rango B density. So here you see that there is a higher density of gobies, and downstream you see there's lower density of gobies. We think we observe that because of the water chemistry in the river. So around here, you know, it's closer to Lake Ontario water with high connectivity, so the Rango B really thrive in that water. So maybe that's why we see a higher density. Whereas downstream, you know, we have influences of different water masses, so that can modify the connectivity, and perhaps the Rango B cannot thrive as best here, so lower density observed. So in summary, the Rango B is present in all 5 river sections, and overall there's an increase in the Rango B abundance, but that can vary according to the river sections. So recent years may indicate a decrease in the Rango B density or abundance, but you see there are oscillating patterns, and those patterns may be explained by different factors, including the boom and bust dynamics that we can observe in biological invasion, where the population will increase, reach a threshold, and then some individual will leave the population to, you know, go somewhere else, and then the population decreases afterwards. So to conclude, the Rango B is a really successful invasive species in the upper St. Lawrence River. We need to have long-term monitoring surveying each of the river section and have proper sampling effort to really better understand the trends in the Rango B population over the time and better understand those oscillating patterns that we observed in the data. And in general, you know, there's a need for better control over vectors of introductions, although there are some progress that were made in terms of the water ballast regulations. And finally, there's a need to develop effective tools in order to detect non-native species early in their invasion. So with that, I'd like to thank everyone and all the funders for the River Report and all the collaborators. Thank you.
Thank you so much, Cristina, for presenting with me today. We're really excited to see what comes for the River Report in the future and with all these indicators. Please visit the website if you haven't yet. Lots to come soon. Next, we have David Bruce Conn, a professor at Berry College One Health Center, and he's also an associate of invertebrate zoology at the Harvard University Museum of Corporate Zoology, and he will be presenting native and invasive freshwater snails in the St. Lawrence River watershed. Take it, Bruce.
Okay, thank you. I hope you can see my slides now.
Yeah, if you want to.
Okay. Okay, well, thank you very much for having me. It's a pleasure to be back here again. I enjoyed the symposium last year when I reported on some of our work with mosquitoes in the St. Lawrence River watershed, and now I'm talking about snails. You'll see that the thing that connects the two in terms of my own research is not just the organisms themselves, but the fact that both mosquitoes and snails are very important in transmitting various types of diseases to wildlife and to people. And so they have a lot of health implication as well as the environmental. Let me say, first of all, there are many collaborators I've worked with over the years on this. We've been working on this project since 1985. And the primary one who's been around since all the way back then is my wife, Denise. She's my primary collaborator. And so I do want to acknowledge her. What I want to do first is say, what are snails? What are freshwater snails? Why do we study them? Well, the freshwater snails are members of the phylum Mollusca. They're gastropods, as many biologists call them. Most freshwater species are herbivores, whereas you have a lot of carnivorous species in marine systems. Most freshwater species are herbivores. Some of them are scavengers, and some of them are detritivores. But they're very important members of the freshwater communities all around the world. Some of them are threatened due to their requirement for specific environments. Some of them, in fact, are endangered. But some of them, opposite of that, are very adaptable, and they're able to actually colonize new areas. And they become, similar to the last talk, they become invasive species. They can often outcompete native snails and can also interact negatively with other biota and change the new environment. The most important thing here, though, is that snails are the almost exclusive hosts for some serious pathogens called trematodes or diagenians or flukes, and those can be transmitted to humans, to domesticated animals, to wildlife, and as well as fish. And so we have a lot of interest in them there. As a result of that, they are very much a part of a relatively new movement in biology, which is an integrative science called One Health, where we understand that if you really want to understand the health of any particular thing, you must understand not only that thing like a human, if you're concerned with human health, you must be concerned with human health, but also the health of animals that we interact with, and also the entire ecosystem in which we both live. Well, again, our study has been going on for more than a quarter of a century. We've worked extensively throughout the St. Lawrence drainage area, and we've used a lot of different techniques. Probably most of our work is simply netting and hand picking from various types of bodies of water. But we also scrape substrates underneath the water. We also take boats out in the lower left and dredge the bottom to bring up whatever is there. Also, we've done some scuba diving to get things that can't be done in any other way. I think we've made 18 dives in the St. Lawrence River itself, looking for snails and other biota. And then we also use the navigational buoys that are in the seaway as a substrate that when they are put out of the water, we examine those for any mollusks that might be attached. Also, we take the material back to the laboratory where they have to be identified sometimes microscopically, as you see in the lower right. By the way, that's Denise, my wife, at the microscope there. And because there are actually several different schemes of taxonomy and naming and classification of these snails, we've settled on the internet-based mollusca base. So every binomial name that I give you in this will be based on that particular scheme. So just to summarize, in all of our work, we see that there's quite a diversity of snails in our freshwater systems throughout the St. Lawrence Valley. We have counted 26 different species. Among those, 22 are native to our area. 4, on the other hand, are invasive, and you can see those at the bottom. And so I'm not going to spend a lot of time with the native species, not that they're not important, of course. They're quite important, but it would take a full hour for me to go through all of those. They are very diverse in their life cycles and the way they live, what they eat, specifically where they live, and so on. But I am going to focus, because of the theme of this session being the idea of change, I'm going to focus on these invasive species that you see at the bottom. Before I do that, let me quickly show you from 1985 to 2022, where we were working just last summer. We've had all of these species that you see here, and I know you can't read all of this right now in this busy slide. The main thing I wanted to point out is in the green and the blue columns at the very right. These are the snails that we see actually in the St. Lawrence River itself, or in Lake Ontario, or the combination of those. These are snails then that like the water. waters, as opposed to those that like smaller pools, ponds, small tributary rivers, and so forth. You can see in the yellow stripe down the middle. Again, I'm not going to go into great detail about our native snails, but they are quite diverse and they are quite beautiful, as you can see from the shells alone. They have, again, various methods of feeding, of reproducing, and so forth. And so I'm going to go on and talk about the invasive species. But before I do that, I want to point out, this is a picture that I took actually 1 month ago in Poland. I was doing some work, as I also work a lot in Central Europe and in some other areas around the globe. Walked up to a pond, a small lake there in northern Poland a month ago, and just reached down in the water and picked out 4 different species of snails. Interestingly, all of these are native not only to Europe, but they're also native to North America, to Canada and the United States. So there's not a complete barrier, never has been. There has been a way for certain things to travel between the 2 continents for as long as we have known them. And so all 4 of these actually are native to both continents. It's those snails that are not native, that are native only to Europe and move to the US, or only to the US and move to Europe, or from Asia or Africa or whatever. Those are the ones we're especially concerned about. So the first invasive snail I want to talk about is a very common one, is a very pretty one actually, called Calanina georgiana. We have found this throughout the St. Lawrence region. It has become quite common over several decades. But unlike the other 3, which are exotic species from other continents, this is actually not from another continent. If you look at the map below, the orangish or amber color, that is the native range of these snails. So they are native to the southern United States. But the red range shows the invasive range. So throughout the Great Lakes area, both of Canada and the United States, I'm sorry, these maps are US Geological Survey maps, and so they don't show actually the Canadian distribution except in the lakes themselves. But you can see that they have pretty well colonized all of the St. Lawrence drainage all the way through the Great Lakes. Again, they're quite common, live in an environment similar to what you see on the left. This is a small river called the Little River in northern New York State, and they like weedy areas of emergent plants like this. Another one that we have not found as frequently, is one that has been restricted to the St. Lawrence River itself. This is called Valveda piscinalis. This one is the European valve snail. It was introduced some time ago, at least a few decades ago, and has not spread very far, but is common within the Great Lakes, some of the Great Lakes, as well as the St. Lawrence River, all the way out until you reach well below Montreal. And you can see the typical habitat where we find that attached to rocks right on the shores of the St. Lawrence River itself. Probably the most important ecologically is the European faucet snail, Bythenia tentaculata. This is a very important species because it has been here for well over 100 years, 150 years. It was introduced probably back in the 1870s. It has become very well established. It has outcompeted in many environments our native snails. And very importantly, it serves as a host for some of these parasites I was telling you about. And so it exists, as you can see again in the map, throughout the Great Lakes region and also in some other areas. Finally, the one that we're excited about right now in studying, we first found this in 1986, a single specimen in 1986 in northern New York State. It's called the Chinese mystery snail, Siphangopolludina chinensis. This was introduced not from Asia, not from Europe, but from Asia, and has done remarkably well. So we found our first specimen in 1986. Since then, we have found not only individual specimens, but the picture that you see at the left, that's the Grass River in northern New York State. And there were hundreds of these at that location. And we have found similar large populations in other places throughout the St. Lawrence Basin. It's a much larger snail, and you can see it has a much wider distribution in North America as its new home. Okay, so let's go beyond the snails and say that, again, one of the reasons, and perhaps the most important reason for being concerned about snails, is that they are the exclusive hosts for many of these trematode parasites. Some of these can cause some of the most important diseases of humans in the world. For example, schistosomiasis is a dreadful human disease that kills and sickens literally hundreds of millions of people, especially in tropical areas. Fortunately, we don't get those in the northern latitudes of the St. Lawrence, but we do get a related species or set of species, as you see on the left. These live in birds, and these things what are called cercarial dermatitis. They live in the birds defecate in the water, releasing the microscopic eggs. The eggs hatch and penetrate into a particular snail. And in that snail, they undergo explosive asexual reproduction and then change into another larval form that you see on the left there, on number 4. Those are called cercarii. Those normally would go back into a bird that's wading in the water, but they can go into the skin of people. Now, they don't really infect the people. They simply set up a terrible rash. It's like having poison sumac or poison ivy or something like that, a terrible rash that causes a lot of irritation and can cause a lot of destruction also in terms of bathing beaches. So bathing beaches along even the Great Lakes over the years have had to be closed because of the terrible outbreaks of cercarial dermatitis. On the right, in this graph, these are both from the Centers for Disease Control in the US, you have echinostomatids. There are several species that can live as adults in humans as well as various birds and mammals. The eggs pass out again. The larvae hatch and penetrate into aquatic snails, and those aquatic snails, the same cycle is seen, except that these have to make their way back into the human or the other animal through the diet. And the way they do that is they'll penetrate into another snail or into a frog or into a fish, and they will insist in the kidneys of those animals. And then when the heron or other water bird or human or whatever eats any of those particular organisms, the fish, the frog, or the snail, without cooking it, they become infected again with the parasite. So we have worked a lot with these over the years. This is a 2012 paper that we published. This was an international team, including both US and Canadian scientists. And we worked to look just at these exotic snails, the ones I've mentioned to you, as well as a couple of others, and as well as the invasive Asiatic clam at the very top, Corbicula fluminea, and also Dreissena-morpha, and Dreissena rosstriformis. These are the zebra mussels that most of you are familiar with. All of those bivalves can become infected with echinostoma, and also Valveda bicenalis can be. Also, Bithynia can become infected with Cyathocodali busiensis, as well as Spiridiotrema. And these have been known to cause major epizootics among waterfowl in both Canada and the United States, in some cases resulting in the deaths of hundreds of birds, migratory waterfowl. And they're quite a very important problem. So you have this life cycle again, where you have this particular worm. The worm, it can get over an inch long. You may have 50 of them in your intestine at the same time. You see that big crown of thorns. It uses those to literally work its head back and forth, raking away the lining of your intestine, and then using the sucker in the middle, suck up the dead cells that they have destroyed in your body. They're quite destructive in you. But they pass from your body. They infect the snail, as you see on the bottom part. And then from there, what we have here, this is the kidney of a frog in the St. Lawrence Valley that we collected from one of the wetlands. And almost every frog that you get in the St. Lawrence Valley wetlands, you will see all these little silver white balls. Each of those is the cyst stage of one of these parasitic worms. So that then when the bird comes along and eats that frog, it becomes infected again. Now, we have also found that these can invade zebra mussels. That's a different story that I won't go into in great detail here. But they will infect a wide range of hosts. The only commonality is that they always go into the kidney system.
Bruce, just letting you know we're a little over time, so if you can...
Good enough. So these are just, I'm just putting these up here to show you that these papers have been published. We've gone into a bit of detail with these organisms. And so the information is out there, and we continue to pursue it by looking more at the snails and the parasites that they hold. And really, that was the end of the talk. So thank you, merci, and I'll look forward to the question and answer session at the end.
Thank you so much, Bruce. All very interesting stuff. I did not know a lot of that. So thank you so much for sharing. Our last presentation is Bo-jian Chen. He is a postdoctoral fellow at Queen's University, and he's also been helping us out at the River Institute as a research scientist for the Great River Report. And he is presenting on establishing an integrated amphibian diversity monitoring toolset along the St. Lawrence River.
Hi. Thanks, Mackenzie, for the introduction. Good afternoon, everyone. My name is Bo-jian Chen. I'm a postdoc fellow cross-appointed between Queen's University and the River Institute. Today, I'm going to talk about an integrated amphibian diversity monitoring toolset that we've been working on. Humans have altered many aspects of the Earth's surface and released deep impacts, among which land use alteration and climate change have threatened the global ecosystem and lead to drastic biological losses. The WWF Living Planet Index, LPI, shows that an average of 69% decline in monitored animal populations. But freshwater index shows even more daunting biological diversity losses at 83%. Though covered less than 1% of the planet's surface, freshwater ecosystem hosts 1/3 of the Earth's vertebrate species. Among them, amphibians that normally live in the intersection area between terrestrial and aquatic habitats play a fundamental role in the good functioning of ecosystem. Sadly, the IUCN Red List Index showed that amphibians are deeply threatened by the environmental changes and are accelerating to an extinction crisis. There are many threats to these animals. Among them, habitat loss and climate change are the top ones. As shown from Wild Species 2015 of Canada, the survival pressure on amphibians in Ontario is really intense. Studies reports that over 90% of the original wetland has lost in southern Ontario, especially along the St. Lawrence River. This situation is extremely worrisome to amphibians because many of the threatened species live in a narrow band along the river corridor. Hence, the conservation on amphibians is urgent, but there are challenges. Normally, conservation planning and related land management needs substantial monitoring effort to provide knowledge on species distribution, abundance, and etc. However, due to the biological characteristics of amphibians, those vital information are hard to obtain and less understood, not to mention how these have changed and will change over time. The current standard monitoring method in Canada majorly followed the Marsh Monitoring Program protocol and focus on counting amphibian calls with supplementary visual identification. There are clear limitations in current monitoring. First, many amphibians such as salamanders do not make calls, and frog and toads only calls in narrow time period of the year. Hence, monitoring based on calling counts may miss a large part of their annual cycle and may be missing important parts of their critical habitat. Second, many amphibians live in swamps and marshlands that are really hard to enter, and counting calls require quite extensive labor because protocol states that each monitoring site requires at least 3 visits with 15 days apart. So large area monitoring needs intensive calibration between multiple organizations. In order to meet those challenges, we propose an integrated toolset to enhance current monitoring system and help amphibian conservation. Firstly, we utilize species distribution model, SDM, via Maxent, to estimate the relationship between species occurrence records at sites and the environmental and spatial characteristics of those sites to generate a distribution heat map, which provides prediction of species suitable habitats. Maxent is a program for modeling species distribution from present-only records. Its predicted performance is consistently competitive with the highest performing records. Then we apply detailed EDA assessment based on the heat map to examine species distribution in real time. In this part, depending on monitoring objective, we can apply either a species of concern monitoring or general biodiversity monitoring. The EDA results can provide feedback and used as validation to the SDM. And with continuous updates of species occurrence data and environmental data, the SDM can be adjusted to increase prediction accuracy. There are many merits of our toolset. Compared with traditional point-to-grid species distribution maps and expert draw maps, SDM show much more superior power in species occurrence range predictions. And follow-up EDA assessment could serve as independent validation, which covered the shortage of current SDM application. Since EDA analysis is focused on DNA, not calling signal, our toolset can broader species monitoring coverage, especially benefit cryptic salamander monitoring. Furthermore, studies suggest sediment to preserve DNA for a longer period of time. Hence, EDA sampling via sediment could provide longer monitoring time window. And in winter, We could even obtain good monitoring data from those sites we are unable to access in summer times. Plus, survey site design guided by SDM heat map could benefit survey efficiency and lower labor cost. Our toolset can be applied in multiple directions, such as conservation, research, and public outreach, as Mackenzie stated out, i.e. the River Report and citizen scientists. Given different choices on sediment layers, we can investigate either contemporary or historical diversity shifts. Our toolsite R&D plan have two phases. Firstly, we will establish single species monitoring ability using loop-mediated isothermal amplification, LAMP, qPCR, and droplet digital PCR, the ddPCR. Then, as model validation builds up, we will develop community diversity monitoring via metabolic coding. Here are some progress we made. To test for SDM, we gathered species occurrence data from Thousand Island National Park, Marsh Monitoring Program, and HIC, focusing on the Upper St. Lawrence River region, and we adopted the 10-kilometer buffer zone setting from several government reports. The current data at hand covered 10 frog and toad species and time span from 1980 to 2022. We selected chorus frog as focal species for the trial because it is well studied and our lab has established a traditional method for its monitoring, so it will be easier to cross-validate. And by far, its data is the most abundant at hand. For the environmental data, we included 19 climate variables and 8 land cover variables in the model. Let's see the heat map. The figure on the left is a traditional point-to-grid map we've made using only historical data. You can see the chorus frog distribution display is quite limited. The figure on the right showed suitable habitat prediction using SDM. Warmer color indicates higher habitat suitability. SDM can also provide rankings for important impact variables. In this case, we have 2 climate variables and 2 land cover variables on the list. The tricky one is wetland. From the response curve, we can see as wetland coverage increases, the occurrence of chorus frog decreases, which is weird for species normally live in wetlands. By checking our data input, we found the reason: sampling bias. We just don't have occurrence data from the southern side of the river where it has high wetland coverage. So, next step, we will broaden our study area. We have contacted the New York State Department of Environment Conservation, and they kindly agreed to share data with us within the 100-kilometer buffer from the river on the southern side. We also contacted NHIC for the same reason, for the northern side, and iNaturalist as well. Based on historical records, we found an amphibian hotspot near the River Institute, the Cooper Marsh. We are going to conduct ground truth tests on sediment DNA assessment in there. LAMP, qPCR, ddPCR, and metabolic coding are already presented by our lab mate Stafford, Oriane, and Alan yesterday. So if you want more information on that, you can reach out. And this is all for my talk. This project is new from our current research frame, so we are welcome for collaboration and support. And thank you for your attention.
Thank you so much, Bo-jian. This work is so important to be able to get accurate information about amphibians. So I'm excited to see what comes next for this. Yeah, so that's all for presentation. So we can go ahead and move into the question answer period. If anyone wants to add anything into the YouTube chat, I will check that right now. And we'll get the rest of our speakers in here as well. All right. So I do have a couple that I jotted down that I might start with Bruce. I know you went over like the human impacts, but in regards to the environment, particularly, what would you say the largest impact of invasive snails would be? I'm intrigued if you can think of it.
Well, you know, that's a great question, and it would really depend on what your priorities are. Some people, of course, are very concerned about its impact on the environment itself. For example, most of these are herbivores. They can have a big impact on especially benthic plants, emergent plants, as well as algae that they scrape from the rocks. So they have a role in the entire food structure of the ecosystem. Their impact on other snails, native snails, has been quite dramatic in some cases, Bythenia especially in smaller lakes, not the St. Lawrence or the Great Lakes themselves, but the smaller lakes surrounding in both Ontario, Quebec, as well as New York. They have actually caused great reduction of native populations. But probably in my account, I think some of the impact on health of wildlife, there's not a huge impact on the health of humans like there is in the tropics, but the impact on wildlife health is quite large, especially to waterfowl. So all of those things would be reasons why these can be very problematic.
Right. Okay, follow up, sorry. So would you say, I know like with invasive species, like removal of invasive species can be difficult. Would you say that's a path that could be taken for snails, or is it kind of just they're here to stay?
I think, as with most really successful invaders, I think they are here to stay. Yeah. That doesn't mean they're going to stay at the same levels, as you showed in your talk with the gobies. You know, they will have a crash or a reduction of their populations, just like the zebra mussels have. But they will still be here. Once they have become established, it's almost impossible to get rid of them. So we're better off focusing on trying to keep them from getting here in the first place. And then if we fail that, trying to just understand their impacts and trying to lessen or mitigate the impact rather than try to wipe them out altogether.
Right. Awesome. Okay, thanks, Bruce. Bo-jian, I have a question. Just checking the chat. Yeah. So I know you mentioned there's been 90% loss of wetlands. If you could say, what would be the most beneficial mechanism, like if we could, to bringing back amphibians through like wetland, either protection, or is there a way to actually bring wetlands back up? Would you know?
Recently, the publication suggests there being like a pond restoration, a massive reconstruction of wetlands in Switzerland or somewhere Sweden, some in Europe, and they show that amphibians do come back, and the decline trend of amphibians do like stop and even reverse in certain species. So restoration do helps with this. So even more, there are multiple threats posed on amphibians, but like a habitat restoration might be a more tangible one to help restore them, like in the shorter period of time.
Okay, awesome. I'm just looking. I think we had one question in regards to our presentation, Cristina. So they asked, are those same oscillating patterns of populations seen in other river fish species as well as the round goby? So I've been working a bit on some other of the fish species indicators, and the only one I can think of would be yellow perch. Their populations have gone up and down over time, which I'm sure a lot of fishermen have experienced. But this is most likely not due to the same boom and bust reason as Cristina had explained. It's more so due to the changes in phosphorus levels, other nutrients in the water over time, with changes in government policy, as well as changes in the fish harvest and pressures that way. So yeah, there are, but it would be different for the native species in comparison to invasive species in the river. Yeah, I'm trying to see if there's any others coming in. I know we cut you off a little bit early, Bruce. I don't know if you have anything else that you wanted to add about your presentation.
Oh, you didn't cut me off too early. I guess I rambled on a little bit too long. So no, I don't have anything else to say other than just to say that we are continuing this work. We'll be back up there on the river first week of January to do our annual buoy survey and look for the mollusks that we find on the buoys, and then again next summer for a more broad scale search. So we'll keep checking back in with you on this. It remains a very exciting project.
Awesome. I just got one from Matt Wendell. Great presentation, everyone. Tying together the presentations, I was wondering if the relationship between invasive goby predation on invasive gastropods trends is well understood.
So there are some research, especially from Tony Riccardi at McGill, who studied the impacts of the round goby on gastropods because it's one of their favorite foods. and they can really eat a lot of them. So the Durango bee do have an impact on those snail population. So that's what I know of the relationship between the gastropod and the Durango bee in the St. Lawrence River.
Awesome. Yeah, that's a really good question. I didn't even think about that, because I mean, they're both bad, but they might be counteracting. Well, Durango bee could counteract it a bit. Yeah, interesting question, Matt. Thank you. I have another one for Bruce here. We have heard a lot about eDNA techniques at this symposium. Are there some applications that come to the top of your mind for snail research?
Well, not right off the bat, but that's not an area of my strength. I do know there are a number of my friends across the globe that are actually starting to do that and are looking. There are many of these snails are rather cryptic. You don't see them very often. They're very difficult to get. As I mentioned, some of the ones that we collected, in fact, we only got either from scuba diving or occasionally dredging from a research vessel. And sometimes they are able to pick up species through some of their eDNA surveillance. So we'll see. I think that technology has not been around long enough to really know exactly how reliable it is for everything. But I think certainly it will be useful. If you look at, you go anywhere in the river, and one of the critical keystone groups of organisms in the benthos will be mollusks, not only the snails, but also the bivalves. Incidentally, speaking of Tony Riccardi, we've just published a paper together on the invasive Asiatic clam that has just come into the St. Lawrence area. I've been working with Tony on and off since I think 1995. And so, and we're both interested in some new unionid work in the river right now. So I personally don't plan to do any eDNA work, but I suppose others will.
Great, awesome. Yeah, it's definitely up and coming. We had a lot of presentations on eDNA, very interesting stuff. I got one more from Matt. Bruce, is there a guide you could recommend to the audience that could be readily used for people to help ID gastropods in the field? Do you have a go-to by chance?
Yes, there are some very good things. The best one probably is a major work released by the US EPA, and that's easily online. Just look for freshwater gastropods of North America. It covers both Canadian and US populations. It's a little old, so it will be outdated in terms of some of the invasives and some of the other things. Also, as with all areas of biology, I mentioned to you that we use mollusca-based classification. The reason I designated that is because there's a lot of disagreement among molluscan biologists, malacologists, a lot of disagreement about exactly where to draw the lines in classifying different species. So, but this one EPA guide, and there's some others, if somebody wanted to email me, I'd be happy to provide a list of references that they could use.
Awesome, thank you so much. I'm refreshing it here. It doesn't seem like there's any other questions. So unless anyone else has anything to add, we do have the names of all the speakers on the website. So if you wanted to reach out, you can get the emails there. And yeah, we're ending the session. If there's nothing else, thank you so much for coming today, everyone. You did amazing. And I believe we have a little break before the next session, which is inspiring the next generation.
Thank you.
Thank you.
and welcome back. We're into our fourth and final session of the day, and I have Emilie DeRochie, who's going to be the session chair, and she works with me at the River Institute, so it's very exciting. And our last session is inspiring the next generation, so I'll hand it over to Emilie. Go ahead, Emilie.
Thanks, Georgia. So my name is Emilie DeRochie, as Georgia mentioned, and I am an educator with the Great River Report Project at the River Institute and the River Strategy Coordinator. Our first presenter today is Danielle Delhaes, and she'll be speaking about biomimicry. So I will let her take it away.
Hello, Emilie. Hello, everyone. So, all right, let me see if I can share my screen with all of you. Share screen. There we go. All right, can someone just confirm that you are seeing my screen that says biomimicry, tapping into nature's genius to design regenerative solutions?
I can see it, Danielle.
Excellent. All right. Okay, so let's begin. So my name is Danielle Delhaes, and I am an education consultant. I specialize in sustainability and climate action. And for the last 3 decades, I've been dedicated to try to create opportunities for students and adults to mindfully engage as kin with the more than human world. And along my journey, I discovered biomimicry, and I received a training in biomimicry, which is a design approach. And quite simply, it changed my life, and it changed the nature and the depth of my relationship with nature. So I'm here to pique your curiosity and hopefully to entice you to start a journey in biomimicry learning yourself and share it with the youth around you, whether it be your students or your own children, wherever you come from to listen to me. And if you have any engagement with youth, I think that you will find this inspiring. So let's talk a little bit about biomimicry. So biomimicry is the conscious emulation or mimic, of course, imitation of nature's genius to create designs that serve our needs as humans, but that also create conditions that allow all life to thrive. In other words, that protect life. And so biomimicry is, of course, a design approach, but it can also be considered, because it's emerging, as a branch of science, and it's also a problem-solving method, and it's a movement, and it's a new way of viewing and valuing biodiversity. So digging into biomimicry and adopting this design approach, as I said, has the potential of changing your life. And so I want to tell you a little bit more about the aspect of why should we model life. So basically, organisms and ecosystems have been facing the same challenges that we do on this planet, for literally thousands and thousands of years, and they know how to meet these challenges sustainably. Nature has selected ways and designs on this planet that last and that are appropriate for the places where they exist. So ecosystems and organisms actually provide us with a lot of, it's kind of like a living library. They provide us with innovative solutions for our problems that relate to energy or food production, or the need for clean water, benign chemistry, information systems, packaging, and so much more. Everything is out there in nature. And in biomimicry, there are 3 ways of imitating nature or tapping into this wisdom. And one of them is by mimicking the form. So an example of that would be if we mimic, for example, the structure of the leaves of water lilies, which are naturally repellent without any chemical coating. Fabrics have been produced that have the same structure, and they can be water repellent without having to create a whole lot of chemical coating and waste. Which of course have a negative impact on the environment. And an example of a process, which is another way of mimicking nature and looking at how, like, what's a recipe to do something. So for example, software engineers designed a very efficient truck delivery system by looking at how ants forage for their food and communicate with each other to get that food and retrieve that food very efficiently. So by looking at the network that they have and how they do this, the process, they have actually designed a very efficient truck delivery system. And finally, we can mimic systems in nature. So a system that is more and more known now, and people talk more and more about this, is what we call the wood wide web that was put forth by Suzanne Simard. And this is when fungi actually help trees or network between trees so that trees can communicate. And then there are hub trees, the mother trees, that are really the central distribution system for resources and information. And so this has been mimicked, by students who wanted to shift a culture in their school with regards to the understanding of the importance of eating locally and urban agriculture and so on. And they wanted to really affect a change really very quickly. And so they mimicked that network of distribution of information in order to change the culture in their school and start basically an urban agriculture program. So these are different ways that we can mimic nature. So form, processes, and system. And basically the long-term vision is to actually create products and processes and organizations and policies, new ways of living that are really adapted on Earth for ourselves as humans, because obviously this is not what we have been doing. So biomimicry adheres to the principle that life creates conditions that are conducive to more life. And so the picture that I have here is a beaver pond. And as you know, beaver ponds are incredibly rich with biodiversity. And so this animal comes in and of course, dams a stream in many levels and creates this tier of, many tiers of ponds that attracts so much life. And so if we think of what the beaver does in creating its own habitat and fulfilling its own need, is that it's actually creating more life. And so as humans, we have this responsibility. We are part of living systems, and we need to find those same regenerative ways and practices to engage in the world. And so as Robin Wall-Kimmerer reminds us in her writings, we all have gifts, but we also have responsibilities that come with the gifts. And biomimicry is one way of engaging in nature in a regenerative way. So nature, when we think about biomimicry, is viewed as a model, a measure, and a mentor. And this is not new. This way of viewing nature has been around and has been used or adhered to by humans in the past, and particularly with Indigenous cultures. And so when we think of nature as a model, we think of nature as an inspiration for its wisdom, for its genius, for its biological intelligence. When we think of nature as a measure, nature has all of these life principles, such as the one about, being conducive to more life. And those life principles can be used as standards for design. In other words, we can go back to how nature does things and how nature adheres to these principles and question and compare our designs and make sure that they are not harmful to life and that they are regenerative. So there's a whole series of 10 different principles that exist and that have been identified that help us create regenerative designs. And when we think of using nature as a mentor, it's really about with a great deal of curiosity and humility, asking the question, what would nature do in front of the same challenge that we face? So by being so humble, when we interact with nature, we value nature, we see nature as a place of wisdom, and we engage with nature with reverence. And so biomimicry is about learning from nature as opposed to about nature. And this whole idea of respect and valuing nature is very important to biomimicry. It's also a practice that shifts the relationship that we have with nature, because with this approach, we are seeing ourselves and we're viewing humans as nature and part of the living systems. And biomimicry also deepens our understanding of our own place in nature and our kinship to the actual earth and all of its more than human creatures. So I'll give you a few examples of biomimicry design that have made it into this world. There are very many. And then I will also at the end share a great deal, quite a lot of resources for you to learn more about biomimicry after this short talk, which of course is just to pique your curiosity. So Whale Power Turbine designs fans and of course wind turbines. And as you can see, their wind turbine has the same design or ridged edge that the humpback whale has on its fins. And at first, the biomechanical engineer that looked at the whale thought, why is it not smooth? Because we all know that a smooth edge is far more efficient for lift and for, you know, the fluidity of the movement. And so by looking at this, they realize, and by testing it, they realize that this design is actually far more efficient. And so they are now designing with using the same mimicking what the whale has in terms of its shape, this form that it has. And this is really much more efficient. And so here's a win for nature by producing more energy and conserving energy as well. The company Infinite Cooling has looked at a beetle that lives in the desert, and it has a structure, the way that the wing is shaped on the outside. It actually captures fog and it trickles the water into its mouth, so that because it lives in the desert, of course, water is scarce and it has to find ways to collect this water. So since about 40% of the water that is used in the US is used for manufacturing in different sites and power plants, a lot of the water leaves these facilities as water vapor, and of course it's just lost in terms of a source of energy and the actual resource itself, the water. And so Infinite Cooling is now designing these towers where the water panels are shaped in the same way as the beetle, and the water can be totally recycled, and we have a closed loop system that saves millions of gallons of water as well as millions of dollars to these different companies that are using this technology. And a final example is hemp fiber that is being cleaned by natural processes of decomposition inspired by tidal stream. And this is done by Renaissance Fiber, and it has made hemp competitive price-wise because the degumming of the fiber was very expensive to do chemically. And so now, compared to synthetically produced fibers, it's back in the game in terms of its price, so that it can be competitive to produce this natural fiber that has now nearly a zero impact, because it also allows sequestering of carbon through the cleaning process. So those, I hope, are three inspiring examples. And I want to say, to end my presentation, that the practice of biomimicry really truly is transdisciplinary, and it actually can apply even to your own gardening practices, such as permaculture, for example. So it's pertinent to the work of everyone, from students and educators, engineers, scientists, artists, researchers, basically anyone who is committed to driving real changes in this world. And so what we need to remember is that we are all designers. We're designers of our own lives, and we're designers through all of the things that we do to interact with others and offer anything in this world. And so to feed your journey, and I hope you will begin one, if you want to learn more, I have this series of different links that I have prepared, and the link is in my bio on the website for this symposium. So you just have to look up Danielle Delhaes, and you will find the link to all of these resources that will allow you to learn more about biomimicry, practice it, go through the design steps. Ask Nature is an incredible library of all of everything that nature has to offer to solve the different problems that we have, and how is nature doing this. So I hope I have inspired you, and I look forward to your questions a little bit later on. Thank you, everyone.
Danielle, I look forward to exploring those resources a bit further. Next, we have Dr. Diz Glithero from the Canadian Ocean Literacy Coalition. I will pass it on to Diz.
Great. Thank you so much, Emily. And can you hear me okay?
We can, yeah.
Perfect. I'll go to share my screen now. And just give me a thumbs up if everything's looking okay here. Ready? Do we have full screen there? Good. Can someone just confirm that you can see my screen? Yeah, okay, great. Thank you so much. Well, good afternoon, everyone. It's such a pleasure to be here today and to be part of this year's symposium. It's my first time being part of the symposium, but very familiar with the work of the River Institute and an absolute delight to be here with all of you. I'd love to take the next 10-12 minutes to share with you more through the storytelling and some images, my journey over the last 20 years as an educator. Not an exhaustive journey I'll take you on, but just picking 3 or 4 moments, experience, and the lessons learned from those, and how those experiences and lessons have shaped the work that I do, and some of the reflections around, you know, how do we move from raising awareness and strengthening understanding and knowledge and engagement to fostering agency in the generation to really drive the kind of change we need. So I'd love to start out. It was about 20 years ago, first teaching job. I had done a science degree at Dalhousie University. You know, I grew up in Southern Ontario when I did an outdoor experiential education degree at Queen's University. And I wanted to have my first teaching experience, you know, in a place where I was mindful that as a white privileged person growing up in Southern Ontario, there was a lot about this country I did not know, and was not taught in schools or even in teachers' college. And I think it was essential to have even the potential of being a contributing educator is to really understand Canada's history, but also more importantly to explore, well, not more importantly, as importantly too, to really understand more of a place-based approach to learning. And so I had the privileged opportunity of working as an educator in Bella Bella in the Heiltsuk First Nation. And within days of arriving, it was pretty clear that the students, you know, the community became the teacher and I the student. And it was just an incredible opportunity to really understand and explore people's relationship with place and how that informs ways of knowing, ways of being, and to take that understanding forward in my teaching practice. And then after heading back to, you know, a few more years of teaching in the classroom, heading back to Queen's, where I explored a master's degree, I one day, 2002-03, listening to CBC radio on my Walkman, dating myself here, and heard this gentleman come on, and he's talking about this program called Students on Ice that he's trying to get up and off the ground. And ideally it was to catapult students of all ages to the ends of the earth, to the polar regions, and to have that firsthand experience to connect to nature in its full power, and in hoping that at the start of their lives, it would really transform their relationship and connection to nature. And so I went over to the payphone, picked up the phone, called this gentleman who was just speaking on the radio, and you know, was absolutely delighted to hear about this program from an experiential education point of view, and at the same time scratching my head as to, wow, the ecological footprint of this program would be, you know, equivalent to all education programs in Canada put together, and just to have that conversation together. And the gentleman, Jeff, was very gracious, said, come on up, have lunch. You know, 3 months later, I found myself in Antarctica. 1 year later, I found myself as the education director of Students on Ice. And 20 years later, he's my partner and we have 2 kids. So lesson 1, careful who you call. Lesson 2, the power of experiential education. There's just nothing like it. And I think for all the educators here in the room or community practitioners that work with people and community science that takes people out into the water, the rivers, getting hands wet, there's nothing like it, because it's that emotional, personal, visceral connection. And when we have that, then, you know, the mind and heart are activated. And that's where you start to, you know, have that not just strengthened understanding and knowledge, but that desire to contribute to change. And so that was really powerful. And just to give you a scale of, like, you know, a place like Antarctica, you step off the Zodiac, this is your site. You walk up a knoll a little later, this is your site. You keep on walking a little more, this is your site. So you experience something on a scale that literally catapults you to almost another planet. It's where nature is in a force it's incomprehensible to us living in urban centers. You know, another example looks like just the seagull eating your lunch here at the park, but when it lands beside you and an 11-foot wingspan wild wandering albatross stares you in the eye, it doesn't matter where you're from, what race, age, gender, you know, your background, lived experience, wherever you're from, that moment is transformative because you're staring into the eyes of another creature and very quickly and humbly realize you're just one of millions of species on the planet. It puts humans quickly in their place, and I think that's important. And just a quick story to wrap up kind of my experiences with Students on Ice is these were two students came from the Bronx in New York City. They had never left the Bronx. If you can imagine your first trip anywhere being Antarctica, I mean, several flights, sailing the Southern Ocean, one of the roughest in the world, getting to Antarctica, and just the opportunity to kind of stare out over, you know, where sea, sky, you know, all kind of blend together. And it was silent. So for any high school teachers out there, rare, two teenagers silent. So I take a seat maybe 100 feet behind them and listen, quiet, 10 minutes quiet, 20 minutes quiet. Finally, 30 minutes later, Malcolm turns around and like just tears, right? And said, you know, what's up? He said, it's the first time in my life I've ever heard silence. So how are you feeling? You know, because it's on one hand, someone could flick me off this ledge and it wouldn't matter. I'm so small and insignificant. But at that same moment, I realize I'm part of something bigger. And that line shared to me by this young gentleman in Antarctica has totally guided my work for a dozen years, I guess, since. And if there's ways that we can create as educators opportunities, you know, for people of all ages to feel that they're part of something bigger, that's where we'll get them. That's where there's a potential to really transform connection, relationship with place, behavior. And that led me to, basically that moment with Malcolm led me to doing a PhD and really exploring as an environmental educator, moving from, you know, some of the research and theoretical work done in civics education. How do we foster citizens that can drive change? Not just good citizens that are law-abiding, as important that is, but to the point where they become truly active democratic citizens. And what's that progression? And to then look at that, so that's kind of the bottom half, and to look at the top half, the same thing, because often as a student myself going through public education and as a teacher for years and years, like it was a lot about recycling programs or, you know, eco schools or opportunities where you would do things around stewardship. And all of that's important and needs to keep happening. But can we go further? Can we get to the point where we're cultivating agency? And what are the learning conditions that enable young people to actually foster and empower that sense of agency that makes them want to be active participants in society to drive change? And that became, you know, really the essence of the work I wanted to do as an educator. And the number one finding I found in my research is the incredible importance of youth-adult partnerships. That intergenerational learning and leadership, co-leadership and partnerships. Every young person who I met, that was one of the key elements. Quickly, I'll just jump ahead and just doing a quick time check here is another very privileged opportunity I had was in 2017 to serve as the education director of a 150-day expedition that ran around the entire coastline of Canada. And, you know, 25,000 kilometer journey. But what was really powerful is that all those narratives you hear, you know, we're the longest coastline in the world, 20%, you know, fresh water. We've got 30% of the boreal forest, 50% of our coastline is in the Arctic, 35% of the landmass is in the Arctic. And yet, how much does that really rest in our day-to-day kind of narrative and understanding of who we are as a country, part of our identity and culture? And so this journey became a real opportunity to explore some of those questions, getting to know the coastline better, getting to know the communities and the diverse people. And what it really struck home too, being 2017, the 150th anniversary, was for some, it was not a celebration at all. And for Indigenous communities, by the time we left Newfoundland all the way around the Arctic, the 4 Inuit settlement territories of Inuit Nunavut, and all the way down the Pacific Northwest coast down to Victoria, we're exclusively an Indigenous territory. And so you realize where the majority of us live in Southern Canada, like those ways of knowing and being and understanding and the concerns and the changes and everything that's happening, those stories aren't told as often as they need to. And the knowledge and expertise and wisdom from those communities and being on the front lines of understanding those changes and the solutions, the resiliency and innovative solutions that are already in practice. So it was an opportunity to share, to sit down in relationship, a people-centered approach to learning, a relationship-centered approach to learning, and to have those conversations to explore pathways forward. And of course, very unique and amazing opportunities to connect to the more than human world as we went. And the power of storytellers, artists, musicians, animators, helping to communicate the stories from the ship out to millions of Canadians. Because as good as scientists are, and I consider myself a social science researcher, we're not always the best communicators. There's people out there whose gift is to share those important messages and stories. And, the other just last thing I'll share about the Canada C3 journey, it was just an amazing scale of collaboration to watch scientists from so many universities coming together to co-design a shared science program, and also together with community members, experts on the ground, doing important community science and integrating that into questions that they would explore together and then communicate those findings out to other Canadians. It was just a really inspiring example of the scale of collaboration and partnership that can happen. And so the last story I'll just flip to, when we wrapped up C3 in 2017, I was left that question that kind of burning in for me was like, what is our civic responsibility as a country with the longest coastline? We're often called an ocean nation, but do the 30 million of us who live nowhere near the ocean feel that, breathe that every day? And that led me into my most recent work. In the last 4 years, I've been the national lead of the Canadian Ocean Literacy Coalition. And it started as a project to do a research-based understanding of what does the term ocean literacy mean in Canada? What are our connections to the ocean across these different regions and very diverse kind of cultural geographies and places? And who's doing what to foster that connection with Canadians to the ocean? And mindful that, again, for those 30 million Canadians living nowhere near the ocean, the connection point is water, waterways, watersheds, and to bring that into the conversation. And so from that national study in 2019-2020, we were able to celebrate the diversities, but also come together around shared priorities. And those priorities then helped us co-design and co-develop a national ocean literacy strategy that was launched in 2021, making Canada the first country in the world with a national ocean literacy strategy. And the exciting part was that is 2021 marked the start of the UN Ocean Decade. So here we were, kind of now a very collaborative, coordinated community that up until now is very fragmented and siloed, each doing good work, but not even aware of what each other was doing across regions, sectors, scales. Now working together with a shared framework of action and being able to now work within the context of a decade to really advance Canadians' understanding of the ocean, the waterways leading to it, the connection between ocean and climate, and just ways to create experiences and opportunities that allow Canadians to strengthen their understanding, value, and care for the ocean. And the last thing I'll just share is in June, one of the projects that's being advanced through the work of the national strategy is we launched Ocean Week Canada, and we being over 110 event hosts, over 20 content partners, over 750,000 Canadians who actively engaged in one of those events, and over 2.5 million that directly engaged through social media around the conversation of like, what is our responsibility and connection to the ocean, and how do we strengthen support for ocean conservation, and just that ethic of care that we have a responsibility for. And the last kind of message I'll just leave on is that it's interesting, whether my hat is ocean literacy or I work with folks around water literacy, climate literacy, science, nature literacy, ecological sustainability literacy, it doesn't really matter the term because we're all going in the same direction. We all want the same end goal to build a more just, sustainable, healthy future. And it's, as David Orr, one of my favorite environmental educators, said, hope is a verb with the sleeves rolled up. And it's a historic times where all hands on the deck. And the only way we're going to get there, no matter what slice of the puzzle we're working on, is together. And so partnerships, collaboration, coordinated action is absolutely essential. So thanks very much. Privileged to be a part of today's discussion, and I look forward to some questions. Thank you.
Thank you so much, Diz. I can't wait to explore more about your work. And I hope that in my career as an environmental educator that I can have even half of the amount of cool experiences that you have to date. We are on to our next speakers now. And these are some people I've had the pleasure of working with over the last quite a few years, actually. This is the River Institute's education team. So we have Cristina Charette, Alanna Akkermans, and Lexy Harquail. So let them take it away.
All right, everyone. I'm really happy to be here today with Alanna and Lexy, my colleagues, to talk about how environmental education can inspire the next generation at the River Institute. So first, I know you heard a lot about the River Institute in the past day, but I wanted to start the presentation and share with you about who we are and what we do. So we're a nonprofit organization that was established in 1994, and we have three major pillars at the River Institute. So research, education, and outreach. And we work around the St. Lawrence River. So the overall goal of our research is to help improve the health of the St. Lawrence River. So like you heard a lot of scientists yesterday and today, we have many areas of expertise, including water and sediment quality, fish physiology and population health. We offer also services in terms of taxonomy identification for invertebrates or phytoplankton, and we do spatial analysis with the drones, for example. We also have a really important community aspect at the River Institute. We present different events, including Science and Nature on Tap, which is a monthly speaker series where everyone come together to learn about different topics from different experts. There's also the Great River Report, which is an ecosystem health report of the Upper St. Lawrence River. It brings together science, community stories, Indigenous knowledge, and arts. And with all of those outreach events, we can reach thousands of community members every year. And finally, we have the most important part of the River Institute. I'm a little bit biased. It's the education team. So what's really cool and unique about the education at the River Institute is that we are all educators, but we also are all scientists specialized in different fields. So for example, we have Dr. Brian Hickey, who's our program leader. He's a bat biologist, and in the community he's known as the Batman, and students love to learn from him about bats. There's also Alanna, who's specialized in geology and geography and ecology, and Lexy, she has a background in geology and marine biology. In terms for myself, I'm the education coordinator. I'm also a PhD candidate working on an invasive species of fish in the St. Lawrence River. So we all share a love for nature. We love to share our excitement when we find cool fish or cool rocks in the river. And annually with our programs, we reach about 5,000 students, which is really great. We also, in 2019, I believe, we were awarded an award for science communications. I'm sorry. So for this presentation, the overall objective is to really demonstrate to you how experiential learning at the River Institute can engage youth of all ages. So Alanna will now present to you some examples of what we do in terms of education at the River Institute.
Thank you, Cristina. So our education programs give kids experiences that motivate them, encourage them, and also inspire them in our sciences. So our interactive science workshops are held either at the River Institute, at Cooper Marsh Conservation Area, and we also go into classrooms. Before COVID, we reached about 2,000 students a year. Then during COVID, we were doing virtual programs and we reached about 1,000 students. And now this year, we're increasing back to our pre-COVID numbers at around 2,000. So part of our solution to not being able to go into classrooms was to have our outside in program. We created lots of activities and learning materials for teachers and parents to download. We have 41 different activities on our website that are free to download. And during our online programming, we reached up to 77 different classrooms. So one of my favorite things that we offer as part of the education team are our summer camps. One of our summer camps is called Eco Friends. It's for kids aged 6 to 11. It's a week-long day camp. It gets them curious about science and engaged in nature. So during before COVID, it would be all throughout August. Then during COVID, we unfortunately weren't able to have Eco Friends. And then this year we brought it back, but we kind of did a hybrid version of it. And it really was a little bit more science-based, but next year we're really hoping that we'll be able to get them back doing the fun camp things like songs and different games. Then we also have our junior scientist camp. It's for kids aged 12 to 15. These kids get the opportunity to come for the first 2 weeks of July and be part of our real research that's happening. And they just jump in with whatever fieldwork we're doing during July. During COVID, we had to reduce our numbers, but kids were still able to come and be masked up and do some really cool research. But then this year, we were actually able to increase our numbers. We weren't at full capacity, but we were still able to have kids come along and play in the water and catch fish and do other cool things. Then we also do the Eastern Ontario Children's Water Festival. We have 3 different sites. We hold one in Cornwall at the River Institute, one in Castleman, and in the past years, we've done Spencerville. We reach over 1,000 elementary kids, and we have over 300 high school students that volunteer. During COVID, we held virtual versions of the festival, and we were able to hold the events that way. And then we also do different special events within the community. Like yesterday, we did our fish tank competition where we had high school students come and present case studies and try and compete for a little cash prize. We also collaborate with the Raisin region and the city of Cornwall to hold events within the region to reach out to the public. And now I'll pass it on to Lexy.
All right, hello everyone. I'm going to tell you guys a little bit about what we think makes our programs extra special. So one of the biggest things is that students are learning hands-on, whether it's the camps that they're coming to, the workshops that schools are attending at the River Institute, or the workshops that we're delivering in schools. We're trying to always encourage the students to be learning with their hands, and we think that it really gets them more engaged and more interested in the stuff that they're learning about, whether that's fish dissection or looking at invertebrates under a microscope or pulling in fish in the river. We think that's one of the best ways to get kids excited about what they're learning. Oh, I gotta go back over to my other screen to change the slide. So one of the other things that's really unique for students when they come to workshops and programs at the River Institute is that we do our best to overlap special events and special collaborations with workshops and camps to provide the youth with more opportunities to get to do things we think they otherwise wouldn't be able to. So the example we have on the slide right now is the Lampsilis, which is a collaboration with Université de Québec at Trois-Rivières, who were doing water sampling. Sylvia Rodriguez, who works at the River Institute and is also in school at UTKR, was sampling water quality in this region of the St. Lawrence River on the Lamsillis boat, and our junior scientists were actually able to participate in that by helping with the water sampling and ferrying those samples from the shore out to the boat, which we think was pretty cool. And so we try and maximize these unique opportunities for students to be able to participate in. And that's just one example of how they get to participate in real research. As Cristina mentioned earlier, all of the scientists on the education team have different specializations, but the most important thing is that we're all real scientists, and the kids are working directly with us on the research, the ongoing research at the River Institute. Here you can see some of the students who have participated in camps and workshops helping Cristina with her PhD research. And that's something that we include not only in those special events, special opportunities, but all of our regular workshops and camps that we offer. We're making sure that the kids are, using the same equipment we're using for sampling, and the data that they're collecting is contributing to the ongoing research at the River Institute. And so we really hope that all of these unique and real hands-on experiences that the students are getting at their time at the River Institute, that they're going to take that with them, that they're going to move on into post-secondary education in sciences, they're going to move on to careers in sciences, and they're going to take all of those skills that they've learned with them during their time at the River Institute and bring all those passions into post-secondary and their careers. And we've got some really wonderful, actually, examples, ongoing examples of those students. So the first photos are of Zachary Pilgrim, who started out as an Eco-Friends camp member, moved on to junior scientist camp, then was a volunteer on Christina's PhD, helping her collect data in the field, has been helping her process that data that we collected, and now is actually a co-op student with us, and we're super grateful to have him on board. Kate Schwartz also started out as an Eco-Friends camp member, has worked at the River Institute for many, many summers, and is now at Bishop's University, working at Bishop's University, pursuing her passions in science. And the last example is a little bit more of a biased one, but it is actually myself. I also attended camps at the River Institute as a kid. I did my co-op at the River Institute when I was in high school. I also attended the Rotary Adventures program, which is a collaboration between the River Institute and the Rotary Sunrise Club Cornwall. That's the photo on top there. That was one of the first places I got my passion for bats, which is probably my favorite thing to do at the Institute now. And the photo on the bottom is me continuing to do bat research with Dr. Hickey. That was actually from last summer. So as you can see, we really believe that the spark that the students get, that the youth get attending programs and workshops at the River Institute really carries them on to continue to be passionate about science later in life. So thank you all for listening, and that's us.
Awesome. Thank you so much to the education team at the River Institute. I'm smiling ear to ear. It's great to hear about the programs here at the symposium this year. And I know that you guys continue to inspire students every time they come to the River Institute, or that you make an appearance in their classroom. So it is now time for a question session from our audience. So if anybody has any questions at this time, we can take them now. And I will check to see what is going on in our YouTube. There's no questions yet, but I actually have a question for everyone here. What inspired you to get into environmental education? I know it's a hard question. I would have a hard time answering it.
Who goes first then?
I'll go first.
It's for everyone?
Yeah.
So my passion for science has been around for a really long time, obviously since I was a kid and attending camps. I've kind of always been interested in the science aspect of things, but the education component for me was more of an accident. I've done like a lot of volunteering and participated in a lot of leadership programs over the years that kind of just continue to build on my educational experience. with not deliberately. And so I kind of lucked out when I graduated from school and this position was open, and I had all that experience working with students and working in education and leadership and volunteering. And it just meant that I could kind of combine those two, my really great passion for science and my accidental experience in education together.
Awesome, thank you. Alanna, what about you?
I love that question, actually. Well, I grew up on a farm out in the country, so I've always just loved outdoors, and I always had an interest in science. And then as going through post-secondary, I worked at a lot of camps, and I felt like there was just kind of this disconnect between like my two passions of like working with kids and helping them grow as people and learn, and then also just all the cool science things that I love. And then last summer I worked at the River Institute as a summer student with Brian, and actually it was Lexy, Cristina, and Brian that really made me realize that that was something that I really should be doing, is environmental education. So yeah, now I'm here doing it. So yeah.
Awesome. What about you, Cristina?
Yeah, so for me, I grew up by the St. Lawrence River. So, you know, I grew up with a love for the river, just like watching what the fish were up to, just staring at the water. And also when I was younger, I used to love to pretend to be a teacher. Like I would like imagine like students in front of me and just like teach them some stuff. So I think it was like always in me. And also I used to love like to do like oral presentations in the elementary school. So it just really followed me. And when I started working at the River Institute 7 years ago, I just discovered that like it really makes me happy to share some of my knowledge with the students and see them how excited they would be to learn about a few things about fish. So I think that's how I got to work with students.
Cool, thank you. And Danielle, what about you?
Well, I think I can echo pretty much everyone's journey to environmental education, which is just merging a deep passion for nature that I've had my whole life. In fact, nature has been the central and focal point of most of my decisions in life. You know, where do I live? What kind of work do I do? You know, all of my activities, whether it be my hobbies or choice of partner, you know, like it's just, it really is very present in my life. And I just have a love for how rewarding and beautiful it is to see a human being expand his or her world and understanding of different worldviews and connection with nature and understanding his or her place in this world. So that I just find that immensely rewarding. So it just keeps me going.
Cool, thank you. And Diz, what about you?
Yeah, very, very much in line with everything that's been shared. Danielle at the end there used the word place. And I think for me, like growing up, I had the privileged opportunity of going to kids camp or spending time just with family on water, paddling and what have you. And it was where the world made sense to me. It's where that sense of place was strongest for me. So I always knew that some form of being in and you know, involving the natural world in what I do and the care for it would be part of it. And I think in terms of education I didn't aspire necessarily to be a teacher educator, and I've taken somewhat of a circuitous path, but I think it's for me, relationships are everything, like relationship with the national world, relationship with each other. So yeah, it's not surprising. I think that's where I've ended up, but.
Awesome, thank you. And we actually have a question now in the chat, and this one's for you, Diz. So you mentioned that it's a small amount of people in Canada that live on the coast. Do you have a number or percentage of people that make up that population that do live on the coast?
Put me on the spot. I did when we were wrapping up the national strategy and was leaning on statistics, Government Canada, and yeah, there was just over 30 million of Canada's at the time, like 37.9 million live nowhere near the coast, and kind of define like within several hundred kilometers or more away from the coast. So it was a fairly small percentage that live in coastal areas, and they consider within coastal areas within 100 kilometers.
Cool, thank you. And I think that's all for questions. There's some kind comments in the comment section that you can check out afterwards. So I encourage all the educators and the public who are watching right now to check out the resources that are available by these fantastic educators you see here on the screen. We're going to move on to part 2 of this session, and we will have Dr. Kirsten Martin and Dr. Joshua Anderson join us on the screen with their presentation.
Let's go ahead and share the screen. All right, hello everyone, and thank you for attending today's talk. I'm Dr. Kirsten Martin. I'm Associate Professor of Biology from the University of St. Joseph. And Josh, if you'd like to introduce yourself quickly.
Hi, everyone. Thank you all for coming, and thank you for having me. I'm Dr. Joshua Anderson. I'm a professor of English, assistant professor of English at the University of St. Joseph.
Great. So today we're going to be talking about a couple of projects that we've been running this semester, and really kind of highlighting not only the collaborative aspects. It's, I think, a really unique opportunity to see such connected yet often considered disparate disciplines working together for kind of a common theme. And the projects that we're going to be talking about today, focusing on today, are really under the theme of finding ways to empower the younger generation. And when I say younger, this is the college generation that we're talking about, but finding ways to really empower that generation to reflect on their experiences with their local landscapes in the effort to really help them foster a better connection to their landscapes. Because oftentimes they don't really have that connection. They're not really aware of what's going on. So to give you a little bit of geographic boundary as to where our projects are taking place, we are not in Canada. We're actually in the United States. We're in Connecticut, so the eastern coast. And as you can kind of see from the map on the right of the screen, Hartford's got the little star on it right in the middle. So our campus is just to the west of that. But the green shaded boundary that you see on the screen, that represents the Connecticut River watershed. So the Connecticut River obviously flows through Connecticut, but it has its start in Canada and then flows all the way down through many of the New England states before entering the Atlantic Ocean in Long Island Sound. And all of the projects, or most of the projects we're going to be talking about today, have their groundings within the Connecticut River watershed. And another really unique thing about this watershed, which you may not be aware of, is that the watershed is actually a national refuge, U.S. national refuge. It's called the Silvio Conti National Fish and Wildlife Refuge. And it is the only national fish and wildlife refuge in the entire U.S. And it's also unique in that it is a watershed-based refuge. So the entire area of the Connecticut River watershed is essentially in this refuge land. And hopefully we'll have a little bit of time maybe to mention, maybe in the Q&A, a special project that we're also collaborating on around the Conti Refuge. So I'm going to lead off our presentation talking about the specific project in this Lenses of the Land kind of group that I am actually in the process of finishing up this semester. And this project was embedded in one of my classes, so Biology 145, particularly the lab portion of Biology 145. And this is our aquatic science class. So this is a biology majors elective. And then it's also open to all other majors, and there's no prerequisites for this course. So anybody can take it. And a lot of students do choose to take this class for their required science elective with the lab. So here's a picture of my students from this semester looking very happy. It's their first time wearing waders, so they were thrilled with that experience. And I had biology majors, I had a communication major, and a number of accounting and business majors. So it was a quite varied bunch. And the focus of the lab portion, we only meet 4 times during the semester. So we do 4 all-day Saturday field trips. And each lab focused on a different type of habitat within the watershed. So we visited one urban location, which is the Park River watershed, very near to our campus, flows through the center of Hartford. And particularly, we looked at Trout Brook. Then we visited a rural habitat, Salmon Brook, which is on Holcomb Farm property in Granby, Connecticut. One suburban area, Scannick River watershed, which is north central, northeastern Connecticut. And then we traveled down to the coast, the shoreline, and visited ocean area in the Long Island Sound. So the purpose of this class, obviously it's a science class, so they learn about macroinvertebrates and how to monitor river conditions and erosions and everything you typically find in an aquatic science class. But what made this class really unique was that focus on trying to foster greater understanding and awareness amongst the students of their local landscapes. So our population at the university, it is fairly local. I'd say the vast majority of our students are from Connecticut, but most of those students really have never spent time in their local landscape. And most of them haven't even traveled around our state. And if you know anything about Connecticut, it's a very small state. I mean, you can go all the way across the state in probably under 2 hours. You can see the entire state. But a lot of these students, they haven't traveled much further than their own neighborhoods. So getting them out there, seeing these different parts of the state, seeing the connections. So the way that we did this was through art. So we got a grant this year to embed art activities into a science class. And these different art activities were all paired with some kind of a scientific observation skill. And the idea was that they would observe their environment through standard science, but then they would have to translate those observations and their feelings about the observations in their environment through various art. So I've included some images of the students working on their projects, as well as the various different medium that we use. So at Holcomb Farm, at Salmon Brook, we use wintergreen oil, a natural oil derivative, to transfer photocopied images of the landscape onto reclaimed board. And then they also created poetry, thanks to Dr. Anderson helping them out and generating some tree poems. They added those to their wood panels as well. Then we visited the Scannick River in north central Connecticut. We used the actual river water from that location to do suminagashi, which is a Japanese technique of paper marbling, floating various pigments on the top of the water surface. And then we used rice paper to make images right at the field location. So you can see images of students wearing waders and doing art at the same time. And then another lab, we were looking at land cover change in the various watersheds, how it's changed over the last 15 to 20 years. So they learned a little bit about GIS, how GIS works, and the applicability of GIS. And then they chose one of the GIS images from their assigned watershed. And they had to translate that image into an epoxy disc. We're mimicking stained glass here. And then they used recycled reclaimed glass pieces to represent the pixels on that GIS land cover map, again, to translate what they're seeing from the science into something in display. And then these will be made into a mobile. And then our final visit to Long Island Sound, we ended up our semester-long project. Students also had to complete nature journaling assignments throughout the semester where they'd reflect on each field trip, and then also they had to go out on their own time to different watersheds and write about their experiences. So they completed their nature journaling, and then we did cyanotype prints on canvases. So cyanotype is essentially solar pigment printing, and we visited 3 different habitats, so salt marsh, sandy beach, rocky shore, and they had to use found objects from each to make prints on the canvas. And all of these various art pieces will be put on display at the end of the semester, this semester during our reading day, which is a break before finals. And we'll have a student kind of gallery exhibit that'll be open for the community as well as alumni, because this project was actually supported by alumni donations to a grant fund. So we're going to invite the alumni back. And then they had to complete a pre-assessment before the lab began, and then a post-assessment essay at the ocean on the final day. And I was thinking, I'd get a lot of, we hate this, because the biology students were not into the art at all. So I was expecting all these reflective essays to come back as this was horrible, painful, evil experience, never to be repeated. But these little green text box I've been printed are actual statements from this semester's essays that students wrote, and it made my day. I can just say it literally made my day to read this, knowing that most of these students are the science majors that detest anything to do with art and humanities. And to get kind of this, and how much of it was about their connections to their landscapes being increased. So just an example, one example of a way we're trying to do this, and I think it was fairly successful for a first time through. So I'm going to turn it over to my colleague, Dr. Anderson, to talk about his project. Josh, you're muted.
Thank you, and I'll make this part quick. We'll move pretty quickly through this, but I am an English major. I have been paired with Dr. Martin on a number of these projects, and where we're taking this project is actually, we're in the midst of making a documentary in celebration of the 25th year of the Silvio Conti Fish and Wildlife National Refuge. When I'm teaching about rivers with my students, we always begin with trying to think about the indigenous history of the place and the ongoing history and storytelling of indigenous peoples in the place. As I always remind my students in Connecticut, the word Connecticut itself is an anglicized spelling of an Algonquin word with over 40 different phonetic spellings, and it means the long tidal river. So from that title on down, Connecticut is a kind of river state. So I also kind of want my students to be different kinds of ecological readers. And so I bring together native studies, environmental studies. So this is an image of the Park River in Hartford as it was being buried. And the question that I ask students is, what kinds of stories did we have to believe in order to give ourselves permission to bury a river? And we have lots of interesting conversations that come out of that. So that's something we're thinking about.
This meeting is being recorded.
I'm actually from rural North Dakota, interestingly from Park River, North Dakota, and now I teach in the Park River watershed in Connecticut. So I'm kind of a time traveler, like Mark Twain's character in a Connecticut Yankee in King Arthur's Court, who worked at the Colt factory, interestingly enough. And Samuel Colt, who developed the most iconic gun in the American West, did so from the banks of the Connecticut River, which he changed through dams and dikes. So I want students to kind of realize that palimpsest quality of history, the way that the West and the East in America are actually very tied together through this figure. And this is something we're also thinking about telling the story of. I'm also a horror scholar, and I can't help but think about the horror that we have in our city, in Hartford, with an underground river that once flowed through the backyard of Mark Twain and Harriet Beecher Stowe, and it now is completely underground, and most of my students don't know about it. As you see, this New York Times headline calls it Hartford's Scenic Sewer. And so this reputation is something we're trying to re-story in our projects. I'm also interested in origin stories. As you see here, we have the Charter Oak Bridge with this emblem of the Charter Oak that signifies the kind of origin story, the settler origin story of Connecticut. And so Samuel Colt was fascinated with this tree. I'm fascinated with his fascination in this tree and the way that we use these kinds of stories to try to kind of symbolize the river, make it a kind of meaning-making space. And then finally, this is a really complicated image that I wanted to end on, where we have Abraham Lincoln with Harriet Beecher Stowe, author of Uncle Tom's Cabin and resident of Hartford. And it's this immortalizing a moment in history where supposedly Lincoln said to Harriet Beecher Stowe, "So you're the little lady that started this big war," in reference to the Civil War. Right behind that, you see the riverfront recapture flag or a signage on the railing there, an effort to try to re-story the river through restoring relationship to the river. And in many ways, this is a layered image, getting us perhaps to think about who owns the river, what kinds of things, what kinds of stories are still possible at this river. And so that's where we're leaving things off. Thank you.
Thank you so much, Kirsten and Joshua. We'll move on to our next talk, which is Michèle Andrews from door number 1. Take it away, Michèle.
Thanks so much, Emily. It's a delight to be here with all of you. Such a wonderful array of speakers. And I didn't get to watch too many of the other ones earlier in the day, but that is my plan. So let me share my screen. I think that's working out. Yes, I am the executive director at door number 1. And I wanted to talk to you about a program that I started in the middle of the pandemic to try to engage schools in taking climate action. So you all know this iconic picture now of Greta Thunberg in the spring of 2018. And this was her alone starting her strikes. And this was her, you know, just a short year and a half later with millions of people around the world, young and old, movement. So this is the fall of 2019, not long before our pandemic began. So in the fall of 2019, while this was all going on, I happened to be presenting on behalf of a local community group to some mayors in Eastern Ontario. And I wanted them to declare a climate action plan, to declare an intention to create a climate action plan and to declare a climate emergency like hundreds and hundreds of municipalities around the country had been doing by then. And they had versions of no as their answer. I'll just to get right to the end of the story. But there was a train of conversation that went around this idea that they didn't want to scare the children. So again, this is the fall of 2019. Meanwhile, we're watching the youth striking all around the world because we're not taking action on the climate crisis. And, you know, if we don't want to scare the children, we should be taking action. That's kind of my answer. And I was very polite to this group of mayors, but I did make that point, among others. Anyway, so I have been working in education for a couple of decades, and I had the really wonderful fortune of being able to start this program, and it's called the Climate Action Accelerator Program. It's in its pilot phase. And it's the goal is to catalyze bold regenerative climate action across Canada's elementary and secondary schools. And what schools are doing is they are committing to working with my organization and with each other in a cohort group for 3 years to create and implement high impact whole school climate action plans. And when I say whole school, I'm talking about working across culture, learning classroom, learning outside the classroom, professional learning for anyone that works in the school, and as well all the physical aspects and school operations, so the building, the grounds, the purchasing policies, everything. So it's really truly a whole systems approach. And the schools each create a team, and there's at minimum there are 2 students, 1 teacher, 1 senior administrator, and 1 facilities person. Many of the schools have actually created teams of 10, 15 or more people. And they also have made a commitment to sharing their learning for everyone. So these are some of the themes that we're working on in this program. Certainly, there is no question that what we do now and before 2030 matters most, and that is our approach, is to really pushing them to think that way as they create their plans and their goals. We want them to be thinking about their literacy in the climate crisis and as well in the other intersecting social crises of our time. And as well in all the solutions that we know already exist that we can, if we scale up, we can really make a huge difference. Equity, this idea of climate justice and knowing that whatever solutions we have must lift everyone up and really ensure that those already suffering the most significant impacts are often the most vulnerable people, and that we need to help everyone thrive in the future world we're creating. Hope is a big conversation we have. We spend 10 or 15 minutes at the end of every session trading stories of hope, and we've had speakers on hope, and this is a really important thing, I think, for our generation and the next generation. And speaking of generation, a big theme is this idea of not talking about sustainability so much as talking about regenerative practices, or this regeneration movement. And so I want to tell you just for a moment a little bit more about this idea of regeneration, because it was new to me not that many years ago. So at one end of a spectrum or a continuum, there is this idea of conventional practices, and we all know what those are. They're the ones that pollute, destroy habitat, kill off life, and disproportionately affect those most vulnerable. We'll just call that the bad end of the spectrum. And then as we move along the spectrum, we have tried to be greener, and we'll put that in quotes, but often, unfortunately, green is just polluting less, but still polluting, using less energy, but still using energy, and using fossil fuel-based energy. You know, so it's moving along a continuum. And so we'll call that less bad. And then you get to the word sustainable, and sustainable is kind of, if you think about it, kind of holding us where we're at, or keeping things status quo. And it was William McDonough who wrote Cradle to Cradle that I think coined this term, that sustainable is really just 100% less bad. But given where we are, and given how much damage we've already done to our natural world, and our ability to live in the planet long term, and given the urgency and the timelines, really we need to be thinking at a whole other level, where we are healing, where we are improving health, where we are facilitating new life, and really creating a thriving life for all. And my colleague who works with me on this program, you heard from her earlier, Danielle Delhaes, she made this point as well. And that's being regenerative. So that's, what does good look like? So in each school to answer this question, what if each choice you made, each action you took, contributed to a thriving life for people and the rest of nature? And we are inviting them to look through that lens when they create their climate action plans. And that's a super hard question, right? And often, and there was an author named Peter Block who wrote a book that I'm going to tell you a really quick story about. And he, when we get stuck and we don't know how to do something, how to cross this incredible divide, how to be regenerative in our lives and in our practices at work and school and life, we sometimes just get frozen, and we don't know, and we wait for somebody to tell us, and we put it off because we're thinking, well, surely somebody will give me the answer. Surely somebody will give me the roadmap. Surely somebody will tell me how. And with these wicked problems that we face, often there isn't an answer or a roadmap. And really the answer to these most gnarly questions is to just say yes. And I love this about Peter Block in his book, is that's what he talks about. And so this is the other thing we talk about in our schools, is we don't have all the answers. They're joining this program, and we've put together a curriculum that's building capacity to figure out what we need to do. But we don't know, because humanity's never been in this place before. So I invite you to think about in your own practices, in your own lives, when you get stuck, especially on these big challenging problems we all face together these days, just say yes and go. And where better than a school? So, the ripple effect of a school is that, there are young people, there are students, children who are just yearning for inspiration and for guidance and leadership from their parents, their teachers, their adults around them. But the schools also have grandparents connected, they have neighbors, they have people that work there that aren't in the classroom, but are just as important and are part of this system. And so the ripple effect of turning a school into a place of climate action can really, really emanate out and have a wonderful ripple effect. Our theory of change is that if schools can build and implement strategic, audacious, hope-filled whole school climate action plans, where everyone and all parts of the school community become change makers, it can really make a difference and turn into sort of a contagious spread, if I may play on some pandemic language. It can be contagious and spread way beyond schools. And this hope and these regenerative practices can emanate into our businesses where our parents and grandparents of these schools work, and into the communities connected to these schools. And really that will just help us accelerate the transition that we must make to a just, beautiful, net zero and regenerated world. So my answer to the question about how to, really engage and inspire the next generation is to take a multi-generational approach. And one of our other panelists, Diz Glithero, was mentioning this idea about youth-adult partnerships. So that's what this is. It's just taking a community approach to learning together and to implementing plans that will make this transition. And in my program, I'm really excited. In the pilot phase, I have 18 schools in 5 provinces. They represent about over 10,000 students, and we have about 140 people learning together in these school teams that have been created. So we're excited to be learning. The intention and the commitment is that we will share our learning publicly for anyone. And we have a website that's here where if you were interested in seeing some of the resources, and hopefully soon we'll start to also be sharing stories from these schools. But right now there are resources we've created which are free and open for anyone to use. So that's our project, and our theme is movement to ignore, and I hope that you will check it out. Thank you.
Awesome. Thank you so much, Michèle. I really like what you said about where better than a school. I think that's the whole idea behind this education session today. So thank you for saying that. So up next, we have Todd Royer, who's also a part of Door Number 1 and is a former teacher at the Toronto Waldorf School. So I'll pass it on to you, Todd.
Thank you very much, and awesome presentation, Michèle. Good afternoon, everyone. My name is Todd Royer, and in the next 10 minutes, I'm going to try to kindle the fire of revolution. How successful I will be at the end of this brilliant and lovely symposium when everyone's certainly exhausted from listening by now. I don't know, but certainly it'll give you something to talk about over a pint later. We all know that we need to change. We have the burning platform, and climate change wasn't enough. Joe Biden announced 2 weeks ago that we're edging closer to nuclear Armageddon than any time since the Cuban Missile Crisis. Combined with all of the things we have to solve locally, we know that we have a lot to fix. When we talk about fixing things and engaging the next generation, it's to make real change to the whole kit and caboodle, not just to our local context. We have to make change across all sectors. The organizers of this symposium asked the question, how do we get there? Well, our elders point us in the right direction. Our scientific guru on the mountain, Albert Einstein, tells us the problems that exist in the world today cannot be solved by the level of thinking that created them. Elder Albert Marshall concurs. The air is polluted, he says. The water is polluted. The forests are no more. The animals are being extinct as we speak. And science is not going to save this. We need a change of attitude, a change of mindset. This is a call for us to take a leap forward in the evolution of human consciousness. Human beings are evolutionary beings, not only in our physicality, but in our conscious understanding of the nature of reality. That is why I have called this talk the Evolution Revolution, because we are the ones who need to change. We need to evolve in our thinking, our mindset, in order to transform the world around us. I also love the fact that the word evolution is contained in the word revolution. So we have evolved before, and certainly we can climb out of this slime again. So the revolutionary headquarters has to be the place where human consciousness is developed, expanded, deepened, transformed. Education has to be at its core. And we need a revolution because, as we all know, we don't have time to sit on our keisters and try to tweak our programming at the edges, or create a student committee here, or sprinkle sustainability objectives into our curriculum. Frankly, the impulse behind modern education has been part of the problem that has brought us to this juncture and has needed to change for decades. If I had more than 8 minutes, I would be happy to speak about this, but I'm on the clock and revolution is afoot. Now, I have not told you much about myself, and you might be wondering who I am to be spouting off like this in polite company. I've been privileged to work as a teacher and pedagogical director in an alternative school that is truly alternative and profound in its approach to education, the Waldorf school system. Waldorf is not a fly-by-night pop-up alternative school as you might find in a local strip mall. It is well tested in many cultures and across time. A quote that drew me to Waldorf nearly 30 years ago was from Willy Brandt, the former Chancellor of West Germany and Nobel Peace Laureate. He said, "The advent of Waldorf schools was, in my opinion, the greatest contribution to world peace and understanding of the century." So I've worked in Waldorf, with Waldorf schools for over 25 years. And I still share the same enthusiasm and conviction and believe they have many insights to contribute to the evolution revolution. And from this experience, I will share with you what I believe schools of the revolution will have. All the slides I'm going to share are from the public domain, and so are free to be shared. So I worked as in a K-12 school, primarily as a class teacher. A class teacher moves with their class from grade 1 to grade 8, teaching all the core subjects in which in the Waldorf curriculum includes math and algebra, geometry, history, writing, literacy, literature, physics, chemistry, human anatomy and physiology, zoology, botany, astronomy, geography, geology, life systems, drama, art, gardening, house building, and stories, including fairy and folk tales, fables, myths, legends, creation stories, biographies, etc. Having this 8-year long-term relationship has many benefits for families and children and is a great idea for the schools of the revolution. As you can see, the students are involved in creative work every day. The children are actively recording what they are learning, and they are learning to become more and more creative in how they express the content of their lessons. Subjects are taught in intense 3 to 4 week blocks, and the children routinely produce a main lesson book for each subject. The great value of this is that children have a real treasure trove at the end of their, grade 8 years, the span that I taught in. And they can look back on these grade 8 years and see how they have developed. When I had my parent-teacher interviews, I asked the children to bring in what they thought was their best main lesson book for each year. And we laid out the books from grade 1 to 8, and there before each child was a picture of their development from grade 1 all the way to grade 8. 5, 6, 7, and 8. And they were always awed by seeing their growth in front of them. And you could tell what was clicking in their mind was, if this is what I've done in the last 8 years, just imagine what I'll be able to do in the next 8 years. Now, beyond the main lesson books, there were other creative crafts the children learned throughout the grades. Woodwork began by going out into the woods and getting a branch from a tree, giving thanks to the tree, and then learning to carve. Handwork is taught in every grade using natural materials. If schools are lucky enough to have sheep, the students would have an intimate contact with the source of their wool for knitting. And such pride they take in their knitting. This is a quote from a Waldorf graduate. If you have experience of binding a book or knitting a sock, playing a recorder, then you feel that you can build a rocket ship or learn a software program you've never touched. It's not bravado, it's just quiet confidence. There's nothing you can't do. Why couldn't you? Why couldn't anybody? We need that kind of confidence today. The content of lessons is organized according to the unfolding of human consciousness that has been forged through a long history of evolution. And this is designed to flow from year to year. And this is a profound strength for children who are able to leverage what is happening to them inwardly to their understanding of the subject matter that's before them. There's a story that underscores this, and I must tell at least one story to be true to my Waldorf nature. It's a story in Zorba the Greek. Now, Zorba is this lusty fellow who enjoyed life and drank the world in through his pores. And one morning after a night of carousing, Zorba is walking down the beach, a little hungover, when he spots a butterfly drying its wings in the morning light. And Zorba is just enraptured that he gets to witness this wonderful miracle of nature. He stops and he's determined to watch the butterfly take flight. He waits and waits, but it takes so long. And he decides to help the butterfly along, puts it in his hand, and he breathes on it with his warm breath. The butterfly flaps its wings, but they only stick together. And in his horror, it crumples in his hand, and he watches helplessly as it dies. He said of that moment, "This was the greatest sin on my soul, for I disturbed the eternal rhythms of nature." The following slides show what we already know. Human beings think and perceive differently at different stages of their lives. Curriculum choices need to pay attention and honor the unfolding consciousness of the child forged through the eternal rhythms of evolution. They need to bring the right thing at the right time to avoid demanding activities from children that can cripple core capacities and weaken their global intelligence. In the provincial curriculum, electromagnetism is taught in grade 3. But in Waldorf, we teach it in grade 6, when the children are beginning to feel the forces of puberty surging through their veins. I can guarantee you that no grade 3 child will understand the forces of attraction and repulsion like a pubescent grade 6 student. Schools of the revolution would be wise to outlaw the colonial-based education where subjects are taught for political and/or economic agendas, and where our children are rushed off to market like hothouse peppers. So if we want our children to fall in love with nature and to know something about a healthy, robust, regenerative world, it would make sense that the schools where they spend their formative years would reflect this. The buildings and classrooms would be beautiful to signify the importance of what is happening there. The grounds would be lush and bursting with natural beauty, gardens, animals, forests. Students will tend gardens, cook meals together. They and their classmates enjoy what they've grown. They will tend flocks. Compost and manure. We will have encounters where nature becomes their teachers. The outdoor classroom will be just as, if not more important than the indoor classroom. And the schools of the revolution will be active in protecting and developing the child's senses. For it is through our senses that we engage with the world around us. A colleague of mine who was a remedial teacher once told me that living deeply in your senses is true religion. And it is true that falling in love with the world involves being able to know her. Schools of the revolution also will have child's play as a sacred activity. They will have the most amazing playgrounds. Children can escape the assault of screens and the adult world, engage in a world of imagination. Play is a profound educational force. And sometimes, the older you get to grow up and play at your job. Schools of the revolution will have traditions and celebrations and festivals that mark the changing of the seasons and teach us how to celebrate and give us opportunities to express gratitude and joy. Schools of the revolution will find awe and wonder in the curriculum. A work that actually reflects what we see in the world around us. Even in the cosmos. It is ironic that we are at a time when we desperately need people who can imagine a world different than the one we live in, but our education has spent virtually no time cultivating the capacity of imagination. The founder of Waldorf Education has said that our highest endeavor must be to develop free human beings who are able to impart for themselves, who are able themselves to impart purpose and direction to their lives. The need for imagination, a sense of truth, and a feeling of responsibility, these three forces are the very nerve of education. Schools of the revolution will learn to have as their highest goal the creation of healthy human beings. These will be the people who can form the world into what they know from their own experience. This is how we be the change that we want to see in the world. Viva la revolution. And thank you.
Awesome. Thank you very much, Todd. And this brings us to our last presentation of the day, and I will be doing this presentation today. So I will begin to share my screen. Thank you so much for staying with us to the end today. Get that going here. There we go. Okay. Awesome. So we can get started. So I am here today to present a brand new part of the Great River Report project, and these are education materials. So the River Institute has had education for a very long time, and the Great River Report thought it was time that we bring something to the education team that's unique to the Great River Report and all the relationships that we've made with unique individuals through our time in the project. So these materials aim to inspire change and is called the Changemakers series. So as I said at the beginning, my name is Emilie DeRochie, and I'm an educator with the Great River Report project and the current river strategy coordinator at the River Institute. I have a background in an undergraduate degree with environmental studies and a minor in biology and a Bachelor of Education where I became qualified to teach high school and middle school. I specifically have teachables in environmental science, geography, and biology. And I'm an Ontario certified teacher and also teach at the post-secondary level now at St. Lawrence College for the ETech program. So I've had an opportunity to work with students of all ages, which has been fantastic, and helped me to kind of develop these materials to work for students of all ages. Apologies, I have a bit of a jam here. There we go. So the Great River Report. So you've heard a lot about the River Report today. So this is an ecosystem health report that's focused on the Upper St. Lawrence River. And it's not just a report, we also work with the community, we have community stories and workshops and much more. And most recently, as I said, we have education materials. As I also mentioned, as you heard in the session earlier, we have an education team at the River Institute. There's lots of experiential learning that happens, whether it's dissections, working with aquatic macroinvertebrates, special events, working with artists like Christine Fitzgerald, or even online programs. So it's time that the Great River Report provides some materials that relate to the work that we're doing too. So that brings us to the Changemakers series. So the goal of this series is to increase youth that connect with nature and increase the interest and careers in the field of environmental science. The overarching goal, though, is for students to learn that anyone can be a change maker. It doesn't matter how old you are, where you're from, or anything. You can be a change maker if you put your mind to it. So the Great River Report's change makers. Currently, we have 6 change makers. You can see them pictured here, and we're going to meet them all a little bit today. So what this is a cross-curricular case study that is complemented by a learning activity that is unique to the changemaker. And these are made for grades 7 to 12. So these case study stories have a few unique components to them, one of which are unique subheadings throughout the story. So this is to keep students on track and understand the context. So each case study has an introduction, get to know the changemaker, a short biography, their background, and then their change-making actions. This is followed by a unique subheading about their work. So in this case, for the example on the screen, we have butterfly migration. This is followed by a conclusion where we talk about the changemaker's hopes for the future as a changemaker. These case study stories also include keywords and definitions. So if you look at the example on the screen here, you'll see that there's bolded terms throughout the story. These are our keywords. And on the side, you can see where we define them or describe different organizations in which our changemaker is involved with, such as the Toronto Entomologist Association. Each case study also has Indigenous art as a part of it, and this is a part of the Thanksgiving address in which the Great River Report is framed. Finally, students become the changemaker themselves after learning about a specific person. So educators are provided with free access to these materials where they can bring the changemaker into, well, not the changemaker, bring the materials into the classroom and facilitate these case studies and learning activities with their students to be the changemaker. So it's time to meet our changemakers. Up first, we have Cristina Enright, and the title of her story is The Butterfly Effect. So Cristina advocates for monarch butterflies and caterpillars, as well as milkweed. And something special about Cristina is that she was hosting a workshop for the Great River Report, and I attended this workshop. And while I was sitting and listening to her speak about her work, I was thinking to myself, wow, how could I be a changemaker like Cristina? Like, this is some fantastic work. And then I thought to myself, well, I'll use the best tool that I have in my toolbox, and that is education. So Cristina actually kind of gave rise to the Changemaker series. So this is an example of Cristina's layout. So you can see we have a title page with the title, her name, and a beautiful photograph by Stephanie Hildebrand from the Great River Report team. We have the art by Victoria Ransom, and then we have photos throughout, and we tried to make this layout look more like a magazine to make it more interesting for students. Then we have our learning activity. So after the case study, educators will be given discussion prompts to give their students. After that, there's usually a video to get students to engage more with this individual's work. In this case for Cristina, it's a video from the Great River Report workshop, which inspired the whole series. And the unique learning activity for Cristina is for students to go out into their yard or their schoolyard and find an organism, maybe a plant or a bug that interests them. So the idea is for them to research that organism just like Cristina did. You can read all about it. And then report what they find about this organism. And when I say the word report, I like to use that term lightly, in that we want students to share their findings in a way that suits them best or that they're interested in. So maybe they're going to share their report in the form of a TikTok, a video, a podcast. Maybe they actually want to write a report. So when we use the term report throughout this presentation, we just mean to share what they learned or the results. Our next changemaker is Kat Kavna. She is the founder of Water Rangers, which is an organization that is a not-for-profit that aims to make water testing accessible. So they have these amazing water testing kits that are available for purchase, and you can go out and test the water near you. And the title of her case study is Water You Designing. This is the example of Kat Kavna's layout. Again, we have beautiful photographs by Stephanie Hildebrand. These photos here were taken this summer. And you can see where we explain some terms about what Water Rangers is. And then we have the learning activity. So for Kat, there's actually two options. And this is because she has these fantastic water testing kits with Water Rangers. But I understand that not all educators have these in their classrooms yet. So we have a water testing and report option. And then we have option 2, which is likely best for grade 10 and up, which is a mini aqua hacking innovation challenge. So Water Rangers came to be because Kat entered the Aqua Hacking Innovation Challenge back in 2015 and won. So the whole idea is for students to put STEM and science and engineering together and address the freshwater crisis. As well, If students want to share what they do with CAT, you can hashtag GRR Changemaker Series, as you see here on the screen, and we'll share these posts with our changemakers. Next, we have Philip Ling, and the title of his case study is Powered by Nature. So Philip Ling is the owner of the Maitland Tower site, which is located in Maitland on the St. Lawrence River. So this is a historical site that he hopes to restore ecologically and make a space for the community. He's also a part of the organization Door Number One, which you've heard from some fantastic people today. This is an example of his layout. So we have our photo, the art by Victoria Ransom, and our fantastic layout with a variety of different keywords, and of course, photographs from a gathering. So Phil's learning activity is unique in that I was inspired by an event that I attended at the Maitland Tower site. I'm actually in this photo with a group of people here, and this is the Dirty Paws kickoff day. So that's what they're calling the project of restoring the Maitland Tower site. So we all came together from different organizations and discussed what the future of this site could be. So the idea is for students to be given a stakeholder or rights holder that was present on that day and propose what the future of this site could be in that individual's lens. So they'll be given their discussion prompts to think about the changemaker, a video, which is in development right now, which shows the site, and students will explore the site via story maps as well. Students will collaborate and then share the results with the class of what they think the site should be. And again, we encourage you to use the hashtag GRR Changemaker Series to share what your students come up with, because Philip Ling would love to see what your students have. As well, reach out to us and perhaps you can even visit the site. Our next changemaker is Lawrence Gunther. He is North America's only blind professional angler, and he is the founder of Bluefish Canada, which aims to protect the health of Canada's water and wild fish stocks. The title of his case study is Fishing for Change. He also runs 2 different podcast series, Bluefish Radio, which is a part of Bluefish Canada, and Outdoors with Lawrence Gunther. So Lawrence shares a lot of change-making messages through his podcasts. This is an example of his layout. And we went actually and met Lawrence and his family on the ice this past winter to take these photographs, which was really fun. So this is an example of what educators would maybe download whenever they use these activities in their class. In this case, we have a podcast primer, which Lawrence actually created, because for his learning activity, students will create a podcast with a change-making message. We encourage educators to alter what that message should be. Perhaps you want to address a social issue, climate change, or maybe you also want to address fish stocks and water health. And you can see here, we also provide rubrics for educators if you want to perhaps assess students on their learning activities. So that brings us to our 2 last current change makers. So they're still in development. We have Jessica Shenandoah, who works for the Thompson Island Cultural Camp. So she engages Indigenous youth with their culture, and she's also fantastic at identifying medicinal plants. Then we have Stephanie Hildebrand, and you may have heard her name already today. So she works at the River Institute, and she's so gifted in being able to make people care about a message through visual communications. So they're still in development, so there's more info to come on them very soon. Okay, so I told you about these materials. Hopefully you're excited to check them out. How can you access them? You can access them very soon. They will be free. We're very excited to share them. So they will begin to be released in January. So once a month, starting in January, a changemaker case study and learning activity will be released. So you can keep track and find out when they're released by following our Great River Report newsletter. Follow our River Institute social media channels, so our Facebook, our Instagram, our Twitter. You can also reach out to my Twitter at Miss_DeRochie. You can also email me if you'd like me to send you an email when they're released. And please use the hashtag GRR, as in Great River Report Changemaker Series, to let us know that you're engaging with these materials in any way. That's all the time we have for today. Thank you for staying with us to the very end, and we will start our question period. So I'm not yet seeing any questions in the chat. But I want to say thank you to everyone that joined us in this session. I took some notes while you were all speaking, and I think we're all working towards a shared goal of engaging students of all ages with the environment to care for our future. I'm watching the chat here. Excellent. So if there's no questions, I'll just leave on the note of please reach out to any of us if you'd like to engage more with our resources, our websites, or ask us any questions. We'd love to hear from you. Oh, we have actually a question here. So I was just asked if I want to add any change makers to the series. So yes, I do. We actually hope to reach up to 10 change makers, and we have a few fantastic individuals in mind. And if you can think of any fantastic people that engage with the environment in a unique way that's making change, please reach out to me, and I'd love to potentially make a case study about them. Okay, I think that's all the questions. I think I will pass it back to Georgia now. Again, thank you all for coming, and we hope that you will inspire the next generation at home today too.
Great, so that was all of our speakers for our second day of the symposium. Thank you for joining us. I'd like to thank all of our presenters, our boothers yesterday, the participants, you for joining us, our sponsors, to the symposium committee. It took a big team of River Institute people and some contractors to pull this off, so thank you very much. The producers, we had KEV in yesterday. Thank you so much, Kevin. Zach for doing all the tech for the River Institute, and Emma and Mackenzie and a bunch of the people behind the scenes that helped pull this off. Natasha, who helped with our website development. And of course, my co-coordinator, Emilie DeRochie, thank you for helping this. And Lee, thank you for helping oversee everything. So with that, I just thank you so much for joining our 29th symposium. And I think I'll just leave it with Travis Cole to close us out. Thank you for coming, Travis, and I'll leave it up to you.
Thank you. Be closing with the Ohana Gully Wadekwa. Agwagwaska did what when noon now going to go on that you know a lot of snap and quite sure get the now going to go. Agwagwaska did what when noon now going to go on that you know a lot of snap. You get me star with your Tony Dog now going to go. Agwagwaska did what when noon now going to go on that you know a lot of snap. When I got suit on Tony Dog now going to go. Agwagwaska did what when noon now going to go on that you know a lot of snap. Could you suit on Tony Dog now going to go. Agwagwaska did what when noon now going to go on that you know a lot of snap. On that suit on Tony Dog now going to go. Agwagwaska did what when noon now going to go on that you know a lot of snap. On the quite suit on Tony Dog now going to go. Agwagwaska did what when noon now going to go on that you know a lot of snap. Until that suit on Tony Dog now going to go. Agwagwaska did what when noon now going to go on that you know a lot of snap. Kaya tuso Tony Dog now going to go. Agwagwaska did what when noon now going to go on that you know a lot of snap. Kaya suit on Tony Dog now going to go. Agwagwaska did what when noon now going to go on that you know a lot of snap. But you know what suit on Tony Dog now going to go. Agwagwaska did what when noon now going to do now going to go on that you know a lot of snap. Condilio Tony Duck, now going to go. Agora Gasca de Doha Nuni, now going to go to the Tinoladas there, Ugula Sua. Tony Duck, now going to go. Agora Gasca de Doha Nuni, now going to go to the Tinoladas there, but you don't go. Tony Duck, now going to go. Agora Gasca de Doha Nuni, now going to go to the Tinoladas there, but the Wellas. Tony Duck, now going to go. Agora Gasca de Doha Nuni, now going to go to the Tinoladas there, Gaeli Nicolage. Tony Duck, now going to go. Agora Gasca de Doha Nuni, now going to go to the Tinoladas there, but you do a G on Gibke Neka Galakwa. Tony Duck, now going to go. Agora Gasca de Doha Nuni, now going to go to the Tinoladas there, Yuki Sita Asita Neka Galakwa. Tony Duck, now going to go. Agora Gasca de Doha Nuni, now going to go to the Tinoladas there, but you stuck what Sua. Tony Duck, now going to go. Agora Gasca de Doha Nuni, now going to go to the Tinoladas there, Gaeli Neo Guedige. Tony Duck, now going to go. Agora Gasca de Doha Nuni, now going to go to the Tinoladas there, Zuguan Dizzle. Tony Duck, now going to go. Thanks for having me, guys. That's the end of it, and have a good one.